Good morning, everybody. Hello. Can everybody come in here, please? We're starting. So, hi. My name's Bob Summerwill. I am the Executive Director of the Ethereum Classic Cooperative. I am a Vancouver native, so welcome to my hometown. Thank you. Vancouver represent. I have been part of the broader... Hey, it's Donald. I've been part of the broader Ethereum community since 2014, when I first met Vitalik here in Vancouver. In 2015, I was in Toronto and took advantage of the largest sort of meetup scene there and really went down the rabbit hole. So I was a speaker at ETC Summit in Korea last September, invited there by Anthony, the former director of the co-op. After I had met him in Toronto at EdCon, where he had been invited by Virgil Griffith there of the foundation. So we have a chain of people who have led to these events that finally culminated in me being asked if I would become the executive director and continue the quest to really build these bridges and to get Classic back to where it should be. So one of the main achievements that we've had this year has been the Atlantis hard fork, which happened in September, where Ethereum Classic added the Byzantium opcodes. So Classic had been a long way behind Ethereum on protocol, and we finally got all of the ETC tribes aligned, and we moved forward. It was not easy, Atlantis. We had some fights, we had some disagreements and misalignments, but we got there, and I think that what we've established there, which Afri here, our hard fork coordinator, had a very large part in doing, was that we've established a working model. You know, we have a functional ECIP process for moving things forward, and you know, we know the drill, so we're going to do it again. Something else that's happened recently, which is very personally exciting to me, is Hyperledger Bizu. So what happened there is that the Pantheon code base, which has been built by Pegasus, which is the consensus protocol engineering team, they contributed their code base into Hyperledger. So what you have there for the very first time is something that I was personally trying to achieve myself with a C++ client in 2016, which was getting a mainnet compatible Ethereum client that could also be used for permissioned enterprise scenarios under the Hyperledger banner. So Hyperledger, for anyone who doesn't know, is the Linux Foundation's umbrella for open source blockchain projects. And Bizu is the first of those, which is a public chain one. All of the previous ones have only been permissioned, but Bizu is both. So it's a Java code base, it's got Apache licensing, it's got Linux Foundation governance, it's got an world-class team from Consensus, some of the best distributed systems, cryptographer, Java experts in the world who have built this thing, for 2 years and then basically granted it to the world, given it into that collective governance where the several hundred major companies that are part of Hyperledger can contribute to that. And also, we can contribute. Anyone can contribute. You don't even have to be a Hyperledger member. So the very first thing that is happening within that Hyperledger governance for that code base is the addition of ETC support. So the cooperative is providing funding to ChainSafe to do that work. And that's the very first thing that's going to happen under that Hyperledger banner, is that we are going to have a code base there which can run Ethereum or Ethereum Classic or Clique or IBFT or any of a whole range of things, and privacy mode and all sorts. It's a dream scenario, and we're part of it. And what that gives us is more client diversity, but without that client diversity coming, from a commercial entity that you're having to think, well, what are the motivations? So I think, Besu is going to become a very major client moving forward. You don't have to join Hyperledger to contribute to Hyperledger code bases, but we are anyway. So the cooperative have applied to join Hyperledger, and I anticipate that that's going to complete within the next few weeks. The other thing that we're doing is applying to join the Enterprise Ethereum Alliance. That should also be approved within a few weeks. Now, again, my timeline here was that I was trying to get the C++ client relicensed when I worked at the Ethereum Foundation. When that failed, I joined Consensus and spent a year working on getting the Enterprise Ethereum Alliance launched. So I was the co-lead architect during the build-up phase. Then I was the secretary for the technical working group. Then I was the vice chair for the technical steering committee. A lot of that work was actually very parallel with the work that happened on Pantheon, because the other co-lead architect was Shahan, who's the co-founder of Pegasus, who built this code base. As we were going through that process of setting up the Enterprise Ethereum Alliance, with the difference being that Hyperledger is a banner for open source projects, EEA is a standards body that's trying to define a specification for saying, what does an enterprise-grade Ethereum client look like? Which is essentially a superset of public Ethereum plus permissioning, privacy, and so on. Also, the EEA and the EF, the foundation and the EEA, they were quite at loggerheads when it started. But they're working together now. So something which has just been announced, and there will be more detail of next week at DevCon in Japan, is a thing that they're running within the EEA called the Mainnet Initiative, where they are really, as should have been happening from the very start, looking to apply the resources of those enterprises to a cleaner, better definition of the public network itself for Ethereum. And I want to participate in that, because really, it shouldn't just be the ETH network. It should be all Ethereums. A problem that we had in the specification work for the EEA is that the yellow paper and so on sort of assumes you've only got one network. There are all these implicit assumptions that are tied to block numbers and things in the spec. So really, you want a modular yellow paper, which would say this is what the Ethereum protocol, and here are some specific instances. So that's the sort of stuff I think that we can get to by participating in the EEA, is really get to a better specification for the Ethereum stack, as my friend Boris Mann would say, and that particular chain IDs and so on, those can easily be part of that. The other thing that I've done only in the last few days, actually, I kind of went a bit crazy with it and just piled in, was that we've had this long-standing issue to do with the website. So one of the things that Anthony did in his time at the co-op was make a beautiful-looking new website, which is what was ethereumclassic.org. But that's a WordPress site, which means changes to it have to go through an administrator. So that was Anthony, and then it was passed to me, and then I just didn't do it, because I've been busy doing everything else. And I'm sure that that was much the same for Anthony. In his time was, oh, can you add a link here? Can you make this tweak here? Ugh. So what I decided, really, and I kind of did, and nobody seemed to object, was go back to the old website. So the old website was just a simple GitHub sort of setup. Anyone could submit changes. Here you go, pull requests, review, commit, and then automated builds push the thing up. So what I've done is fancied up the old one so it doesn't look crap. But then both me and various other people have piled in to update the links to make it, not be bad. And we're already nearly there. So, that where it is as usable really as what we had on the WordPress. Maybe a few things still need pulling across, but we can do it. We can get there. And then the other bonus that's happened, which I completely didn't realize, is that a guy has turned up who did the original website. So Dax, the pseudonymous Dax, who actually made the initial website, is here and wants to help. He wants to help us not ruin his website. Because I have been a little bit brutal, and I maybe haven't been doing things great. So if we have someone that knows the web tech, fantastic. And then the other thing that Yaz was telling me is that Don Xiang, who is the guy who did the graphic design for the summit today, he wants to help as well. So brilliant. We're in this position where anyone can contribute the content. Designers want to come in and do stuff, they can. Anyone can contribute. We're in a position where we can do it together. There are no barriers of only certain people being allowed. It's not entirely permissionless, it is permissioned. But the permission is that a good change or not? Yes, I press the button, we're done. The other thing that I've suggested through conversations with Christian Zhu is I came to realize that a lot of the East-West communication coordination difficulties that we have are to do with the firewall. So if you are in China, you basically can't do VPNs anymore, and that's quite a recent thing. You used to kind of be able to get away with it. Not anymore. They're basically illegal, with very small caveats. So Christian told me, if he is sitting in his office in China, he's got a VPN, usually, it might be a bit dodgy, but usually he can do that. If he's out of the office, if he's home, if he's traveling somewhere, no access. So that means he can't get to Twitter, he can't get to Discord, and those are our primary communication mechanisms. So he's cut off. If he's traveling in other countries, if he's in Korea or in Japan, he's fine. So what we see on the other side is, Christian, sometimes you just can't get hold. He doesn't answer anything. He's useless. What's going on? Totally not the case. It's a complete technical problem. But he didn't explicitly say it, and nobody, until I asked, cared enough to try and work out what was actually happening. So what's happening is that. So what I'm suggesting is, well, what we need to do is, as I say here, I've made a WeChat group. You've got to use WeChat. Everyone has to use WeChat. That's the only way to, for that to work globally. So I've made a channel, ETC Global Communications. Purpose of this channel, to bridge the East-West communications gap, we need a medium that works behind the Great Firewall. That is WeChat. Christian tells me he only has VPN access at the office, or when outside of China, it's not an issue, which means that Twitter and Discord are useless. We need to use WeChat, and then we can have good global communication. Beyond just China, we need to be connected for communications with community leaders in other Asian countries, and also in Germany, Italy, France, etc. So what I'm proposing, now that we have this website development working, where everyone can contribute, there's a caveat to that, everyone. Not people in China, yet. Both because of VPN issues, but also just, this is an English language site only. The Chinese, there's two main Chinese groups. And they have their own different sites with different information on them. So we're pouring all of this value into trying to have, canonical good information to point everyone at. That isn't the same information that you get in China. So what we can do, and what I'm proposing is, firstly, we coordinate, so we've got those communication channels with WeChat, and secondly, we just add proper localization into this website, like a normal website that professional people build. Multi-language support in websites is not a weird thing. We should be able to do that, and especially if the guy that made the website is helping us. So we can do that, and that's the plan. I want to work with all groups in any country that would like to have localized versions of this official website. So for China, there you go, that's nice and easy. But A.S, a community member, has already volunteered to help with German and Russian. And I'm sure there will be people in France and Italy and in Spanish communities everywhere who would like to have a workflow where they can have a localized version of this website. If new content is added in English, you'll see it in English until somebody has done a translation into their language, and then that can be replaced. This is a very simple kind of website flow. And I think that just by these few simple steps, we can really unify or build a lot of understanding between the East and West by having communication channels that work so that people can reply to you. I mean, subject to time zones, obviously, that's always a pain, but, not, oh God, someone hasn't replied for weeks. And secondly, by having this potential to say, if you just want vanilla, the basic information, just do your translations in here, job done. If you want to have your own website for culturally specific things, your own meetup details, things that you're like, nobody globally really cares about this, great, do that as well. But at the moment, that's meant the actual basic information on the platform also ends up in that bucket, and it ends up being different and out of date. And, things as simple as, well, when are we, when's the hard fork happening? We get, miscommunication on that. And it's like, how can you possibly not do that? It's in the ESIPs, it's very clear. Yeah, but the ESIPs are in GitHub, and that's behind a VPN. So, anyway. Another thing I'm really happy to announce is that the cooperative has just signed a contract with Masari. So Masari, for anyone who doesn't know, are basically providing high-quality information on coin projects, sort of like an Edgar ratings kind of thing. The idea being that investor types, institutions who are seeking high-quality information on particular projects, have got a curated data view, metrics view onto a project. Now, something that Dean Pappas was raising just the other day in his podcast was, if you look at stats in various places, they will say, Ethereum Classic is dead. There's no developer activity. Look, there's nothing. They're not doing anything. Well, that's because they're looking in the wrong place, or they're not looking in enough places, because the setup that there is in Ethereum Classic, and it is the same in Ethereum as well, is quite different to many other projects. Lots of projects are kind of effectively centralized. They have a foundation that raises the money. They have one development team, and they have one code base, and they're all in the same place. So you point at that, there you go, that's your truth. That's not the truth for Ethereum and Ethereum Classic, where by design there have been multiple clients from the very start. It was true actually for Ethereum at the very, very start until 2016, because really all of the development was done and funded by the foundation, though there were multiple clients. You had Go Ethereum, you had CPP Ethereum, you had Pi Ethereum, and so on, and they were all in that same repo. That ceased to be true when Parity were formed, because all of a sudden Parity's off in Parity Tech. And what you have on Ethereum Classic is now even broader, because you have ETC Labs Core doing Classic Geth, you have Multi-Geth off in its own place, you have Parity off in its own place. As and when our IOHK friends return to the fold, we will have Mantis in another place. Now we have Bisu in another place. And we also had, the Ethereum project, Ethereum Classic debacle, which may be resolved today, but not yet. Anyway, what we'll have with Messari is basically a questionnaire, gathering all of that information, that going to their researchers, and then them building this curated view onto ECC, which will take account of all of that complexity, and gather information on, sort of DApp usage, adoption metrics, and so on. And the other thing that Messari does is really transparency and financial disclosures, things which are very close to my heart. I've been maintaining since November 2017 a very extensive conflicts of interest statement where I disclose all of my salaries for every job I have ever had, all of the associations I've had in my professional life, my crypto holdings. So just yesterday, for example, I bought some more ETC because it looks very cheap to me. So nobody can accuse me of being a bag holder, having hidden interests, anything. I am an open book, and I would like the cooperative to be just the same. And we're very close to that. We have had these half-yearly reports that have been, reporting on our incomings, our spending, and we'll have even more of that moving forward because we are now a non-profit in the US. We are actually a public charity, believe it or not. That's actually the designation. So if there are any US people here, if you would like to donate money to the cooperative, that's actually a tax-deductible event with the IRS. So please do that. But as part of that, we have to do a filing, which is basically saying this is what we're doing to maintain that status, which is showing what activities are you doing and what are you spending, and are you basically still worthy of that designation? Are you using your money responsibly and fulfilling the goals that you said? So as part of that, again, there will be more of that kind of disclosure, which is very similar to what we have already, but in a structured form. And again, that's going to go into Messari. So what you're going to see in Messari is a very transparent view of both the network itself and the activity on that and the entities that are engaged in the ecosystem. So IOHK and Labs will also be participating in that Messari thing. They're both private organizations, so they're obviously not going to disclose anywhere near the same level, but they'll be in there. So anyway, in conclusion, I'm delighted to be part of the Ethereum Classic ecosystem, and we are really on a roll. I would say we are almost rampant right now, and I really foresee a situation where, in a very short number of months, I really do truly believe that ETC is not going to have been, not just going to be caught up with Ethereum, but it will actually be further along, that the protocol will be objectively better than ETH, that we will have some additional features, small features, that we will not have the bloat, that we will not have the irregular state transition, and also that we're going to be in a position where we have a supportive setup in terms of funding, because this has been a huge problem on the F1 side, that essentially it's been defunded since 2017. And, you know, good people have been trying to make it better, no money. Well, guess what? You know, ETC care. And really what's being built in ETC is really the original Web3 vision, you know, because we still believe, and we're going to do it. So there we go. Now I'll pass you over to Anthony, my predecessor, who's going to give us a talk about the state of Ethereum Classic. Thank you.
All right, is my microphone on? Yep. Okay, so my name's Anthony Lusardi. Bob actually already gave a better intro of myself than I could have given, so you now know who I am. I'm the former director of the ETC Cooperative, and I'm currently working on my own startup, but I won't bore you with that. I'll get down to talking about the state of Ethereum Classic.
What's your startup?
I can talk about it later if anybody's interested. So anyway, ETC actually started off the year with what a lot of people thought was an absolute catastrophe, the 51% attack. Essentially what had happened, and we were actually writing about this and trying to talk to exchanges before, telling them your security model for trusting different proof-of-work networks isn't correct and you need to adjust it. Unfortunately, a lot of exchanges didn't listen then and decided not to. So the ETC network had a couple 51% attacks that affected a couple small exchanges, but otherwise the network itself just kept on chugging along. When 51% attacks happen, they really only happen to those receiving payment. They don't really happen to the network itself. The network itself resolves itself over time. And that's the type of thing we were trying to communicate to the exchanges prior to this happening, was that you need to give the network time to resolve itself to reach a final state. And they just weren't doing that. And very oddly, I don't understand what happened in this 51% attack, but the attackers had returned most of what they stole to the exchanges they stole it from. So if anybody's interested in doing any data analysis out there or looking at the chain back then, I have a ton of logs, and if anybody's interested, please reach out to me, because the entire thing was bizarre. And also, just FYI, I've included emojis so that if you're not familiar with any of these things, you know exactly what to feel on each of these slides. So on this one, though, we can be nice and happy because ETC got a new testnet called Kadi. That was essentially where, on the Ethereum side, there were a lot of developers trying to bridge the parity and Geth proof of authority testnets, because POA is much nicer to use than POW for testing out your smart contracts. They had some difficulty finding funding, and so ETC Cooperative stepped up and helped out with that. And in exchange, we got a great testnet now, and Ethereum also got the Goerli testnet, which I know is also doing very well. So go try it out. If you're writing smart contracts, it's basically the testnet to use. You shouldn't use the other one unless you're actually working on updating the network. And then on the opposite end, ETC's GitHub was taken from the original owners, and the original owners would still like it back. I hear that there may be some sort of resolution coming from Bob. We'll see. This is actually really interesting too, because there was never just one GitHub. You know, we have others. Now we have Ethereum Classic, ETH_Classic, ETC Labs Core, and I'm sure there's some others out there that all represent ETC. And Bob actually talked about this before when he was saying Messari goes to one GitHub and can't find everything. It's because ETC has this very distributed network. Essentially, when ETC started, and a lot of people who have left ETC and joined ETC, they all work towards this vision of no one entity has control of all the kind of somewhat centralized components that are built around this network. And so when this happened, a lot of people were upset. Some people are still a little unhappy with it. But when it happened, the network itself actually stayed very resilient because there's no one group that can ever unilaterally make a change on ETC or gain control of the whole network, which I think is really great. Really shows how anti-fragile ETC really is, despite its relatively small size in the space. And then, we also were working with the Ethereum Foundation, especially back when I was at the ETC Cooperative, and I'm looking forward to hearing what new things come out. But I think we've started a great friendship, as Bob said. Virgil invited me to EdCon, then I invited Bob to the ETC Summit, and I'm sure somebody here from the Ethereum side will get them to continue that chain. And it's really been great too, because a lot of people, when they hear about working together, they say, oh, the chains can't work together. We can't sing Kumbaya around the campfire and just, kind of hold hands and sing songs when we don't agree with each other politically and even technically sometimes. But the fact of the matter is there are occasions where working together just makes a lot of sense, especially when it's something purely technical. So where I hope to see ETC working together more, again, is on those things where the things we're working on are simply things that benefit everybody. We don't want a situation where one side is benefiting more than the other. And I personally think that when it comes to the non-technical parts, the politics of ETC and other blockchains, it's really a great opportunity to export those to groups that otherwise would have remained very insular and not seen the other side and other opinions. So really happy to see that we've done some great work with the Ethereum Foundation and really hoping to see more in the future. And then we had the Atlantis hard fork. Bob already touched on this quite a bit, but it brought ETC's opcodes to Ethereum's opcodes to ETC. And it's just improving the dev workflow. I'm somebody who works on smart contracts, so it's nice to have tools that just work out of the box, and now they just work out of the box, which is always just great. And lastly, I'm just giving a very short talk here, but we have a lot of builders. ETC Labs are starting on their second cohort, which have more companies than I can keep track of, so I apologize for not mentioning you guys. We have ChainSafe, Ethernode, and others that are all building cool tools. We have Afri now, who does a lot of management for Parity, but now is helping out with managing a lot of ETC releases, and we're really, really lucky to have Afri. Just him alone is a great addition to ETC. And we have Wei Tang, who I hope I'm pronouncing his name right. He works on Multigeth and proves how similar these networks are. Multigeth is just a small patch to Ethereum's Geth that makes it work on ETC and other networks. And it's crazy to think that we each had to maintain our own for so long when these networks are so similar that you can just patch Geth to work on ETC. And also out of ETC Labs, getting a lot of cool new dev tools, Pristine, Jade Suite, and my own favorite, OpenRPC, which is just a nicer way to interact with RPC APIs, kind of get schemas for RPC APIs, which is really cool. And yeah, so that's my talk. I'm more than happy to answer any questions if anybody has any now, or if you want to stop me later and talk to me, I'm more than happy to. But that's the present state of ETC, and I'm sure you're going to hear a lot more in detail about all those components and much more over the course of the next 2 days. Thank you.
Nice one. So next up is the one and only Donald McIntyre, Token Hash, our very own toxic gentleman, who I'd say is the philosopher of ETC. Donald does fantastic blog posts under etherplan.com, often looking at really a larger scale kind of views of what's going on. And I'm delighted that he's agreed to come. He did drop out And then Yaz and I and others strong-armed him for a very long time, and he finally agreed to come back. So we're delighted he's here.
Donald for president.
I quit like 6 times already, I think. I'm old, so I need to use special glasses. Everything's working. Hi, I'm Donald McIntyre, ETC volunteer, and I'm going to talk about what I see as the Ethereum Classic principles, vision, and opportunities. I have written about these topics on my blog, etherplan.com. So this is a summary of those writings since the last ETC summit. Principles. I'm going to put this here. This is Homo sapiens in the last 200,000 years previous to sapiens. It is very likely that Homo erectus was using stone tools as money, respected property, and other clans and tribes in the form of territory, and had implicit and explicit agreements with other clans and tribes for various functions, such as hunting spaces, access to water, a primitive form of division of labor, and other conflict minimization strategies. Sapiens very likely use the same, albeit more advanced forms of money, property, and interclan agreements to make their expansion even more efficient and scalable. In the last 12,000 years, the emergence of formally protected basic rights through law was the result of agglutination in population centers. Civilizations needed further development of language, counting methods, writing, religion, and legal systems. These cultural advances affirmed the technologies of money and further delineated property and agreements. Our expansion and population growth, combined with more efficient tools and basic rights protections, such as money, property, and agreements, enabled long-distance platforms such as the Silk Road. The Silk Road was a decentralized cross-border commercial system that enabled increased specialization across regions and cultures using emergent communication strategies, such as the price system, for signaling supply and demand states along the different links of the decentralized value chain. This has been a steady pattern to the present day, where the species has grown to over 7.7 billion people. The above is a live image of marine shipping, which is part of a global commercial system that trades over $19 trillion per year. However, this commerce is primarily agreed, performed, settled, and adjudicated through trusted third parties. This not only implies a large cost and risk, but also the absence of trade that would otherwise exist were it not for socially unscalable centralized platforms. The natural next step are trust-minimized blockchains, such as Ethereum Classic. ETC is the emergence of a new system of money and formally protected basic rights, such as property and agreements, but this time through secure cryptographic protocols. The key of Ethereum Classic is its security through sound design choices, such as proof of work as the consensus mechanism, Turing completeness to provide generalized functionality in a safe environment, and a fixed monetary policy to protect property rights that, and ensure that users can count on a reliable store of value and medium of exchange. However, these basic rights and features can only be guaranteed only if the most strict principles are followed. For this, ETC has shown to have, still has, and will continue to have, for the foreseeable future, a strong culture of security through strong principles. Each of these principles has a specific function in guaranteeing sound money, property, and agreements on the platform, even in the absence of higher authorities, which is precisely the desired state of affairs. However, strong principles sometimes can present apparent contradictions. For example, there is something I call the permissionless fallacy, which is the idea that because blockchains are permissionless, that means that anything can be done, even if it undermines permissionlessness. Of course, that must be wrong, because if it were true, ETC would cease to exist. Just like free markets, money, property, and agreements require strong underlying systems, permissionlessness has to be protected by the ecosystem. The correct argument is that because blockchains are permissionless, anything that undermines permissionlessness must be stopped. This brings me to a delicate issue in secure blockchain ecosystems. Toxicity. In systems that seek to dissolve top-down leadership and governance, to uphold etiquette and diplomacy is a security hole. Is the security hole. What is regarded as toxicity is a function of free speech, the level playing field the internet creates, and the absence of top-down governance that I mentioned before. With no top-down governance, the only way of protecting blockchain integrity in the social layer is to have symmetry between players with capital, developers, and intellectual power, relative to regular people who may not count with those resources, but who many times are right. A way of looking at what is seen as toxic behavior in the blockchain industry is to regard it as a permanent state of alert, online activism, and public protest, but without the risk of violence. And it works. If not just see all the times ETC should have died, but it's alive and will in fact be critical infrastructure in the future. Vision. So what is ETC in layman's terms? It is a decentralized computing system that hosts programs, data, and has a processing capacity. The difference with your personal computer or using remote cloud services is that ETC is a remote computing peer-to-peer system, which makes it trust minimized and decentralized. The system has six components that make it work, and combined, they can power decentralized applications, machine-to-machine interactions, smart contracts between people and businesses, and its currency that can be used as a store of value, which is also perfectly a legitimate use case for ETC. Yes, ETC is money. ETC has a unique positioning in the highest value niche in the industry. Proof of work plus Turing completeness plus fixed monetary policy. If you think about it, after Ethereum moves to Ethereum 2.0, ETC will be the only trust minimized, permissionless, and immutable proof of work smart contracts platform in the world. Such strategy is very important because there are three forces that will shape the future landscape of the blockchain industry, and ETC is very well positioned for that future. The format war will narrow the large amount of blockchains in existence today to a very few in the future. Layering will divide the industry between security versus performance, where secure proof-of-work systems will be the base layer, or L1, and scalable proof-of-stake systems will be layer 2. Systemic risks means that even if highly secure, all blockchains, including Bitcoin, still have some IT, operational, social layer, and thus generalized systemic risks. Because people will naturally tend to diversify these risks, the Bitcoin maximalist view is incorrect. It's very likely that there will be several systems at the base layer, not only one. My prediction is there will be 3 or 4 winning blockchains at the base layer, and all other systems will operate on top. The base layer is going to be like an global operating system. If my hypothesis is right, I think a reasonable guesstimate is that the ones that will prevail at the base layer will have approximately this distribution, where Bitcoin will have the lion's share with 50%, and ETC will be second with somewhere around 25%. So in this context, what relationship can Ethereum and ETC have? To answer this question, it is worth looking at the differences between Ethereum and ETC. when Ethereum migrates to Ethereum 2.0. As it can be seen in the table, both Ethereum 2.0 and ETC have are smart contracts platforms and each have a native cryptocurrency. ETC has decided, based on a high security strategy, to stay with proof of work, a fixed monetary policy, and full replication. And Ethereum 2.0 has chosen to pursue a high performance strategy going with proof of stake, a variable monetary policy, and sharding. So if ETC is not as scalable, but very secure, and Ethereum 2.0 is very scalable, but not as secure, what is a good strategy for both to follow? Up to now, both Ethereum and ETC, and all other chains for that matter, have been competing for the same spot beside Bitcoin as premier blockchains, fully secure and fully scalable. I think this is not possible, and the market will be organized in layers as explained before. The opportunity that Ethereum 2.0 and ETC have in this context is to actually adopt the layered model and create a combined L1 and L2 system as soon as possible to be first to market. However, I think the key of any collaboration between Ethereum 2.0 and ETC is to preserve each chain's styles and independence so they can follow their own technical roadmaps, monetary policies, and freely interoperate with other systems. One thing that could delay or disrupt the trajectory of ETC as described in this talk is Ethereum 1.x. There is increasing discussion that Ethereum 1.x may be perpetuated after Ethereum migrates to Ethereum 2.0. However, the market, especially developers, consumers, enterprise, and government, need the smart contracts industry to consolidate on a few winning systems to be able to start investing serious money and building viable products on these highly valuable technologies. Following this logic and other reasons in this list, I think a marginal Ethereum 1.x would be a low-quality, low-value residue of Ethereum. This is Debbie Downer. As to ETC's competitiveness, here it can be seen that Fedwire and chips, which are the large value real-time gross settlement and net settlement systems in the US dollar system, have individually very similar transaction volumes as ETC's transaction capacity. In terms of monthly and yearly volumes, ETC can perfectly compete on a pro forma basis against Fedwire and chips combined because it operates 24/7, 365, while the others work only 251 days a year. And ETC is programmable and permissionless, while the others are not. This makes ETC perfectly competitive as is relative to the US dollar high-value payment system. And with further scaling improvements, it can totally even surpass those systems. Speaking of improvements, after Atlantis, Agartha, and Aztlan, which focus on compatibility, I think to follow the ETC vision and strategy expressed in this talk, the long-term roadmap of Ethereum Classic should focus on these broad lines. Increasing transaction capacity responsibly, maximizing node count by minimizing potential bloat, building highly efficient and secure L2 connectivity, increasing technological collaboration with Bitcoin. One question I get frequently is, why does ETC have value? My answer is that ETC is identical to Bitcoin as a currency. It's an excellent store of value and has the same underlying evolutionary reasons and physical features such as being scarce, durable, costly to produce, divisible, portable, and transferable. ETC is in fact digital gold. Additionally, something Bitcoin does not have and will never have at the base layer, it is Turing complete. However, ETC does have the same identical philosophy as Bitcoin. This is that it will always prioritize security over everything else. The majority of the other systems in the industry have chosen performance. All this makes ETC a perfect complementary system with Bitcoin in the future landscape hypothesis that I described in this talk. If Bitcoin will be this incredibly secure store of value, but with the limited capacity of having smart contracts at the base layer, then those smart contracts can perfectly be stored and executed inside ETC. And with interoperability technologies, such as atomic swaps, they can move value between ETC and Bitcoin permissionlessly, effectively making BTC Turing complete at the base layer. Before, I compared ETC with Fedwire and chips. But when comparing ETC and Bitcoin at the base layer against world major currency settlement systems, BTC and ETC have individually higher transaction capacity than all systems individually, and combined have higher transaction capacity than all systems combined on a yearly basis. As I said before, the fact that BTC and ETC combined are programmable and permissionless makes them extremely competitive with much higher finality as compared with these global high-value settlement systems. This is yet another strength upon which ETC and Bitcoin could collaborate technologically to compete against global traditional systems at the base layer. In my layered blockchain industry hypothesis, layer 1 competes with gold, but is programmable and socially scalable on a planetary scale. Layer 2 competes with fiat, but is programmable and highly secure when anchored to layer 1. In terms of ETC's market value in particular, I think the crypto-based layer as a sector will eventually surpass the market capitalization of gold shown in the previous slide. However, as a valuation exercise, assigning Bitcoin and ETC a 50% and 25% share of the crypto-based layer respectively, it can be seen that if the sector reaches just 50% of the value of gold, then Bitcoin will be worth around 1.925 trillion or $91,000 per BTC. And Ethereum Classic will be worth around 962 billion or $4,500 per ETC. That's more or less 1,000 times the current price. Both estimates are on a fully diluted basis. Opportunities. In terms of opportunities, I see everything I have described in this talk means that it is perfectly suitable as a pure store of value. ETC is perfectly suitable as a pure store of value for high value, high security property and agreements. As a base layer for other chains, it will be a totally complementary base layer to Bitcoin as well. And of course, it will also be optimal for the IoT industry, as was ETC's first goal and vision after the DAO hard fork. My vision in the core infrastructure and services segment is that companies and teams such as ETC Labs Core, Parity Technologies, IOHK, the Multiget team, and Blockstream can follow the very successful Red Hat model of consulting, training, and support on a subscription. They can also provide services like Blockstream does, such as full-service sector-specific sidechains and/or mining services. Companies like Ethernode and Saturn, and products like EtherCluster by Yas Khoury of the ETC Cooperative are indispensable complementary infrastructure for cloud nodes, home and office hardware nodes, API services, ETC-based operating systems, and decentralized exchanges. Many more models can be added in this sub-layer. The big boys like IBM, Microsoft, Oracle, SAP, Amazon, Google, and others are very likely going to acquire some of the players mentioned above and provide large-scale enterprise solutions based on ETC. Final thoughts. I think a formula for ETC's future success is to continue to have a clear trust minimization philosophy and principles, because that is precisely what makes ETC valuable and complementary with other systems. To connect and collaborate with Ethereum 2.0 and Bitcoin and other systems. To be cautious so that collaboration does not change the integrity, thus the underlying value proposition of ETC. For all participants to define clear business models and messaging. To communicate all these things relentlessly. Thank you very much.
All right. Great talk. So you joked when you were going on stage that you've quit 6 times. I'm curious, as you reflect on what were some of the reasons why you quit, and what brought you back, and kind of what are the lessons learned?
Well, the first time I quit was just a spontaneous anger, which is normally what happens to me. I was fighting with Zach and Shane last year, and we were all part of the ETC dev team. And I think I would say that the base pattern is more or less the same. When I see something that I strongly disagree with, I get angry. And that reflects in my behavior, I guess. That was the first time. The other times were always community things, like when I remember one time when we were fighting with Yas and Anthony about collaborating with Virgil and Ethereum, and I saw that as a threat. So I spontaneously burst. Recently, I quit, and I was not going to come here to this because ETC Labs core had hired one of the developers, Thomas Stiebel, who was independent, to join the team, and Thomas was maintaining the only native client that we had. So I thought that was a continuation of centralizing everything on ETC Labs. Yes, the pattern I would say is I react. For example, the last time it was because they moved the client to the ETC Labs core GitHub. And when I call out that movement, because I see it as a centralization or a threat of centralization, then other members like Yas, Bob, and others, sometimes instead of calling out the move of moving the client there, they call me out for calling them out. So it creates like a circle, and I feel that I'm the only one trying to do these things and protect the integrity of, I don't know, the philosophy of ETC. And when I feel that, I say I'm leaving. Sometimes I even deleted the account, but last time I didn't delete it because I've come so many times that I know I'm going to come again. And there's no other. This talks about also about what I see the uniqueness of ETC is that when I say, okay, I'm not going to work on ETC anymore because it's a lot of energy to be defending the principles as in Bitcoin. But Bitcoin is already a huge ecosystem, and it's already has its philosophy, and I think it's a ship that is already with a lot of inertia, momentum. ETC is very small, and when I see the landscape, I see that there's no other opportunity as Ethereum Classic as a blockchain because of this. What I said about the positioning, no? Proof of work, fixed monetary policy at the base layer of the global operating system. Thank you for the question. There was another question here.
Hello. It is a great picture that you have painted on the ETC going forward, but I just want to know your views on how the big financial institutions are taking, especially given the comparison that you have given for the transactions on the ETC. What are your thoughts on that? How they are going to react to this projection that you have put?
When I have some experience there because I come from Wall Street, working UBS, Securities, and Morgan Stanley, large institutions. Then I quit to start my own financial technology company in 2000, thinking that the internet was going to change finance as it changed the media industry. But finance didn't change with the internet only. Finance was still captured by the corporations because on one side, due to regulation, it's very difficult even in the internet for fintech firms to enter the market. And the other reason was because the monetary base is still controlled by a central bank and the financial institutions. But when blockchain came, that breaks at least the second part, no? The monetary base or the control over money, I think is going to be disintermediated finally, and that is going to liberate the industry for new entrants, etc. They still have the protection of regulation, of course, but we have seen that a whole new industry has emerged of exchanges, for example, Coinbase, Binance, and many exchanges around the world. That's a whole like parallel industry, parallel to the financial industry. In terms of behavior, in one of the slides I put there, here, the big boys will acquire some of the players, make all the mistakes incumbents usually make. And that means that they're following the same steps. They're going to try to do their own blockchains, which is an oxymoron because blockchains are meant to be global, permissionless, and they want to make blockchains but closed and permissioned, so it's a total contradiction. And then they're going to go to a step where they're going to say, okay, we accept that Bitcoin exists, but it has to be regulated. And then they're going to say, okay, it's a good technology, and then they're going to start buying Bitcoin, and it's going to be in their treasuries, etc. So I think that's going to be the pattern. Okay. Thank you.
Thank you, Donald. So next up, we have Afri, who is going to talk about hard fork coordination. As I said earlier, Afri had a very critical role during the Atlantis hard fork. He has performed that role on the Ethereum side before, and we're delighted to have him helping out over here. Cheers, Afri.
Thank you, Bob. Yeah, good morning, Vancouver. Now, we already heard 3 very visionary talks, and I'm going to try to wrap this up a little bit by adding some action items to Ethereum Classic. We've heard it before, the vision of Ethereum Classic is quite fundamental. Ethereum Classic is supposed to be the backbone, the key component of the decentralized web, and basically the most important infrastructure we have for building unstoppable applications. How did we get here? Of course, by following certain principles. Previous talks already outlined them. I will just wrap this up. Ethereum Classic is decentralized, among others. It's decentralized in technology, but also in community. It's secure, trustless, and verifiable. And it provides a very low barrier of entry by honoring and respecting proof of work, which basically allows every CPU to have a voice in the network. The underlying ledger is immutable, and governance exclusively happens off-chain or not at all. By honoring these principles and this vision, Ethereum Classic was created in the first time by consequently opposing irregular state changes. When in 2016, the Ethereum community, or parts of the Ethereum community, decided in favor of an irregular state change, and at the block 1,920,000, the Ethereum Foundation decided to fork off. Now I want to talk about the roadmap of Ethereum Classic, about the technical roadmap. This requires me to also take a look back at the previous milestones because there are some interesting patterns I want to reveal. Ethereum was launched in 2015 with the so-called frontier milestone, with the Genesis block 0. And it went through a couple of hard forks and protocol upgrades. The first of them was the introduction of the difficulty bomb, which is especially for Ethereum Classic later quite important, and at block 200,000. And the first major protocol upgrade was the Homestead hard fork in early 2016. And then the Ethereum Foundation network forked off, and protocol development on the Ethereum Classic side kind of stagnated. We had four more hard forks in 2016, 17, and 18 that mainly dealt with monetary policy and difficulty adjustments. The latest was the diffusal of the difficulty bomb in 2018. Interestingly, there was no real upgrade actually targeting the protocol layer, except from difficulty and block formulas. Whereas, meanwhile, the Ethereum Foundation network came along with regular protocol upgrades and improvements and fixes, most importantly, Byzantium in 2017 and earlier this year with the Constantinople milestones. But you already heard it. Obviously, and hopefully you are aware that Ethereum Classic upgraded to Atlantis this year. We finally managed to come together and have our own very own protocol improvement upgrade. And Atlantis brings back some basic compatibility and interoperability between Ethereum Classic and Ethereum Foundation networks by introducing the remaining EIPs of the Spurious Dragon and Byzantium hard forks. And yeah, it was activated just a couple of weeks ago. Just to give a brief summary on the included upgrades, we enabled state try clearing, which will allow us for greatly, significantly reducing the state try size by removing 13 million empty accounts from the states. We introduced a contract code size limit. We introduced 4 new opcodes and 4 new built-ins. Transaction receipts now come with contract return status, and yeah, we did another difficulty adjustment. And yeah, we did it. So yeah. My emojis are not as fancy as Anthony's, but yeah, I hope you can appreciate it. Yeah, that's when it happened, 3 weeks ago. On the right, you can see the Atlantis block, and on the left, you can see the non-upgraded nodes block. Fortunately, we as a community did a very good job at communicating this upgrade, and only less than 1% of the network hash rate was not upgraded this time, so eventually the non-upgraded chain already died. What did we achieve until this point, until activating Atlantis? We have proven that Ethereum Classic is alive, which is something that is not necessarily given, especially events recently in the last year, and a lot of people claiming Ethereum Classic is de facto dead. Also very notable is that the community is able to form consensus. I mean, I'm very new in this community, but I was kind of skeptical that this is even possible. Because Ethereum Classic is a very special community. And we've also shown that core development in Ethereum Classic is responsive to challenges, and getting to Atlantis was quite challenging, also from the development side. Taking a look at clients supporting Ethereum Classic right now, we have Parity Ethereum, naturally supporting Ethereum Classic from day one, from day zero. I believe Ethereum Classic was the first, Parity Ethereum was the first client actually supporting Ethereum Classic. But also that multi-gas is on Atlantis now. It was for Parity and for multi-gas, it's very easy to support Atlantis because all the introduced features of Byzantium already are in the code base for Ethereum Foundation Network. And we managed, with the help of the amazing ShameSafe team, to fix Gas Classic and to upgrade it to Atlantis eventually in time. Unfortunately, we lost Mantis on the way here. Yeah, so we are with 3 full node implementations for Ethereum Classic right now. And we have a lot of amazing tooling available, so this development community is really busy this year. In addition to Gas Tracker, we have Block Scout, we have the Jade Explorer, we have interesting projects like Ethernode, Ethercluster. We are building an OpenRPC spec. And did you know we have 6 different Ethereum Classic testnets? No. So you should come to my Ethereum Classic testnet talk later today. Yeah. But now what? Why I'm standing here? What shall we do in the future? And I'm happy to announce Agatha hard fork, which is not yet set in stone, but I believe everyone in this room or in this community will look forward for further protocol upgrades. And Agatha initially was supposed to bring Constantinople and Petersburg upgraders from the Ethereum Foundation Network to Ethereum Classic to further improve on the cross-chain compatibility. And potential activation date could be March 2020. But yeah. So when I did these slides, I was assuming Agatha will be very limited in its scope, bringing these Constantinople changes over, which are bitwise shifting instructions to new opcodes, and something that Ethereum Foundation Network does not have is account versioning or contract versioning. This is an EIP written by Wei Tang that was not directly accepted into Ethereum hard forks yet, but it's certainly useful, and we might want to consider this for Classic before Ethereum Foundation considers this. But how do we get there? We need to come together again. We need to talk about these upgrades. We need to specifically talk about what shall go into the next protocol upgrade, and when shall we upgrade, and how much time do we need to prepare all the clients. And I proposed to have our first Agatha upgrade call on October 24th, which is in exactly 3 weeks. And we will meet on the Ethereum Classic Discord, so if you're interested in protocol governance, you're all invited to join. Now that we have done Atlantis and we are already started working on Agatha, we have further items on the roadmap. I called the subsequent hard fork Aztlan, which could bring even more features. Let it be what the Ethereum Foundation called Istanbul or Berlin. It could be additional features that are not considered by the Ethereum Foundation. All this is possible to activate in 2020, so next year. Eventually, we can consider merging them. So we have Aztlan and Agatha at the same time, but this is something we need to find out together with the community, with core developers, and yeah, need to decide upon. But that's not all. Beyond protocol governance and protocol upgrades, we also are currently investigating modifying the mining algorithm. Unfortunately, Christy is not here to talk about POW, but Alex is here to talk about SHA-3. He's been working on a SHA-3 network, we have massive options. We could consider basically anything that proves suitable for ASIC resistance, even random X. So parity Ethereum has been around since day one, and it will be around for a while. We might need to support the parity team by maintaining it. Multi-gas is more active than ever and it's very stable. It would be nice to have Ethereum Classic support in foundation gas upstream, which would be, I personally believe it has a lot of potential to collaborate on one client for two networks. The same is true for Hyperledger's Besum. I strike through Mantis because I believe even if we salvage this code base, it's not worth the effort to continuously maintain a client unless we find a really big team that's willing to do this. And I also want to strike through Gas Classic because I really hope we can finally get rid of this client because it's how to put it nicely. It's a risk. Yes?
So just on Mantis, there is a really big team. It's just not working on it.
Okay, but
my answer there is persuade IOHK back into the ring.
Okay,
that's the answer.
So I'm a big fan of client diversity, and I believe it's good to have. But I also believe that unless there is a big team behind it, consistently maintaining it, we should be careful with just having more clients. And I hope we can, I hope we do not try to get Classic Gas through the next upgrade. And beyond that, you can only speculate. There are a lot of interesting options out there for Ethereum Classic. Eventually, once Ethereum Foundation moves to proof of stake, Ethereum Classic might become the most significant proof of work EVM chain. We could provide Ethereum users migration paths for, instead of moving to Ethereum 2.0, to move to Ethereum Classic. This is something we could consider. We could consider merging other EVM chains into Classic. Options are, there are a lot of options out there, and we can only speculate at this point where we are going. But getting there requires us to be mindful about it. We need to maintain integrity as community. We need to continuously honor our values, vision, and principles. And I personally believe we don't need toxicity. We rather need diplomacy. We need more collaboration, less competition, and we need to be the open minds working on open protocols, building open software. And this will make Ethereum Classic future-proof. Thank you. You can find me on Discord and Crypto Twitter, and you can ask me questions. Oh, Jesus, thank you. I have an additional fridge for maple syrup because I have so many Canadian friends.
Right, you have to have a specific fridge for it. It's like a beer fridge,
Yes, exactly.
but for maple syrup. Okay, so I think it's break time, right? Oh, you got a question?
Just a question?
The question is my mic on? The question is, Zach Mitton, a few days ago, said exactly the opposite in terms of clients. That I was surprised. He prefers no client diversity and to have one client because, in his point of view, he thinks that that minimizes the risk of splits or something. What do you think about that opinion?
Yeah, that's a good question. Thank you for that. So usually developers are lazy. So no offense. I mean, he has a point, and I support that less is sometimes better. And if we only had one, it would be so much easier. So whatever we mess up, nobody would notice. But since we have multiple clients, we need to be very mindful about it and very careful developing them and speccing everything we change. And
I mean, I guess the trade-off really is if you have only one client, you can't have a fork, but it might not go where you like because you've got no counter. You know, there's a total risk of capture there.
Yeah, I was arguing that it affects availability. If there's only one, and it.
I mean, I think two or three is good.
yeah.
Very
The
good.
other, and most people probably know this, but the other big advantage of having more than one client is that you can immediately tell whether there's a difference, whether there's a problem with the protocol or a problem with the implementation. And that's a really important strength at any development phase.
That's a good point.
Yeah, I mean, you can triangulate, right, and see is this a bug in a particular client, or is it a specification bug where both of them are to spec, but they are different, so that the spec itself was not, needs clarifying. That there is a bug in the protocol spec, and without multiple clients, you can't do that triangulation. And again, if you've only got two clients, you get the situation with Gethin parity. Well, if you've got a difference in behavior, who's going to buckle? Are you ever going to get back? And you don't really see that in consensus, but you see it in the RPCs, where the RPC behavior has always been different between Gethin parity, and it's still not resolved years and years later, because what's right, what's correct? I don't know. There was never a spec.
That's why they have to use chains, open RPC, I guess.
That's not a question.
Your speculation slide was interesting, and the second one about ETH users, developers who either oppose proof of stake, I guess migrating over to ETH Classic is kind of interesting. Talk a little bit more about that. And I guess the question is, what does ETC need to do to create a better glide path for that to happen? Because there will be opposition. And whether it's the developers or users or miners, what do you think ETC has to do?
Yes. This is probably the most speculative item on my slides, and there's nothing specified yet. And I would imagine that, for instance, you could do something like, you deposit some ETH into some kind of burner contract to signal that you want to migrate to Ethereum Classic. And we as Ethereum Classic can consider, is this something we want to offer? And might to create like an interface on Ethereum Classic side to allow coins or people to transfer to our ecosystem. But this needs work, obviously. And I really enjoyed reading this EIP written by Wei Tang, which actually offers to merge EVM chains, the state of EVM chains, which is a much cleaner way of offering such a migration path. But this is this is very far future, and it needs a lot of research.
So he's talking on that later.
Oh, amazing. So Wei is talking on that later. So you should not miss his talk. Oh, thank you.
So, yeah, thank you, Afri. So it's the morning break now. We will resume at 11 a.m. back in here. One thing I didn't say at the very start of the day was about the other room. So there is a second room next door to us, and there are two one-hour slots there where it's open for lightning talks. So there are 8 15-minute slots available each day where, you know, the room is dedicated to anyone who wants to give a talk or a demo of anything. That will be the same again tomorrow. For the rest of the day, you know, there are tables, there's power, sit down, show people stuff, work together, whatever you like. There's also on the whiteboard outside where you've got the sign up for the lightning talks. There's also sort of a birds of the feather, open, connect with people. I am looking for this. Is there someone who knows about that? You know, on any kind of topic. So find your tribe that way. If there's a specific kind of person or people doing a thing or with interest in whatever that may be, feel free to use that board to locate them. You know, the hashtag that we've been using on Twitter is just hashtag ETC Summit. And that's the Wi-Fi here as well, if anyone has not worked that out yet. There's no password or anything. So we'll resume again at 11. Thank you. Hello, everyone. Oh, yeah. So we're going to get started again. The next talk is by Shane Jonas of ETC Labs, who's going to tell us a little bit about JSON RPC tooling. So this is an area, as I was alluding to, where there's been some divergence between clients, lack of standardization, just very sort of manual kind of processes. Is how do you make these APIs available to interact with clients? And the Open RPC project within ETC Labs has been a great step forward there. And then I guess Shane is also going to talk about the broader picture. Thank you.
Yeah, so I'm going to talk about the future of JSON RPC tooling. So with modern automation and tooling like gRPC and Swagger, JSON RPC was really lagging behind, and Open RPC fills that gap. So what is JSON RPC? So it's just like a simple protocol to make remote procedure calls. So you can see like on the left-hand side up there, this is an example of Web3.js and how it uses JSON RPC. So it just makes a request there for an example. It has method block number, and then multigeth or one of the other clients can make a response there with the correct block number. So this is great. It's really simple, but what are the problems? It's really unclear what methods a JSON RPC API has. So in this case, like multigeth has ETH block number, but what other methods does it have? Is it get block number? Is it block number? It leads to a lot of incompatibilities between implementations. Bob alluded to that earlier. There's a lot of incompatibilities between geth and parity. And also, we have a lot of outdated JSON RPC clients, like Web3, Ethers.js, that kind of stuff needs to get updated constantly and their documentation constantly. But it's not all bad. JSON RPC is pretty simple. It's transport agnostic, and it's already used really widely in the blockchain space with Bitcoin, Ethereum Classic, all that stuff. So OpenRPC, what is it? It's just a simple JSON description of JSON RPC APIs. And I'll just go over like a bit of the structure here. And the most important part here is that you can define a bit of info about your API, all of the methods, and you can kind of reuse the rest of the stuff to make it a lot easier for you. So one of the things we've created with OpenRPC is the Ethereum JSON RPC specification. And it's basically all the API methods that an EVM-based blockchain must implement. So in this case, it's a set between Ethereum and parity geth that they can both support, basically. This gives us really great stuff like generated documentation you can see on the right-hand side. We have clients, and this is already in multigeth. And if you want to see the actual spec, you can check out the link at the bottom. I can post the slides later. Yeah, so how is it implemented in multigeth? Well, we have this discovery method that multigeth implements, and it's called rpc.discover. And what that does is return this OpenRPC document that describes how multigeth works. So, and here we have here's the example for Web3 client version, and then the result is like a string that gives you the client version. And you can check out, all this stuff out in multigeth. And so not only do we have these great docs and everything, but we have a bunch of tools that we built on top of this. One of them is the Playground, which lets you preview and edit OpenRPC documents. You can see it does like live updating. Some of the other stuff that this Playground has is you can kind of configure it to look more like docs, like not have the editing. And also, it has really great features, like in this case, I can kind of interact with the multigeth API here, and it'll give me all the methods that that multi-geth has, and then I can kind of go into client version and hit the play button and kind of interact with the API kind of in real time there, and I don't have to write any code yet. So some of the other great tooling that this provides is like an alternative to Web3.js that's just generated from this document. And you can see here, I get really great like TypeScript support and autocomplete and inline documentation stuff, like really great editor support. And this really helps onboarding new devs and that kind of stuff. It's a really tough process if you don't have this kind of stuff. So some other tools for devs that we've built is like a mock server where you can just have your OpenRPC document, give it the mock server, and it'll basically generate an entire server for you that can kind of give you fake responses. So in this case, I'm asking it for block number, and it's giving me like the Genesis block. So this is kind of like the big overview of the tooling foundations that we built. So we have like the specification on the bottom. We have the meta schema and the typings, and then all of the stuff that uses that is like the playground, the generator, documentation stuff, and the mock server. So just to like recap the benefits of having something like OpenRPC is that we get great up-to-date API documentation. It's specification driven, so you can start building stuff across multiple teams, like with the mock server, for example. It's human and machine readable, especially across the wire. It's really easy to debug. I showed like the multi-geth service discovery, which helps a lot with all of the tooling. And then we have all of these clients for many languages. I showed TypeScript there, but we can also generate like a Rust client and like hopefully Golang in the works. And like the big thing I want to kind of point out here is that having OpenRPC gives us an industry standard way to build all of this great tooling on top of JSON RPC. So what's next for us? Ideally, it would be like other chains and other client support other than multi-geth. Lots more outreach, more talks and demos. And like I said, ideally, we want some Golang generated clients later. And we have lots of incremental tooling improvements coming. And we also have improvement proposals. And for Ethereum, we have the ECIP 1053, which you can go check out, and the EIP 1901. And we have one for Bitcoin as well. So you can go check that out and see a lot of the big picture stuff that I talked about today. And yeah, that's it. If you want to learn more, you can check out openrpc.org. Thanks.
Hi, welcome. My name is Zane Starr, and I wanted to talk to you about a problem that we have currently in the ecosystem. And that problem is, how do we connect users of decentralized services with developers that are developing decentralized services? What I'm calling the decentralized service gap. So just a little bit of background about myself. I work in the ETC Labs core dev team, where I primarily focus on tooling. Prior to that, I worked on decentralized science fiction for Consensus, and sort of throughout my career, I've had to focus on infrastructure and building services, from everything to wireless sensor networks to working on big data problems for Groupon. And so to sort of frame this problem, I wanted to open with this question. So, how many of us out there are running full nodes or using light clients to connect to dApps? Just a show of hands. How many of your users, if you're a developer, are using full nodes or light clients to connect? So just a casual look around, there's just one or two or just three hands popping up. And so you kind of really have to ask, why is this? And like, what is the problem? So as developers, we're always looking for a way to sort of avoid centralization. So if you look at the image on the left, we have this big blue like circle, and we have these red dots around it, and that's centralization, which is what we have currently today with the standard web. And what we really want is this decentralized network. And so we need ways to get users to actually run the services. So we don't have an image that looks centralized, but one that's decentralized. So that improves security. There's no central point to just disconnect the network. There's a host of benefits to this. And so the question really is how do we get to this? So what are users really facing? The problem is, like, what does it take to start a service? And so here, I'm just trying to start Geth, and it's kind of hard, even for a developer. And so just for example, there are over 26 combined different arguments to just start a network over across parity or Geth or multi-Geth, which is just too much of a cognitive load. And so what we really want is to allow developers to hit a "that was easy" button. So you hit this launch service, and all of a sudden, you're on a decentralized network. You're no longer going through this very centralized hub, and you're just a part of this node. So the question is how do we get there, and how do we bridge this gap? Because as developers, what we really want is this decentralized network, and as a user, what we really want is a "that was easy" button. And so I'd like to introduce to you what we've proposed as a solution to this, the Jade Service Runner, which is really a system in two parts. So what do we do? Well, the first thing you want to do is give the user a "that was easy" button. So we have built an installation tool that allows the user to just go through and install a decentralized service, hit a button, and then launch, and then select what network they want to run. So in this case, we've installed multi-Geth with a single button press, and then just started multi-Geth on the Kadi network. And so this provides an interface for developers to then connect to it. So again, we're trying to get to this point where we have a "that was easy" button. I don't really need to understand too much of the details of what went on, but I have control of it. So as a developer, what we've done is provide the tools to make it such that in 5 lines of code, you can simply start a decentralized service, prompt the user to install it. You can also request access to run it. And so what we have on the left is the code to do that, and on the right is a proposal that we have for the permissions to allow it. So it should be as easy as installing or running an app on your phone. All right, so what is this actually doing? So we have our dApp on the left, Service Runner sits in the middle, which proxies requests to the underlying services in the background. So here we have classic Geth, parity. And so Shane, in his talk before, talked about Bitcoin nodes and being able to run these different services. What the Jade Service Runner provides is an interface to make easy installation, daemonization, so that means that the process that's running is always kept alive, and access in terms of location and discovery for what an individual user is running. All right, so what does the future look like? The future really looks like a modular synth, in our opinion. And so if we have generic, easily discoverable interfaces where there are lots of different components that dApp developers have access to, and you can just kind of plug these different things in, then you can make really interesting music, and it's discoverable, so it's accessible to all sort of developers. So practically, what does this look like? Practically, the future looks like single-click installation, easy access for permissions, and peering between Jade service runners. So just to step through this very briefly, we have a DApp that's just sort of a light DApp, and it doesn't actually have access to install a service runner. So it just runs a client, which connects to other people that are running service runners, which are all interconnected, which allows for service discovery. It uses openrpc.discover to allow this DApp user to discover what's being run. And these service runners are tied to a decentralized registry, which allows for easy installation and the specification for how these services should be run. So here we have a local machine where a user is running one of these service runners and being a peer in the node. Okay, so just to recap, the Jade service runner is filling the gap by providing programmatically discoverable APIs, single-click installation, and fire-forget daemonization of services. So the different work that we have to be done is work on the permissions layer. So I showed you this prompt for allowing a DApp to install a service on your machine or to connect and start a service. So that permissioning and like how the identity system works still needs to be fleshed out. We have peering, so a network protocol between Jade service runners to connect different users to different services that are running. So this is particularly useful if you had a network of side chains or relayers to connect to the network. This would be a single-click installation to allow users to provide or join L2 scaling solutions. The thing that Shane talked about earlier in his OpenRPC talk, the abstract service definitions. So imagine that it doesn't really matter what client that your DApp connects to, you just want an Ethereum client. So using OpenRPC, you make the specification that says, just give me an ETH client. So this is already an EIP 1901. And so what this allows for you to do as a developer is to say, abstractly, give me a service that implements this description. And so you can go and do that, and the network will either install a service that meets that and allow you to start it and make a request. And the other thing is a decentralized service registry, which you can kind of view as an app store for decentralized services. So I want to connect to Cosmos or something like that. So how do I do that? Oh, okay, cool. I can just point to the Cosmos registry, and then I can say, okay, I'll download the configs for this, and then button click, you're done. So the other thing that we're kind of thinking about, but we haven't really solidified, is support for bridging between JSON RPC and GraphQL, or bridging between JSON RPC and gRPC. So I'd like to invite you to help us move things forward and build awesome tools that improve interoperability, help L2 scaling solutions, and really help us build a decentralized network. So check out our docs at Jade Builders, OpenRPC, and the Jade Service Runner codebase. Pull requests are welcome, and we're going to do a workshop today. So stop by and let's build all. Okay.
So yes, my apologies there for not being there for the handover.
Oh, no problem.
And
I think they gave me some.
you have that?
Oh, is this the? Okay.
That's the clicker. So so yeah, Zach now is going to talk about adding Merkle mountain ranges and fly proofs to ETC. You know, this is something which you know, there's been an ongoing kind of thread here. So Zach worked on BTC Relay, so has a long history of, you know, these kind of texts for linking chains together. And I am really quite, you know, fingers crossed that we have an opportunity to to look at getting fly proofs into the next hard fork. If we can do that, that would be brilliant.
Thank you, Bob. Okay. Yeah, relay systems are not the only thing that would benefit from this, but they're definitely one of them. Okay, so I just want to say, like, from the beginning, right from the Bitcoin white paper, there was this idea, Section 8 right there, simplified payment verification. But I would argue that, like, this never really took off. People aren't using this stuff. And I want to ask the question, why? And I want to maybe answer that and come up with a solution to it. So first of all, the description of, like, how that works. So on Bitcoin there, they're just talking about transactions. But it could be any kind of data. And down here at the bottom row there, you would have the leaves of the tree, which are any kind of data. And in order to make a Merkle proof, you would, the idea is that someone has just the root, and they don't have to keep track of all that data. So not everyone needs to run full nodes, and they would only need to take, like, a small little bit of that data in order to prove something against that root. But the problem is, how do we know that that root is legitimate? And this is the part that a lot of people forget to discuss when they discuss Merkle proofs. And this is unfortunately the really hard part to get right, which is that Merkle root is embedded in the hash chain. Okay, so you need to download all the headers in order to make sure that it's part of the legitimate chain. And that's a totally different kind of security, right? That's the proof of work chain. And then once you have that, you can have the Merkle root. And once you have the Merkle root and you trust that, then you can get these proofs from a full node. But the problem there is that this list in Bitcoin is really long. And in Ethereum, it's even worse. So just to kind of show how it works in Ethereum, it's a little bit different. There's a few of these trees. There's the transactions tree, the receipts tree, and the storage tree, or the accounts tree, which has storage trees in it. But it's the same idea. You have to prove something against a root, and then that root is contained inside another tree. But eventually, it comes down to a single hash that you have to trust in a block again. So see, they're all pointing back to the block at the top. And again, you have to have the entire chain in order to know if there's any validity to that. So let's look at the numbers. Just to get the actual Merkle inclusion proof part, that's super small, 400 bytes on Bitcoin and maybe 800 bytes on Ethereum, depending on exactly what you're looking at. But the real problem up here, again, is those headers. On Bitcoin, it's 50 megabytes, and on Ethereum and Ethereum Classic, it's 3 gigabytes. So this kind of blows up any possibility of using this in a way that we understand how to, the user experience that everyone's used to using the internet and just using computers. So if you have to download 3 gigabytes, that's going to take a while to do. And obviously, this is not good. So I just want to preface where we're going to get to, which is with Fly Client, we can get that down to 500 kilobytes. Okay, so that's, 3 orders of magnitude difference. At that point, you're not just talking about a speed up, you're talking about, like, entirely different kinds of software architectures that become possible. Okay, so I put this slide in here to kind of show, like, what's the typical UX now. This is Bread Wallet. I'm not really sure how to play the video. It doesn't really matter, but it just kind of shows that, like, this piece is loading when, because the way Bread Wallet works is it actually tries to make use of light client techniques, but it has to download the headers, and it says syncing, 59%, 60%, and the first time you install this app, it takes like 15 minutes. And then every time you open it, it takes 20 or 30 seconds. So I want to tell people to use it, but I can't because it's just going to confuse them, especially if they're new users. Okay, so with Fly Client, the first general concept is how can we do this without, how can we prove the work of the chain without downloading every single header? So the reason that you have to download every header now is because it's this linked list. And as we know in computer science, a linked list grows with the size of the list. So if you want to access one piece in the list, you have to run through the entire list. Whereas if we had a tree or something, this could be a lot better. But let's just take a look at an idea. What if instead of downloading all the headers, we just took a few random ones? Okay, we just asked for a few random ones, and you don't know the random ones that I'm going to ask for. So if you're able to return those, then maybe that means you have all the ones in between. But the problem here is without all the linkages, they're just floating in outer space. So there's no way to prove that someone didn't just create them afterwards, or there's no way to know what order they came in, or that they're part of anything really. So what we really need is a way to take those random headers that we ask for and link them together. So it becomes obvious that like some sort of tree would be useful here, but okay, we need to not, here's what I'm trying to show, is that we need to not only link the first header to these other headers, but we actually need to link the other headers to the ones before them, and the ones before them. It's kind of a recursive process. And the first kind of tree you could think of maybe using would be just a regular Merkle tree, which is what Bitcoin is using right now. The problem with that is that, so if you can imagine like A, B, C, D down there, those would be the headers, and you'd be adding them to this tree. Every time you add a new one, you actually have to change the parent hashes there. So if I were to add F, then I would have to change Y2 and Z1, which changes the root, the root of some of the other ones. So that becomes a problem when we're trying to link them together later, recursively like that. Okay, I don't think I'm ready for that slide yet. Okay, so this is where the Merkle Mountain Range data structure comes in. This was, at first, I guess, talked about from Peter Todd for a totally different use case. But you put the first item in, and that's really, right now, that's the whole tree, right? Okay, so this is the first block hash. Put the second one in, then you have to hash those together to make a parent. When the third one goes in, it kind of just stays on its own, and so you can see this structure start to form, where it's these, that's why they call it a Merkle Mountain Range. It doesn't necessarily only have one root, and as we add the next piece, you can see that sort of cascaded, and since BH3 was the same height as BH2, it created H of 2 and 3, and since that was the same height as its sibling over there, that created another parent. So as we go through this, maybe we can just kind of watch. I had block hash 6. Now we have 3 separate mountains. Add block hash 7, causes like the cascade to go all the way up. And what's nice about this is, unlike the Merkle tree I showed before, this one, you'll notice none of the parent hashes ever change. So when I add more leaves to it, there's no updating going on. There's just adding of new things. So that's a really important concept to this tree. And then here's a little bit more about how the tree is implemented in code. Like basically there's the tree representation, and each of these things has an index. And you can think of everything above the first row as just a sort of metadata, whereas the leaves of the tree are the real data. So if you want, let's say, leaf 8, there's an algorithmic process to go from leaf 8 to get up to index 15th item in the array, and that's the item that you know is containing leaf 8. Okay, so let's look at a proof. The way proofs work for this is first, let's say if we want to prove leaf 8, which is node 15 there, we would first take all the peaks of the submountains. So we need all of those. And then we just need a regular Merkle proof from the local mountain that this item is in. So from 21 there down, that's the sort of the branch of that Merkle tree. So that would be a proof of 15, and it's also enough to prove 16, by the way, as well. And what's nice about these is when you send these to someone who's going to receive them and use them to verify, all you have to do is tell them that, like, that's node 14, this is node 21, and you give them like these node and hash pairs, and they can reassemble the whole thing into a tree on their side, and then they can verify by just making sure it has all the right nodes to index the one that you're claiming to have proven. So if we want to add 22 to this, it's really efficient. We're just going to add 2 more nodes, and that's enough to validate leaf 22 and 23. So we can do stuff where, like, maybe I request a proof for a few of the leaves, and then do some calculation. I'm like, oh, now we need a few more, so I can grab another proof for the next few after that, and we can keep track of everything really nicely. There's also an optimization where we can get rid of the implied leaves. Like, we don't need leaf 7, or we don't need node 17 there because we have 15 and 16, and they can create that locally. Okay, so that's the bagging the peak process. I'm just showing here that, like, for the proof, for the root, since there's multiple peaks there, the way the root is defined is it's the concatenation of all the peaks and then the hash of that. All right, so how do we add this to Ethereum Classic? Well, this is how a header looks right now. There's all these items in it. We could just add an extra item at the bottom of it, and because this thing is RLP encoded, most of the surrounding software would have, like, very little to do to understand it. It wouldn't break that much because these things are already getting sort of decoded as lists. So it'd just be an extra item in there that, like, doesn't really affect anything else if you're ignoring it, and if you need it, you know where to find it. Okay, so how does the actual full fly proof work, though? Now, Benedict wrote the paper on this with a few other people, and he did a talk at, I think it was Scaling Bitcoin a year and a half ago. So there's a 30-minute talk there, and I think I linked to it at the end, so if you want to see, like, all the details, just check out the link at the end. But I'm just going to kind of just go over the main sort of themes behind it. So first, we pseudo-randomly request a sample of a few headers and proofs of their exact placement. Okay, then we request enough of these headers. If we get about 600 of them, then we have, like, a cryptographic level of certainty that they couldn't have just happened to have those exact 600. So it's enough to know that whatever we're proving from this, like, is legitimate and that work was actually done. And now, this is kind of a little bit maybe harder to realize why, but the way that the queries are done, instead of just picking 600 randomly, you pick them closer to the end of the chain, and that's to kind of intuitively, the reason for that is to protect against, like, a fork that someone would make where they're just using legitimate work from the early part of the chain and just forking off and making their own chain. So there's a whole, like, exact mathematical equation for, like, this probability distribution you're supposed to use. And then, okay, so then here's the really interesting part, though. Instead of the person wanting to verify the information, instead of them just picking 600 random blocks, they actually can use the block hash for that randomness as like a seed to automatically pick the 600 blocks, because that makes the proof no longer tied to the people involved that are like requesting it. Now it's just sort of a bare proof. It's a non-interactive thing. And what's cool about that is like you could show it to anyone, anywhere, anytime. Like there's nothing else external to that proof that you would need to know to prove the entire work of the chain. So a lot of people might realize that usually using a block hash as randomness is insecure. But in this case, it's actually not, because so the problem with using block hashes as seeds is that if a miner, let's say they mine a block and they just happen to have this block hash, if they are somehow involved in the outcome of that randomness, they might just throw it away and make a new block. But in this case, we're just trying to prove how much work was done. So in order for them to create a new block with a new set of randomness, they actually have to do more work. So it kind of like cancels out that fact. So in the end, we have a single proof. It's about 500 kilobytes, and it proves the total work of the chain. It can be reused indefinitely to prove any other data in the blockchain, including historic data. So from that proof, you can make all these little Merkle proofs for like any piece of data that you want in the entire blockchain. Okay. So obviously the main benefit of this is that the user experience can be a lot better. We don't have to really download anything as like this ongoing daemon or process on the user's computer. They can literally just ask the way they normally would make a web request, get one piece of information and get it back. If we're using a peer-to-peer protocol, it's really awesome for that. But even if if our users are using like Infura or like some kind of centralized service, we can actually verify that information now. So sure, it's still centralized. It still has the problems of, the service can go down and that kind of thing. But we're no longer trusting a central party for what the information is. So I would say that alone is a huge benefit. Now, the other potential benefits, full node syncing, no longer requiring ugly checkpoints. Even Bitcoin, I was looking like in the docs for Bitcoin, even they have like checkpointing now. Because the problem is when your full node is trying to download the chain, there's no way to know if it's the legit chain until you get to the end. By that time, you've already downloaded like megabytes and megabytes, and you've just wasted a bunch of time. So this kind of gets rid of any need for that. It's just a one-time, I make a request, you send something back. If it's legitimate, I'll know it. If it's not, I'll just kick you out of my network. Okay, so this is the trustless ETC, ETH bridge thing. I think there could be some really huge potential there. Like right now to do these bridges, so Bitcoin Relay is probably the best example of a bridge like this. You have to relay all these headers. So all the Bitcoin headers are going into a smart contract on Ethereum. And it's expensive. They need to incentivize it. It's not properly incentivized. That's one of the problems with BTC Relay. But even if it was, it's hard to do that. Even if it was, it's a lot of data. It's expensive. And this, instead of trying to figure out the incentive structure, this eliminates any incentive. You don't need any incentive because you don't need to relay those headers anymore. So now if someone wants to make a proof for something that happened on the Ethereum Classic chain, and then have some smart contract on Ethereum, do something in return, you can actually make that proof as like a one-time transaction. So whoever's trying to make that proof would relay the header themselves, because they don't need to relay all the headers now. They just need to relay the headers they're interested in. And some important things for the EVM. So once we have this Merkle mountain range structure inside we'll be able to access any historical block hash, right? Because you'll just show, in a smart contract, you can show a proof to an earlier historic block hash that's part of like the chain that you're on. And then from that, you make a Merkle proof. So really, you can work with historic data of a smart contract inside of a smart contract. And a lot of things get just way cheaper and much more feasible in the way that these things work. I didn't put anything about Internet of Things up there, but I think this could be really useful for stuff like that. Like, I think there's a lot of potential for like really like low-level devices to be able to talk to each other, verify information, and create a network that's actually robust, because they don't need to send each other as much data, they don't need to trust each other, and they don't, there's not as much anyone can do to take down another node. All right, so now I'm going to get to the issue, which is the hashing algorithm that we have currently on Ethereum Classic and on Ethereum. The verification for that is extremely expensive. Inside a smart contract, it would be hundreds of millions of gas just to do one of them. On a computer, like on a phone, it's 20 seconds. On a laptop, it could be 10 seconds. And that's because like there's this process, you need this DAG structure, which is expensive to create. You could also send the person the DAG structure, but it's 16 megabytes, and it's growing exponentially. So I kind of question whether or not we want to continue supporting Ethash. Obviously, that's a really big change, and it's not something like I don't think anyone is solely in charge of. This is something we have to decide, like all of us. But right now, it doesn't. It's not ASIC resistance anymore. So that was like the main purpose of Ethash. There's a lot of good alternatives out there, and I think Alex is going to give a presentation at some point on switching to KCAC 256, which I think is as good of an idea as any. But that would actually make it extremely efficient to do, and that would make the bridges possible as well right off the bat, because Ethereum already supports like a KCAC opcode, so all of that stuff would work natively. Okay, so just here's some links, and if you want to contact me or if you want to look at any of the other slides, that's my presentation. Should I take questions, or?
Absolutely.
Okay, does anyone have any questions? Sure.
If you have any requests for, I guess, other EIPs to make this easier for you, I guess what are they? And I also want to know, are there any particular algorithms that make this easier? So I know, Lake 2, I know it's going into a symbol. Does that help you at all? Or?
I don't think that helps unless that's somehow used. We switch to that hashing algorithm instead of KCAC. But I would have to think about it. I mean, I definitely might have some ideas, but I'd have to think about it a little more.
Okay.
In terms of Vitalik's, kind of request of saying, talking about the data storage layer piece, and saying that if ETC had Fly client plus gas repricing on call data, so that is part of Istanbul as well. If we can have that gas repricing on ETC, but with the version, trick so that you're not backwards incompatibility doing, I think we could get to that position very soon.
Well, yeah, of course.
Sure.
I guess I just want to know if there's like a wish list of EIPs that would make for Fly client work on ETH. If you send that to me, maybe we can get a few of those
I see.
done.
Potentially getting it on Ethereum, getting this
running
on Ethereum.
Well, I mean,
okay, cool.
I presume you want both. Okay. And actually,
I hadn't thought about it much, just because up until a couple days ago, it seemed pretty clear that ProgPow was happening and then proof of stake. But yeah, happy to talk about that.
Okay. All right. Well, hooray.
All right, I think I solved that.
Yeah.
Last
year, IOHK presented nipple pause, and this year you presented the fly client. Do they do the same function? Are they complementary? Would they live together, or only one?
So I was really interested in nipple pause first. That's kind of how I got into this research. I was researching that stuff, see how that was working, and then this came out. And to me, this just blows all that away because basically the amount of the type of cryptographic security you get with this is better. With that there was it was focusing on these super blocks and the ability to kind of use a single block as a point. But yeah, there was just a ton of problems with those, and this is a much more, I think, elegant solution. So, I mean, yeah, that got us pretty far, but this is overall, I think on every metric, just better.
Could both live in the same blockchain and some users or clients use one and others, or only one has to live into it?
I don't think so. This is kind of something that, well, there's ways to do a soft fork or a velvet fork to make this stuff work, but the big problem still is eth-hash, so there's not really a way to do a soft fork for fixing that.
And I think this is actually a fantastic opportunity to bring IOHK back into the ETC ecosystem, as saying, you love that kind of stuff, don't you? Can you help with Fly Client? You know, because we could really use with help on the research side and implementation of this into various clients.
Yeah, definitely.
This is absolutely in their ballpark. You know, it's Charles's bag.
As far as I know, I'm the only one working on this right now. So if anyone is interested in helping out, just contact me. My email is up there. It's just my name, 23@gmail.
And I'd heard as well on the Ethereum research side, it's essentially only Vitalik that's looking at it. So it isn't like, you know, there's anyone sitting and waiting. Really, yourself and IOHK are probably the best people in the world to do this.
Yeah, and I think it's starting to pick up more momentum too, because I just saw Zuko retweet last night that they're going to try and add that to Zcash. And Grin and Beam have added, are supposedly adding this too. So I think a lot of people are realizing that this is just a huge improvement in a lot of ways. One more question?
Sure.
Here.
Hi, Zach. Nice to actually meet you in person.
Hey, man.
So I had a question. Are there any trade-offs for using Fly Client versus fully validating the node? And if so, kind of what are they and how do they work?
Yeah, it's always beneficial to run a full node over any of this light client type stuff. It's hard to say what exactly the benefits are, but with this you're relying on sort of the honest miner assumption. You're relying on the idea that more than 51% of the people mining this blockchain are doing it honestly. So you could have the longest chain, but if the transactions that make up that chain aren't valid, then the data is not really legitimate. And especially in this room, we should know that sometimes transactions can happen that are not necessarily deemed legitimate by everyone. And the only way to find that is with a full node.
Yeah, so that was basically my question. Just to restate what you were saying, it sounds kind of as if Fly clients are good if you have a light client need, where maybe on my cell phone or something, I'm not going to be able to run a full node ever, but aren't exactly the thing for everybody used in all cases. And I guess I wonder then too, how do say ETH and ETC are communicating via Fly client? How do they resolve that if one day ETC or ETH change the rules and go with a different rule set? How do you resolve forks then if Ethereum is now talking to potentially 2 ETC fork chains? How does that work?
Well, mostly these light clients are just following the proof of work chain. So the same way that BTC Relay is now is if there's a chain that overtakes the longest chain, whether you consider that the legit one or not, that's the one that the contract will be following. So the same thing would happen with a bridge between Ethereum and Ethereum Classic. But it's important to emphasize that this doesn't affect anything outside of that. So even if that bridge got messed up, it would have no effect on Ethereum Classic as a network by itself. It would just have an effect on the bridge and maybe the health of that system.
Okay. Thank you.
Thanks. Oh, all right. Just unplug this.
Now, where is Brooke? Oh, hello. Sure.
Okay.
I'm sorry, could you go back one slide to your contacts and URLs?
You know what? I just unplugged the computer.
Bummer.
But you could ask the question anyway, if it's possible.
That was my question. I missed the resources.
All right, I'll come show it to you later.
All right, thanks.
All of the slides will be made available soon.
Yep.
Thank you.
Thanks.
Okay, so next up in the last talk of this morning, before we head into lunch, which should be starting at 12, is by my good friend Brooklyn Zelenka, another Vancouver resident, and an Ethereum and a core developer, and a proposal which has been hanging around for a while, and I hope it will happen soon. Come on down, Brooklyn.
Thank you. Right. All right. Hi, everyone. So as Bob mentioned, it's right before lunch. I'm going to try to keep it as quick as possible, get some food in all of us. Prior to that, I'm going to be talking about ECIP 1050 or ERC 1066 on ETH, which is smart contract status codes. First, a little bit about me. I'm Brooke. I'm XSpeed, basically everywhere on the internet. I'm the co-founder and CTO of a company called Fission. We do, the short version is a decentralized Firebase with user-controlled data built on top of things like Ethereum and the interplanetary file system IPFS. I'm a programming language theorist and VM enthusiast, and previously did a lot of work as an Ethereum core dev, but now I'm mostly visiting from IPFS land, just because we're mostly working on storage these days. I'm the co-author of a number of EIPs. The two ones of note, I guess, are making changes to the EVM instruction set architecture to add subroutines and static jumps, something that didn't happen earlier this year, but now there's a lot of interest in again, so that would be really nice if that happened, and status codes, which is what I'm going to be talking about today. On ETC, that's ECIP 1050. The big goal of this project is three things. One, to help people write less code, i.e. introduce fewer bugs, ship faster, all of that. Have a higher confidence in the code that you are shipping and get better feedback about it. And make Ethereum more accessible to everyone. My 75-year-old grandmother in the Czech Republic should be able to use Ethereum instead of keeping money literally under her mattress. Today, everything's in English and sometimes in Chinese, and that's just a totally foreign system to her. At a very high level, the core idea is we can borrow things from Unix or HTTP. So just like how we have status codes on the internet that let us do things like provide user messaging, automated services, do microservices, all of that, we can have the same general idea with status codes on chain that talk between smart contracts. Because it's, one of the design goals was portability, so it's a single byte, which is, you can use really on any computer on the planet, right? We can read zeros and ones and in chunks of 8. So 1 byte, And that also means that it'll work cross-chain as well, right? You don't really care about the provenance of a status code, just that it is in this format. Here's some reasons to care about this. I mean, really, the three main ones were prior, but it's also a dependency in several ERCs. Security tokens are using them, for example. So a lot of regulated tokens are using these messages. It's approved, but not actually yet implemented as a primitive in Viper. And there's a lot of interest as well from people doing diligence work and smart contract auditing as well. It's also open to extension. About 40% of the codes are defined and approved so far. So these codes are all structured so that it's both easy for a developer to work with them, but also easy to automate them with directly in a smart contract. So we take a byte, we break it into 2 nibbles, which are 4 bits each. Here's an example of a code, 4.1. That's broken up like this. The first 4 are the category of thing, so time logic, off-chain flows, if somebody's authorized to do something, all of that. And then the second half is the actual reason. So you don't have enough authorization, right? Or it's a generic error. You'll notice that's backwards from HTTP, where 200 or 500 are generic, so that you start with the first digit and then the zeros to say this is a generic success or generic error. We flipped them around just because it was much, much easier to work with in practice to do it that way for the automated code portions. All of the even numbers are some kind of failure, and all the odd numbers are some kind of success. And then it gets a little bit more specific within that. So we often want to pull out that nibble. And then the other nice thing that we get from this is if you, say in the 0 column, so the first category is just 0, that's all generic, then the lower nibble is just what that one means, and we have this generic option as well. So in this case, B, we can just forget about the first 4 bits. As I just alluded to, this can be seen as a table, so columns and rows, where the columns are categories, time, range logic, agreement, off-chain flows, encryption, all of that. And then the rows are reasons, so something's accepted or started, or is out of range, or anything like that. And we can grab the 2 across, compose them together, and get an actual semantic message out of this, that we're awaiting a match. So even as a developer, you can there's a helper library for this, but you can also just, instead of having to memorize 256 codes, you just need 16 and 16, so 32, and you can reconstruct and read them directly. In terms of space, so again, 256 codes available in the space, we've defined around 90 so far. To put that in perspective, HTTP has about 65. So we're already more granular, with also a different design space, but more granular than HTTP already. The helper library, available on NPM, lets you do this in a more human-readable way, so you can break up the category and reasons and stick them together, so you can combine them or pull them apart if you want to do some analysis on it. Or there's some helpers as well for doing reverting to, so you can say, I expect a status code that's in this range, or that is a success, or that is specifically time logic, otherwise fail with a particular message. We can also automate the message portion of that too, which we'll talk about in a little bit. But for now, just know that it is compatible with revert, and you can put a hard-coded string message in there. A little toy example flow. So we have 3 participants on chain. We have some kind of token, a proxy contract of some kind, and then either a user or another smart contract or whatever it is. And then the lines are time. So make a request, hey, I would like to buy this token. So we'd like to buy for them, and we're not available yet. So maybe it's a security token and it's not been approved by the regulator yet, or there isn't enough token supply, more will be released later, whatever the reason is. So we're not open yet for business, but don't worry, we've cached that. We'll call you back when we're ready. And then that message can propagate back up. Some time goes by, the user is impatient and they ask, hey, is that done yet? And we respond again, 43, no, and then we can just revert the entire transaction because nothing actually happened here. Sometime later, this token is now open for business, the ICO is open, or the lockup period's done, whatever it is, and we can then say, hey, we're ready. You know, you have a few users waiting in queue. Okay, great, let's send those messages to buy for them. Great, that's complete. Propagate that back out to the users. And there's been some discussion lately about having user messaging sitting in a queue for things that have happened while you've been away from your computer. You could push that into these messages into such a proxy and then have those codes translated into the user's language. Today, a lot of this is done with either assume that there's success, revert, or return a Boolean. The problem with Booleans is they're not very specific about what they mean. It's just a true-false, right? Success or failure, but sometimes it doesn't really mean failure. It just means like I don't have them on the list, or any number of these things. So here's an example from the real world where this is helpful. So in security token context, we want to check if it's allowed to transfer a token right now. And so we have extract out this checking validator into a separate contract, so it doesn't have to live in each smart contract. So when you KYC your users, you don't have to do it for every single coin. It can just be live in, here's people that we know are real people and meet, whatever requirements, and then you can use that for all of them. And those can talk to other of these so that you have a partner that also does this or has different requirements across a border. They can talk to each other and make sure that everything's okay in a totally automated way. So the flow for that looks something like this. We have a token and a validator. We say, hey, I'd like to do this thing, and it'll talk to some of its friends. And today, we just get back false, right? So it might not be something that needs to be fully reverted. It just says, nope, they're not on my list. Maybe check some other lists. Check the next one. They are on my list. And then we check this last one as well. We check to another friend. And then we just get some trues back. And then we get back true. So we can't really do a whole lot with that without deeply understanding the smart contract that we're talking to. And even then, we're really only have this success fail or yes, no option. If we give a little bit more context, so in this case, it says the user is too young, right? They're not. We don't have them on our list for being, say, over 18. So you can actually skip this next check completely and then go and say, hey, is there anybody? Is this user manually whitelisted by some other authority? And then it goes through that flow and can come back and say yes. You can propagate that single message back through or change it to be a little bit more contextual to your specific use case because you're talking to many parties with, that are trying to handle many different use cases. It can get more tailored as it moves up this chain. And again, these might be different authorities in different countries, who have different requirements for different things. So specifically for a validator use case, that's really important if you want to say, do some securities trading between South Korea and the States, for example. And finally, user feedback, which I alluded to a little bit earlier. So revert, something that we have now, ETC, which is great. Back in back in the olden days now, something would go wrong and you just get an out of gas error. It's not very helpful. Now we have hard-coded messages, and it would be really great if users could get messages translated in their own language, localized and understood, directly on-chain. So using status codes, there's 256 of them. This is a translatable amount of data, right, or a number of messages. It's not an inconceivable amount of data to do this with. So you put a location preference contract on-chain, and then let people register localizations. There doesn't have to be special, official ones. Anybody can register one of these and plug it into this system, and then set themselves as using that. So as a demo, in the repo, we have English, Spanish, and pirate speak. So people can really add whatever they want into this. So a success flow looks something like this. We have a Japanese-speaking user. They want to talk to a smart contract. And they have an ETC wallet. They send a transaction that either does a read or a mutation on chain, doesn't really matter, and it sends back a status code. And that's actually the transaction is now complete. So the rest of this is just a lookup. So it actually costs 0 gas, right? So we'll say then separately, okay, so what's the text for this? I look at the user preference for tx.origin on my previous transaction, grab the text out of the translation, propagate that back up to the wallet, goes to the user, and we can display this right in the UI for them, while recording the generic status code for other people, like the number, so that other people can look at it and have it translated into their language. Let's look at a revert flow. So I have another user, another wallet, another smart contract, and we ask them to do something, and it sends a transaction, and that transaction reverts. So one way to handle this is to revert with just the code and handle the translation in the wallet directly. We don't have that built into wallets yet today. So we have helper functions for revert with this code, which goes and grabs the text for that, looks up the translation that the user has set, sends it back, and includes it in as if it was a hard-coded string, but hard-coded in the user's language. Which works with how revert messages are shown today. So status codes, obviously inspired by Unix philosophy and HTTP, which leads us to a networked web of contracts. So Unix and HTTP have a lot in common. You should be able to plug anything together, and you should have these chains of functionality that work, and it shouldn't, the idea is that you're not going to build everything totally from scratch every time. You're going to talk, in HTTP case, over the network to another service that does something for you, or to, in the Unix case, over a pipe to some other process. ETC and ETH are shared systems. And what people are mostly doing today is taking a bunch of smart contracts, sticking them together, editing a bunch of portions of that, overriding them, and deploying them. So even if the original contract was fully audited, we have proofs for it, everything, and then somebody goes and starts overriding functions, the proof's invalid. Right? So having deployed high-quality smart contracts that, let's say QuantStamp or Consensus Diligence have looked at and certified, and that the whole community can say, yes, we understand how this thing works, and we can plug into it, and it'll work the same way every time. The data inside of it is maybe very useful. So even in that case, deploying my own, I won't have that data necessarily, becomes very useful and needs to have a high degree of reuse. Right? We need to be able to talk to it from many different use cases that the initial author hadn't necessarily thought about in an automated way that doesn't require human intervention. And then the last portion from this is state rent, or even just collecting fees, because you can obviously send money along with the transaction. Is there a business model here for high-value data and high-value utilities on-chain making money? So it's almost a potentially a business model for open source smart contracts. Would look a little bit like this, just as a diagram. Right, so we can have some top-level dApp talking to several different smart contracts that can then, in turn, talk to others and others over a common interface, a common protocol. You could create new protocols, just like how TCP has this whole handshake. You can create more protocols out of this, back and forth with these status codes as well. As I just mentioned, you have these pluggable, high-quality, reviewed, security-hardened smart contracts. Which would be really lovely to see as ETC moves forward to build these out and make it much easier for people to get involved in developing smart contracts without having to know about all of the subtle quirks that can happen in smart contract programming. So, thank you very much, and I'll let you get back to lunch.
Any questions?
So what would this look like from the perspective of a smart contract developer? Yeah, so what would this look like from the perspective of somebody who's writing a Solidity contract integrating with these codes?
Mm-hmm. So let's see if I can just grab an example. All right, great. So here's a simple example. Instead of returning a Boolean, you return a byte. And that one byte is the status code of what you're trying to communicate back. So it could say things like, you're authorized, right? 0x11. The developer may put that in, hex and then 11, right, in Solidity. Or they can use the helper library, which would say authorization success, and then send that across. And it'll turn it into the byte for you. That costs a little bit of gas because now you're taking two enums, which are uints underneath, sticking them together and then casting it before you send it. But it's a little bit more readable. You can also consume these. So you'll get in a byte. You can look at it directly or pull it apart and do some analysis on this is success or failure. And there's an entire helper library with about 30, 40 functions to help you do that, and even do things like revert unless it is in a certain range.
And just to follow up on that, would this, let's say this standard were to take off, would it basically become like like safe math, for example, where there's like thousands of implementations of the same code, or is there any way that we can basically just create one thing in the blockchain and then everybody just plugs into that?
That's exactly the hope, is that you can deploy contracts right on chain that use this to tell a little bit more about what's going on in the response, makes it more reusable. And now people aren't redeploying the same safe math or ERC20 or whatever. We re-architect those. Safe math is actually a really good example because it doesn't require anything else. You can just call into it. And then exactly use safe math, which is, if you look at how smart contracts and Solidity are designed, they should be delegating out to on-chain, other on-chain contracts, but they're not right now. Yes?
Thanks for the talk. I was wondering, you mentioned that there's some support to Solidity coming, or in the works?
Viper.
Okay, sorry, Viper, yeah.
Yes.
Well, on that note, is there anything in the works in regards to Solidity, like for maybe some way you can just like throw the error and it'll automatically return stuff or something like that?
Yeah, so that's what the helper library is trying to do. You can just use it with revert or require. There's a helper require OK function in the helper lib that will, again, you can either say require OK will require it be an odd number, or there are further ones that say require a particular status code or a particular category or reason.
Cool, thanks.
Yeah.
I got one here. Can you talk a bit about the Viper integration, what that kind of looks like?
Of what the library looks like?
Yeah.
Yeah, sure. I mean, I can also show you literally the library after, but it has enums for category and reason to help you read a little bit better. So you're not just looking at just straight numbers all the time. You can say this is, time out of bounds, for example, or time expired. It has functions for working in different types. So if you don't want to be working in hex, you can be working in uint8. You can pull a status code apart into the category and reason. There are helpers for translating between that. There's one column for application-specific codes. So if you have something that's not covered, you can define those. And there's a translation to get from that into this library. And then a bunch of things for revert and translations.
You're saying it costs a bit of extra gas to do like the string conversion. Could there be some sort of extension to Solidity where you wouldn't have to have that extra gas?
Absolutely. We'd have to build it into the language directly. I would love to see that be the case, but
Cool. Yeah. Thanks.
Yeah. Great. Thank you.
Thank you, Brooke.
Thank you. Ooh, yum.
So that's this morning. We're done. Go eat food outside, and we're back here at 1. Thank you. So hi, good afternoon. So we're going to start this afternoon with a talk by Terry Culver, who is the CEO of ETC Labs. I have been talking with Terry an awful lot over these past few months and really got to build a good working relationship and trust. And you know, ETC Labs have had a huge contribution into the change that we've seen on ETC this year. You know, we are really moving, and an awful lot of that effort is coming from you know, developers and investment on their side. So really happy to welcome Terry to the stage.
I don't get a hug? Here we go.
You know, I don't want to intrude.
Hi there. So the talk after lunch is also known as the nap talk. So if anybody nods off, that's perfectly fine. If I nod off, someone prod me. So I keep talking. Let's start with the Gambia. This was my first project out of college. And to my mind, throughout my career, it's been a cautionary tale about adoption of technology. We were hired in 1993 to build a computerized tax system. If you don't know, the Gambia is a small sliver of the country on the west coast of Africa, surrounded by Senegal. And they had been depending on a British colonial paper tax collection system, which certainly wasn't efficient, if it ever was. And the government was hoping that this new system would put them on better financial footing and increase payment rates. The Gambia, like many countries, suffered from you know, low participation in the formal economy. It still does. After 3 years, after building a digital tax system, after building a data center, after assigning everybody in the country tax ID numbers, after creating what we thought was a successful project with both political and social support, it all came to a grinding halt 2 weeks before it was supposed to launch. A colonel in the army, Yahya Jammeh, took power in a swift and decisive military coup. None of us saw it coming. And it was pre-internet days, or pre-mass adoption of the internet days, and certainly pre-cell phone days. So this was crisis management by fax. And our first concern, obviously, was to get our team out, which we did. And our second concern, obviously, was the future of the project, which we felt was important for, you know, the population. You know, Jammeh claimed that he would give power back within 2 weeks and return to a democratic system. As these things go, he stayed in office for 20 years and only left in 2016. And as you can imagine, our tax reform project never went anywhere. And that story sticks with me. As we think about the technology that we're building here, that many of you are building, as excellent as it may be, its adoption and implementation may very well be subject to political and social influences well beyond our control. And so to my mind, it's important to really have at the forefront of our thinking how this is going to be used, what resistance it's going to face, and who's going to resist it and why. Since the Gambia, I went on to work on a number of projects for the Harvard Institute for International Development, the United Nations, several countries directly in Sub-Saharan Africa, India, Bolivia, and so on. And in the course of that work, my colleagues and I always came up against certain systemic issues that would hinder us in what we were trying to do, things over which we had no influence. And around 2015, I started to look at blockchain as one possible way to deal with some of those systemic issues, a way that you could avoid having to deal with corrupt or weak institutions, a way that you could deliver to people a mechanism for peer-to-peer exchange or a certain kind of economic independence. It hasn't provided that yet, but I still think it has the potential to do that. And that's why I'm here. That's why one of the many reasons why we established ETC Labs. And that goal is really what informs our mission. We are trying to do three things, more complicated than this slide would indicate. The first is obviously build high quality technology. And you know, I come to this not as a developer. I'm sure our development team will confirm that emphatically. And I don't come at it as an investor. I come at it as a humanitarian. And you know, even with that, the core of everything we do has to be the technology. It has to be innovative, has to be sound, has to be robust. The second is we're committed to building what I think of as communities of value. And by that I mean communities where people can engage in economic activity in a peer-to-peer way, in a trustless way, in a way that you know, can only be achieved, as far as I know, through a blockchain. And also communities of value where you have a certain amount of economic independence and integrity that can only be derived from a public blockchain. And that's really what led us to Ethereum Classic to begin with. And then the third is fulfilling the social promise of blockchain, which I'll talk a bit more about later on. Before I talk more about ETC Labs, I'd like to just take a minute to acknowledge something that maybe we all know but don't talk enough about, which is that ETC is growing. You know, what started as an important statement about governance and immutability has turned into a major public blockchain. That's no small feat. And it's in large part due to many of the people here in this room. And so I'd like to just take a minute to, you know, give respect and credit where it's due. You know, Anthony, you know, I think you've really been at the forefront of that. Donald, Kevin, many of our developers. You know, I hope you can take a minute to just acknowledge what you've accomplished. So. And then also our development team, I think, is working away at a great pace. You know, you can look at the number of commits and the work happening on the development side. And you can also see the growth on the community side, which we count as somewhere upwards of 15,000 people, maybe more. We expect that growth to continue. And it's, I think, all moving in the right direction. If you don't know, the dev team is organized into three sort of sub-teams. One focuses on tooling with Shane, Zach, and Zane, and they're, I think, all here. We have the protocol team that works primarily on the client, and then we have the EVM team. And as I mentioned, they'll talk much more about what they're working on. But we're really proud that they're part of ETC Labs. I think, you know, those developers could be doing other things. They could be working with other organizations. And we're really happy that they're working with us and working on ETC. We also have key technology partners. You know, we don't think that we can do this alone or should. So we work quite closely with ChainSafe, and Aiden is here today, I think. Hey, Aiden. And also with Whiteblock. We'll be adding to this list of partners in the year ahead. But we think that they bring additional expertise, additional insight, and additional perspective that helps us as we grow. And then in terms of creating communities of value, you know, there's a couple different expressions of this. We launched earlier this year what we call the Studio Program, and that's an effort to try to encourage projects to deploy on Ethereum Classic. We've signed up more than 12 projects now, as well as certain channel partners who will bring additional projects to Ethereum Classic. You know, it's all well and good to have a blockchain, but if nobody's using it, that's a problem. So this program is really trying to solve that problem in an accelerated way. The second is that coming this year, we will be launching a whole bunch of bounties and hackathons. We are in active discussions with Gitcoin, and I think Scott might be able to talk a bit more about that later today. But please stay tuned for some good news there. And then the last is that we will be launching later this year a managed index service for Ethereum Classic. So an Infura-like service that will be free It will supplement Yaz, your good work with Ether Cluster. And we feel that this is a necessary piece of infrastructure that needs to be in place in order for Ethereum Classic to grow. The other thing we're doing is we're actively looking to collaborate more closely with the Ethereum community and ETH1X. This, I think, is a subject of active debate in our community. It's, Ethereum Classic was established around the principles of immutability and security, and rightfully so. We'll stick to those principles. We're committed to a proof-of-work consensus algorithm. Nonetheless, we do share some values with the Ethereum community. We share DNA. We share technical functionality. This is reflected in our technical roadmap. It's reflected in the partnerships that we're developing or trying to develop. And so it makes sense to us that we should work more closely together. We believe that we can do this while maintaining our core principles, that collaboration does not necessarily mean compromise. In fact, just the opposite. I think this is something that we feel strongly about, and I think we'll have more details about that as this develops later in the year. It's in the early stage, but it is a core commitment to our work in the year ahead. And then our accelerator. And where's Liz? Liz and Ankit. I don't think ETC Labs would really be anywhere if it weren't for the work that you've done around the accelerator. We've just started our third cohort in the labs. And we're seeing more applications. We're seeing more mature projects. We're seeing a higher degree of technical ability. And we're seeing true commitment to public blockchain, all the things we want to see. And this is really an effort to develop the ecosystem. It's, I think, a counterbalance to the development work that the core team is doing so that you can grow at the social level as well as at the technical level. And we'll still be offering the same things the accelerator offers, office space, investment, financial and business development support, technical support, and introductions and network building to technical partners, financial partners, and other partners. And just to give you a sense of who is in the current cohort and who's, I think, growing in a really positive way, here's a quick list. I won't run through them all. Some of them like Ethernode. I think they're speaking either today or tomorrow. And Second State is here. They're collaborating with us on the LLVM work. And they just launched their BITL IDE, which will make it easier for developers to build on blockchain. So I think the accelerator is really moving in a great direction, and we expect continued growth there. The last thing I want to talk about is what I mean by fulfilling the social promise of blockchain. We have very much in the forefront of our minds three fundamental transformations taking place. The first is demographic, and this map shows it. It's a proportional map showing the distribution of the global population by the year 2050. By that time, there'll be approximately 9.8 billion people on the planet, most of whom will live in Asia and South Asia. Coinciding with that population growth will be mass urbanization. So for the first time in human history, most people will live in cities. The second transformation is financial. Already there are hundreds of millions of people who do not participate in the formal economy. Some estimates place it somewhere between 60 and 80% of the population in emerging markets don't have a bank account, they don't pay taxes, they don't appear on any formal kind of economic activity whatsoever, but yet they make a living. This will only increase in this part of the world as the population grows. And then the third transformation is digital, something about which we all know, and many of you know better than I do. Our being here is a testament to our recognition of the digital transformation taking place. Put together, all this means that in the next few years, most of the people will live in a part of the world that doesn't have the necessary infrastructure to support them. They'll live in urban areas and high concentrations, and they will earn their livings and make their lives in ways that are unfamiliar to us in mature economies. To me, this is an exceptional use for blockchain. We often think about blockchain adoption as a trade-off between censorship resistance and transaction finality. But for most of the people in this part of the world, they've never had transaction finality. If they're in the informal economy, that doesn't exist. Even if they have a bank account, transactions are slow, the institutions are weak, or the people within them are corrupt. Even if people buy land, it's never quite clear that they actually hold title to it. Even if they accumulate some form of wealth, there's always political risk that it could disappear. So the idea that you have to have this trade-off, it's certainly something we think about in this part of the world, but it's something that people are already experiencing, and therefore I think the threshold for adoption is very different in the world that we will see in 2050 than it is now. So as we think about the partnerships we engage in the year ahead, as we think about the technical roadmap, it's really working towards a point where ETC and blockchain more generally can provide service and resources to the people who will be living in this part of the world who currently don't have them. Thank you for listening to me. I hope if you got a nap, it was a good one. And if you stayed awake, I hope it was worthwhile. Thanks.
Does anyone have any questions for Terry?
Yeah.
Thank you. So what then do we need to put in place now to facilitate this adoption at a greater pace? Yes, there's recognition of value elsewhere, but sadly we, for better or for worse, appear to be the decision makers in the first world to establish these patterns. And I hope that does not remain to be the case, but the fact is, what can we actually institute now and where within our societies to open up minds to the adoption of these new frameworks?
I think it's a tough question. I think the first two things that we have to do is, one, stick to core principles. I think despite whatever resistance there may be, we have to stick to the core principle and value of a public blockchain. That's where, people in this part of the world are going to start to see the real value. That's where the adoption, even if it's more difficult at the beginning, is going to be greatest. I think the second is we have to be willing to evolve while maintaining those principles. We are in the very early stage of figuring out what this technology is and what it can do and how people can use it. So, we probably don't even really know yet where people are going to find the greatest value in it. So I think we need to be open-minded to it for surprises, for discoveries, for unexpected things. That's it. Okay, thank you. Oh, Kevin?
How committed is ETC Labs going forward with Ethereum Classic? Could you give maybe 5 years, 10 years? What are you thinking?
This is till death do us part. We're all in. I don't know what else to say.
Sounds good.
All right, thanks.
Thank you, Terry. Whoop. Okay. Next up we have Aaron Lowry, who was one of the first cohort at ETC Labs, working on Ethernode, which no doubt he's going to tell us a little about here.
A little bit. Try to keep a lot of the focus, thanks Bob, more on some basic educational principles related to network infrastructure, and maybe get a little bit of a bigger picture view of some of the challenges that are faced in our attempt to develop functional D-app ecosystems and attract users in ways that provide meaningful and lasting value to them. So I think there's a general consensus around the fact that we're looking for these viable distributed applications to provide some fundamental value to these blockchains in general, specifically ones running an EVM. And so it's really important if you're looking to try to begin engineering an application that can provide value to an end user, that you understand the network constraints that we're dealing with and engineer appropriately. So I'd like to start by taking a quick look at these network depictions and go over some of the contrasting elements of them. And the public network architectures that are depicted here show the internet on the left and an Ethereum virtual-based machine environment on the right. And you can see there's sort of a scale for decentralization there. And these are terms that we utilize pretty freely, things like decentralized permission versus permissionless. But it's not always clear exactly how we're defining these things. So the internet is sort of a centralized yet decentralized network. It involves a lot of hard infrastructure that we take for granted frequently, especially in countries like the United States, Western Europe, and places that invested heavily in them. It involves a few significant players at the top rungs, and it's very has a very distinct hierarchy of permissioned services. So to give you a little bit of an example, and we're all pretty familiar with this, if you work from the user out, you are accessing this public internet through a permissioned device where you have a MAC address that's attached to a modem, whether it's a cable modem in your home or it could be a mobile modem in your phone. Regardless, you're using a specific hardware address, and it has to be permissioned by your internet service provider. Now, your internet service provider most likely is just local or maybe even regional, but they're also permissioned to connect you and your data to the rest of the existing infrastructure. And this contains for a lot of this stuff is kind of elementary, so many of you probably are familiar with it, but maybe some people who are watching won't be. This is then run through a series of, you have DNS servers to resolve names. You have data centers to distribute and store most of this data because it's economically inviable for us all to be pulling data peer-to-peer all the time. And there are numerous points within this network that have different vulnerabilities. And a lot of these vulnerabilities are addressed in a distributed network scenario. You have, instead of a hierarchical kind of construction, you have basically an equal peer network, and that is truly permissionless to join if you run a client and it meets the qualifications to join the network. It doesn't care who you are operating it. And so these are very fundamental properties to these networks that provide a lot of value to them. Now, the challenge that we have here is that the blockchain networks that we're hopefully participating in if you run a node, or at least accessing through someone else's node, you're still dealing with this entire hardware infrastructure of the current internet. And it's kind of depicted here with some of my limited design skills. But you can see pretty clearly, if you're the user and these are your your devices that you're connecting, like this is pretty much how it goes. You go through your router and your modem, and that's connected and permissioned by your ISP, and then that spreads out to some routers and switches, and like these are all points of hard infrastructure. They're privately owned in most cases, and you're paying a service fee just to access them. There's also some of these other points where I mentioned of potential failure, or at least vulnerabilities through DNS servers, data servers, and this is all really interconnected through a relatively limited but fairly robust network of fiber optics, most in general. Now, when you run a blockchain node, you participate in one of those decentralized, distributed types of networks that we described before, and this image tries to depict a little bit of how these look. Now, we use our InKeep logo here to represent a node. This is a piece of node hardware that we've developed specifically to make it easy for individuals and enterprises to host blockchain nodes in a local environment. But you'll notice even in this, this infrastructure here, you have the node is still behind your modem. You can't connect to the rest of the network without that key piece of hardware and the permissions that are involved with it. But once you do, you can see here it starts to develop the properties of a distributed network, but it's still all running on top of that other existing infrastructure. And these are, this is a scenario that's often not really well addressed when we're trying to imagine or engineer distributed application systems, because the vulnerabilities to the core underlying network are extended to the blockchain networks that we're operating on top of them. So in an example like this, and I think I wanted to point this out as well because you don't hear a lot about it, but these EVM networks are all one network, even though they have separate blockchains and different data ledgers running on these nodes. These all actually talk to each other all the time. So here, you'll have an Ethereum node and an ETC node and a Kadi node or a Morden node, and the actual data ledgers that they contain are different, but they all have an eNode address, and they're capable of communicating one with another, make handshakes all the time. And this is an important point because let me touch on this too. So this is a brief interjection about Ethernode here and our InKeep hardware. It's actually designed to replace a router in this infrastructure setting. A node is your blockchain gateway, but it's still a gateway that's behind your modem, your internet gateway. But there's a pretty decent argument to be made for running a node and a number of features of blockchain specifically that you can't access or utilize if you don't. One of the key things is having an actual network identity. This is depicted as an eNode address, and it gives you actual peer status within the network and an address that you can send and receive transactions from, enabling P2P interactions and utilizing different protocols like, for instance, Whisper, which is in the Ethereum client, for transmitting secure encrypted data across the network without necessarily involving network fees because you're not hashing into the blocks. You're also reducing your dependencies. The underlying value proposition of a public blockchain is trust minimization. You really are trying to eliminate the number of parties that you have to rely on for valid access to your data or handling of your data. And if you're relying on, say a centralized infrastructure solution like Infura, you're reintroducing a lot of that, those vulnerabilities that you'd portend to be trying to eliminate in the first place. So it's really critical when it comes to just blockchain interaction. And it gives you the ability when you have a copy of a ledger living locally on a piece of hardware to query it very quickly, very securely, and with a lot of flexibility. So these are really critical elements to or justifications for running a blockchain node and participating in a blockchain network. So a lot of what we do is combining or recombining different technologies. And events like this are a good example of kind of how this occurs. Like Zane was talking earlier about the service runner. These are the kind of technologies that we've been integrating into the operating system that we developed to run on the in-keep hardware, and is kind of the fundamental basis of ENOS, which is our Linux-based blockchain operating system. So one of the things that we've done here, and you'll notice on this slide I've shown, we use what we call the NAPI, and this is, we've developed all the software in fairly modular components, and many of them utilize technologies that are developed by people here, and some other technologies that are very commonplace and some quite old. But the NAPI is something you can use standalone or with the other features in the software, but it's based on OpenRPC spec JSON RPC, and allows you to interact with the nodes that you've hosted locally in a lot of standardized but dynamic ways. In the NOS interface, you can click a button, host a variety of different nodes, and then also run applications that have the ability to interact with one or multiple nodes at once. Also using things like a local wallet so you can sign transactions and really begin to automate a lot of these things in ways where everything happens, all the processes happen locally. You're not reliant on any third parties for any of the interactions you perform. It's especially valuable for people who are doing development or in many applications like this, for say like an enterprise solution where maybe you want to run a private permission chain on one side where you're accumulating large amounts of data that would be uneconomical to process on a main chain, and then with the ability to write data to a main public chain as well, where it can be trustlessly verified by third parties. One of the things that led us into blockchain a number of years ago, because we come from a background of IoT systems and system deployment, and so we were attracted originally to Ethereum Classic because at the time it was positioned as a blockchain for IoT support, IoT data transmission, and that hasn't yet materialized, but we're constantly working, recombining different technologies to help enable that, and do so in a way that's as decentralized as possible while still operating within sort of the underlying fundamental constraints of an internet-based system. So this is a sort of a brief but descriptive depiction of how we're currently sending IoT data across public networks, but in a manner that's economically viable. So we use the Whisper SSH client running on like a light firmware on an edge device where we can take and parse in data from a variety of sensors, and then hash that and send it off via a bytecode across the network, where we can subscribe to the topics that it broadcasts with a base node, and then we take that data and decrypt it and parse it into a database there. And from that point, we're able to utilize it in kind of whatever manner is applicable based on the use case. And these are the kind of transactions that you really are only going to be able to perform if you're running some type of a client where you're part of the network. If you're trying to do any of these kind of processes without running a node or some sort of a light client, then it's pretty much unachievable. That you might as well just stick with a standard kind of IoT system. But all of these things, again, are constantly kind of in development. I think the Fly client work that Zach was talking about earlier could be hugely impactful on especially the edge side of these kind of equations. And so we're just working to constantly integrate a lot of these tools. The platform of ENOS allows us to do that pretty readily and take tools from, say, an IDE to a wallet to basic applications like that, and just integrate them right there in the operating system where they run locally, and you can interact with them in a secure and local manner. So feel free to hit us up anytime. We are happy to hear about projects people are working on, ways that you want to utilize these kinds of networks, because a lot of times the value proposition for them is still kind of undefined. We're still based around this idea of trust minimization as the fundamental purpose of utilizing blockchain in the first place, especially in a public and decentralized manner. But we face a number of challenges, specifically in the fact that it's still based on the current network infrastructure of the internet. One note on that front, we also, in the in-keep hardware that we build, it's all mesh network enabled. So this has very sort of geographically limited implications currently, but it is the kind of technology that can enable a freedom from that base of the current internet that we're currently operating on, and open up a whole new realm of actual decentralization and distributed network potential. So thank you.
The NKeep is a hardware node, no?
Yes, sir.
That someone can have at home or the office. What client does it use, and does it ship already synced? So you just have to get the last few blocks, or does it ship empty and you have to synchronize? We ship the hardware unsynced. That's an extension of our desire to kind of promote trust minimization. I guess it's kind of a little bit of a toss-up there. If you pre-sync it and then let it catch up, you're still going to, once you reach the end of the chain, you're going to be able to validate the whole thing. But we support currently Geth and multi-Geth in the client, and formerly Mantis as well, but you have options in there. As you go to spin up a node, you can select which chain you want to run a node on. Multi-Geth is very good for this because it's supporting all these different EVM platforms. But yeah, you have options whether you open RPC ports or not, configure which type of sync you want to perform, archive to a light sync, to try to just give the user some flexibility and all that as well. And also it supports the POA click network. So you could host a Kadi node, or you can create your own POA chain with a click of a button there as well.
So I just have a follow-on question for that. So you were using Mantis until it wasn't supported for Atlantis. So what was your experience there with Mantis?
We think Mantis is an excellent client. It's beautifully written. It's extremely efficient. It has a smaller footprint. The challenge that we ran into with specifically for the InKeep is support for ARM architecture. So the InKeep is an ARM-based processor, and currently, obviously Mantis hasn't upgraded to support Atlantis, but even previous to that, it was just running on x86. So that was sort of a challenge right there, but it's a very well-written client. It's a good piece of software. Very good.
So that's actually, ARM Linux is how my Ethereum adventure actually started, was porting CPP Ethereum to ARM Linux. Mm-hmm. And yeah, I know the challenge.
Yeah, it is, and we're not Scala devs, so we're kind of limited on our ability to kind of compensate. Yes, sir.
In your opinion, what do you find one of the biggest hindrance or challenges to implementing this distributed network? Like getting these nodes out on a large scale?
In a practical sense, a lot of it is a value proposition for the customer. And I think that there's a better argument right now for a value proposition for things like enterprise deployment. Although I'd love to see users everywhere running a node, syncing a hardware node in their home and all that, and we developed hardware to help facilitate that. Without good, useful applications that run on top of it, it's really only appealing to developers or maybe people who want to pull real-time data from chains for trading purposes or some other things like that. But user adoption really is about developing applications that are value sustainable for the customer and the end user, and those are still to be developed, I would say, in many cases. I think on the enterprise side of things, there's a very good value proposition for private permission chains that are used to aggregate data produced, whether it's in, say, manufacturing or supply chain environments or something like that, where you can accumulate it in an environment where you get the benefits of blockchain, which are mostly in these applications used for compliance and audit, those kind of usages, but also have that in in an environment like we've tried to facilitate with NOS, where you can have your own private chain running here and all your datas go in there because there's a lot of it, and you could never economically put that on a main chain. But in an environment like this, you can actually take your data that you're producing from your private chain and snapshot it or incrementally publish it to a main chain for trustless verification.
Like on the other side of that, like how attractive would it be to Ethereum Classic developers to have access to a larger node system? Would that?
I'm not sure how to quantify the attractiveness, but I think there's a benefit for everyone involved in the technology if widespread distributed node ownership and usage grows. It adds robust nature to the network. It reduces latency times, and in many cases, and a healthy distributed network is one that has lots of participants. And if you're not running a node, you're not participating. So it's of benefit to all of us. Tangible benefits for users, it really depends on use case.
Earlier you spoke on the centralized permission levels within internet connectivity.
Yes.
With recent concerns such as net neutrality in the States, are there any plans to circumvent issues at higher tiers, such as replacing servers, for example?
So I think the answer to that lies within technologies like mesh networking protocols. Short of that kind of actually distributed network where the users are all peers and you don't have sort of the hierarchical structure where at different points it could be cut off or limited or restricted, then that would be an ideal environment from a networking standpoint. Practically transitioning from what we have today to something like that there's a lot of entities that would be highly disinterested in that occurring, and so there's some challenges there, and just the practical aspects of transition are substantial. We'll still work for it, but yeah, it's challenging.
Question. So what efforts, if any, are being made with regards to framing this kind of in the public good? Schools, libraries, universities are running this infrastructure, not so much for, quote unquote, the proprietary usage of a particular blockchain, but to create redundancy with regards to mesh networks, a secondary layer, et cetera, a whole other layer of utility that could be run. And there just also happens to be this, the blockchain functionality built in there. So, Samsung's done this with their phone, for example. What, if any, efforts are being made with regards to establishing these partnerships with hardware manufacturers so that this is an additional option or module that could simply be included with the purchase of this commodity hardware?
I don't know if I can speak to that in like a comprehensive large scale, because I don't know exactly what advance or intent some people or organizations have, or what kind of actionable measures they're taking on those things. But I think probably realistically the most impactful ones involve things like low Earth orbit satellite from an actual network and even mesh network propagation kind of scenario. On a institutional level, like you're saying, I think there's a lot of value, especially in larger distributed, private systems for viable and efficient backup and redundancy, and it's something that we have a geotelematics company. I've done this for a number of years, and it just runs an SQL database, and it accumulates tremendous amounts of data. And in order to provide the kind of safeguards for that data and for our customers and all that, we have to run multiple redundant backups that are distributed around geographically and things like that. And you're able to achieve a lot of those inherently by running like a private blockchain network. The nodes that you run on it, they're just naturally going to be distributed backup and redundant systems. So I think that's one of the greatest benefits to that kind of network architecture from a private or institutional or enterprise kind of standpoint, for sure.
Thank you.
Thank you. Gracias.
Thank you. So yes, next we have Scott Moore, our Canadian buddy from the wrong side of the country. He's come over. So Scott Moore worked on Gitcoin, which you may or may not know about. So Gitcoin is not a coin. There was not an ICO.
Actually, very important note, yeah.
Indeed. But it is a mechanism for basically, bounties or rewards where people can incentivize people to fix issues on GitHub projects. by putting a bounty on it and that being paid out.
Awesome.
Thank you.
Thanks, Bob. So I'm here to talk a bit about Gitcoin, but I'm more broadly here to talk about open source, which kind of underpins everything that we're doing, not just in Web3, but historically in the web and in software generally. So I guess to start to frame the conversation, just want to give you a bit of background, what is open source? What does it mean for something to actually be open source? This is not a canonical definition. There's lots of different interpretations of what open source means. But in general, the source code needs to be available. It needs to be royalty free. There needs to be effectively free distribution of the software. And it needs to retain the original software license. So there are many of these licenses. There's MIT, there's GPL. There's a lot of new ones coming out actually, which are aiming to have some kind of ethics built into them around some of the current controversies, mainly in US tech, which I won't get into in too much detail. But some of these characteristics can be swapped or modified. This is just the baseline for what open source actually is. And so why do we care about it? I kind of alluded to this, but it's actually a huge number of applications that use open source. 96% actually rely on open source software. It's pretty much every piece of software that you might use. I actually think this is slightly outdated at this point, and it's probably slightly higher. But it really doesn't matter whether it's 96 or 98%. At that point, we should really give a shit about what open source, I don't know if I can say that up here, but about what open source is about. On average, 57% of code, again, is from open source software. And it's, if we want to give economic value to it, about $400 billion worth of value. I probably should have edited this slide, because you'll notice below that there's an ETH value there, which is also out of date, by the way. But in general, the important point to note here is that open source generates a lot of value, not just for the blockchain ecosystem, but for the general open source ecosystem and for the software industry generally. So why is it that there's only maybe 1 to 2 maintainers per core repository? Why is it that so many different pieces of software that we rely on, for example, OpenSSL, most packages within the NPM ecosystem if you're a JavaScript user, lots of Rust packages, lots of pretty much any software package in any language you can imagine, all the way down to the Linux kernel development. Why are there so few maintainers for these pieces of software? And largely, although there's arguments to be made about this, one of the major reasons is that there's no pay for open source work. So actually, 62% of respondents in this recent survey, which was done in part by libraries.io, were self-funded. And then the remainder, the largest second percentage, were basically given money by their employer to do it. And then there's a long tail of other options. There's consulting, there's crowdfunding, there's grants. These are all okay options, but they don't really solve the core problem of what basically a sustainable open source software ecosystem would look like. And this is particularly important today because the scale of software, as we've all seen, is growing pretty exponentially. 208,000 users were basically using SourceForge back in 2001 in a 2-week period. 31 million now are using GitHub. So it's a pretty large increase. And yet, the same amount of work is being done by, orders of magnitude more work actually, is being done by the same amount of people. And so it's not surprising then that you get cases of burnout. This is just one example of Semantic UI, which was sort of like a Vue.js or a React style front-end library, which was basically after 3 years, sunset just because Jack couldn't pay the bills doing it. A more prominent example is OpenSSL. This is probably a bit hard to read on the screen, but in short, OpenSSL was, and still does, power a lot of security on the web, and it was maintained by 1 or 2 people. There was a huge vulnerability in 2014, I believe, called Heartbleed, and then people started to care because this package that had been kind of relied on by everyone for so long and not funded was suddenly causing them problems. Just one more example, which is relatively recent, with the event stream library, which is a just popular NPM package. This is actually just an anecdote from Dominic Tarr, who wrote this library, which I very much empathize with, which is like, okay, so he worked as a dishwasher in this restaurant. He made the mistake of being too competent. He got promoted to cook. He got like a 50-cent pay raise. That's great, but being an open source maintainer writing a popular module is like this times a million without the pay rise. So it's actually slightly worse than getting a sort of like position as sort of like a promotion within a kitchen to a cook. And like both of these types of work are extremely important, but it's clear that Dominic Tarr's work and the work of these maintainers is affecting just a massively larger number of people. So we should really be like considering why is it that the work that they're doing isn't proportionally being compensated. So how do we solve this? We obviously have a bias towards our solution, but I think that this is just one framing for the general problem and one solution that could be considered, which is this magic instrument of money we've made. So programming basically money, programming our values into money, gives us the ability to actually fund more open source software, and it incentivizes communities like ETC, like ETH, like Bitcoin, to give back to open source in a way that didn't really happen before Web3 was kind of like coined as a term. And fundamentally, the reason for this is partially selfish. It's partially that we have the ability to like gain money or value for ourselves by giving back to these like core pieces of infrastructure that are open source to begin with that power our ecosystems. But at the same time, it's just a general ethos that I think has permeated Web3 culture, which is open source has value on its own and should be supported regardless of what the core intention is of it. And so as a result, we see a lot more open source projects being funded in Web3 than we did in previous iterations of the web. And so our mechanism for sort of getting some of this value that is being generated in open source and given back to open source is bounties, first and foremost, as Bob mentioned, which is essentially taking money from funders and giving it to coders per GitHub issue in an open source repo. This is just one approach, and it sort of is a way to get people started in the process of building open source software. It's effectively a way to get users of open source software to become contributors in a very granular way. So this is just an example of like a small 60 DAI bounty on a parity repo, very simple sort of like initial problem, very small initial amount, basically gives people the ability to think about these problems and get involved and get some funding for it. And so far we've done a pretty good job of like growing this ecosystem, just some stats like 500 plus funders, 20,000 plus developers, 4,000 or more transactions, and then that's since 2017. But the more important part actually to me, rather than user and contributor, which is actually pretty important for Web3 right now, is getting contributors to become maintainers. And that's really where we've started to put a lot more of our effort. So we started this grants program, which is actually just finished its third iteration, basically a kind of patronage model for open source, a way to basically give back to individual maintainers and then give them agency to use those funds as they choose, either to pay other contributors or to generally fund their own work, their own time. And so we did a round originally, which was 50K plus contributed to open source. We had basically this capital constraint liberal radicalism matching model, which I won't get into in too much detail, but essentially the way it worked was you had the ability to fund any number of projects to signal your interest, and then the square of the sum of the square roots of those amounts would be matched. So if two people gave $4 each, the matching amount for that particular grant would be $16, and if 8 people donated $1 each, the matching amount would be $64. The point of that is that the signal is getting more and more valuable the more and more people contribute, not necessarily the more money that's contributed. And this was just the paper that started it. It was by Vitalik, Zoe, and Glenn. And this is just a representation of what that looks like. So the same amount of actual money is being donated in each of these bars, but the number of contributors is increasing in each consecutive bar. So the point is, let's make funding more democratic. Let's match people based on the actual democratic interest in a project. And we've done a few rounds of this, so here's just a few examples of projects that have been funded to date with this model, and a few more. I won't get into too much detail on these, probably something that would be worth looking into afterwards, though. And we just finished our third round, which is actually the largest one yet, which had about 250K donated to open source, including matching funding, and 1,500 plus contributions. So this is actually, surprisingly to me actually, starting to become a really valuable model. If we're getting a lot more people donating to core maintainers than was happening in the ecosystem previously. Because although we're better than Web 2 at funding open source, we're still not great at it. There's still a lot that can be done to improve how we're supporting maintainers. But this is all still patronage. So all the models I've talked about so far, either giving money to contributors for their work, or giving money to maintainers to continue their projects, is largely reliant on the kindness of strangers to provide them with funding and ensure that they're able to make ends meet. But what are some other models? These are a few more controversial ones that I just wanted to touch on. I'm not necessarily saying I advocate for them or support them. But this was an EIP 1789 within the ETH ecosystem, which was largely around trying to add some form of dev fund to the mining rewards. There was a recent similar proposal, 2025, which was for 1.x block rewards. Both of these were sort of received very controversially. Some people were like huge advocates of this model. Some people thought that this was going too far or was a deviation from the actual ethics or values of the chains that they were being proposed on. But regardless of what you think of them, the important thing to note about these models is just that these are experiments around how we can fund these maintainers who are, again, like being generally overworked relative to what they're being paid in a more sustainable way, such that we're not relying necessarily only on the kindness of strangers. A similar model, which is sort of more, I guess, opt-in, is like a support contract model. So, if you use the software as an enterprise, maybe you should be paying a fee to get support on that particular piece of software. This is what Firas Abukajije suggested a month back. He's been running this experiment where he's basically been offering consulting on his NPM packages. For those of you who don't know, he runs, I think, over 100 NPM packages. He's sort of like one of the maintainers on each of those, some more than others, cumulatively, which have about 100 million downloads a month. And so this is a good example of an experiment in open source funding, which is super useful for, I think, and worth considering for our ecosystems here too. Another one, which is, again, controversial, is advertising. So this is another Firas example where he put an ad in his NPM install, basically, CLI. So basically, you would see an ad every time you tried to install one of Firas's packages. And lots of people are pretty angry at him about this, which is, I guess, kind of reasonable. I can see why that might happen. But I think the point of this experiment is more interesting than that, which is he kind of showcased that people are very quick to get angry about things without actually doing anything. And so like, I think that largely speaking, what he showed was, hey, here's like an idea, here's a model, and he just got people thinking about this problem in general. And I think that was helpful, even if you disagree with the model itself. But we're actually sort of biased towards at least experimenting with an advertising model. And so I want to touch on one project, which is sort of part of the Gitcoin suite of projects called CodeFund, which has largely been focused on a more ethical advertising model where people aren't tracked, people aren't being basically like sold in the same way as in traditional advertising. And what this has done has actually like been a great way for Rollbar, for DigitalOcean, and for other major players in Web 2 it's been a great way for them to basically get the attention of large open source maintainers. So there's two ways this works. This is actually based on an older project called Code Sponsor, which Eric Berry started before pivoting to this model. Code Sponsor was effectively ads on GitHub repos. So every GitHub repo could have a sponsor. That sponsor would be facilitating basically the work that this maintainer is doing. This is an extension of that where he's gotten a list of publishers and a list of advertisers, but basically whitelisted them in a way where he knows that they're valid, he knows that they're doing good work, and leveraged that to make sure that there's at least some amount of targeting without having to provide particular kind of more invasive targeting that Facebook or Google might take part in. So I think that this sort of model is one that we're going to be promoting a lot more in the coming months, in addition to the bounties, in addition to the grants. And I think it's worth, as an ecosystem, us being at least aware or considering these models more seriously, as long as they're done in a relatively ethical way. So this is sort of everything that I wanted to cover in terms of what we're up to. Ultimately, though, I think it might be clear at this point, my takeaway from this talk, or for you for this talk, is just think about what models look like for your open source projects, what funding models would make sense, how people who are working on your projects are currently getting paid, and just think about what can be done to make that a bigger centerpiece of your strategies, of your organizational sort of ethics and values. I think the Web3 space, again, is doing an amazing job in this regard. I think relative to Web 2, we're orders of magnitude better. But I think the important part for the takeaway here is just to consider these more actively in the days ahead, in the weeks ahead, in the months ahead, as you all build out your projects here. Thanks so much. Any questions?
Yeah, that awesome project, so desperately needed.
Thanks.
So thank you for doing it. I think I don't want to say there's an inherent flaw in the nature of open source, but it's just the nature of abuse of open source creators and maintainers, that they're just being abused by people that actually don't want to compensate them for their work. So is there not some way, you've come up with a lot of innovative examples here, some of which are working well. Is there not some way that commercial adoption of that code would come with a price versus
Yeah, no, I think that's a really good consideration. So that sort of goes to the support contract model, which is one of the ones that for us was working on. Tidelift is another company that's doing something similar in this regard, trying to get people paid for basically supporting particular companies that are willing to basically work with them on particular features. I think that's a good model for certain types of open source projects. So a company like Docker, it's very easy to get a company like Docker to support themselves by enterprise payments. It's easy for them to go and pitch individual enterprises, hey, we'll give you this additional Docker support package. I'm just using them as an example, by the way. We don't have any affiliation with Docker, obviously. It's harder for a project like OpenSSL to do that same thing because it's so pervasive, it's so widely used. And I think the kind of funny thing is the more widely used a project is, the less that model works. So it's kind of a classic tragedy of the commons problem. Ultimately, I do think that should be explored, but I think for projects like core infrastructure of internet layer projects, it's probably not going to be sufficient. Oh, sorry.
I got the mic.
My bad.
Do you have any plans in your roadmap to have cross-chain integrations with ETC or ETH
Yes.
other than ETH?
So I didn't want to hint too much, but there are some announcements, and Terry did allude to this as well, that we are talking actively with ETC Labs about collaborating, and I do think that we're not an Ethereum-only project. I think one of the takeaways from this talk, which was kind of implicit, but I didn't really state, is that open source is not specifically one chain. It's not ETH, it's not Bitcoin, it's not ETC, it's any arbitrary project that happens to want to support this model that sort of was outlined by those 3 principles at the start. And I think that we definitely want to work with as many chains as possible because all those chains are open source and they're all supporting that vision. And so we're fully supportive of ETC Labs, and we want to definitely collaborate further.
Great, thank you.
So first of all, I love the ideas proposed here, especially as someone who has had to abandon open source projects for paying jobs in the past. But for your patronage models, it seems as if the majority of people who would be interested would be others passionate in open source software. So I'm not sure if you'd end up having a sort of net zero funding within the community as a whole. Are there any plans to attract those outside the open source community?
Yeah, and so there's 2 levels of that. Part of that goes back to the comment made earlier about basically a corporate model, or a model where you have companies paying for support or paying for additional features, commercialization of open source software. The other side of that, I think, is just this sort of advocacy where people are made more aware of the value of open source software. There's lots of foundations, like for example, it's a different level of patronage. So again, there's still problems potentially with that model. But a lot of not open source foundations, a lot of general nonprofit NGO foundation types support particular agendas that don't include open source in any meaningful way. So for example, well, I won't name names, but there are a lot of projects, for example, that will support activism, or will support work in journalism, or will support humanitarian aid. But they won't support particular software projects that happen to support those next level, those at the forefront, on the ground organizations. So it happens that sometimes open source software gets funded as a result of those organizations getting funded and those organizations giving back to the open source community. But I think one important piece that could help there, which is definitely something that we're trying to do more actively, and that a lot of others in even the Web 2 ecosystem are trying to do more actively, is get those larger institutional philanthropic organizations looking at open source as its own category for funding, rather than just a facilitator of some other alternate mandate or goal. Cool. Any last questions?
Yes.
Oh, yes.
Do you have
where's that coming from?
any ideas on how this could work with institutionalized things like Open Collective or the GitHub sponsors program? Because we have a bunch of money in our Open Collective, and it's kind of a pain to send it around the world, which would be perfect for kind of getting this to kind of work together.
Yeah, so first and foremost, we're huge supporters of the work that Open Collective are doing. We know PA relatively well. We think that it's an extremely important model, and we're really only in the crypto ecosystem. So I mean, it's very much, we're in our niche, and we think that they're doing important work outside of that to support Web 2 open source. I think that ultimately Web 3 is probably the better path forward for the reasons I mentioned. There's just a lot more support and interest in open source technology, and it's harder to convince people in sort of Web 2 that open source is even something that they should be pursuing, let alone something that they should be funding, whereas here it's obvious that we're pursuing it. Open Collective has sort of a similar model to what we're doing with grants. So there's some similarity with Gitcoin grants in the sense that it's a monthly subscription that you can basically give to any project. And any project can apply as well to have their little card on there in the same way as Open Collective. It's just specific to sort of the blockchain ecosystem at the moment. But we think they're doing great work, and we want to see more collaboration on that front as well. On the GitHub sponsor side, we think that's really great work as well. I think we're really huge fans of everything they've been doing lately, even around dependency tracking and vulnerability tracking and so forth, that I think, I'm really impressed, I guess, with Nat in particular. I think he's done an amazing job in such a short time frame already. We've been doing some work kind of just advising or providing our feedback on the program. And there's been a few other organizations doing that, but we haven't really discussed very actively with them what that might look like. Cool. Thanks so much, all.
Thank you. Take that back east with you.
Will do. Cheers.
Okay. So thank you, Scott. So yes, we've now got a break for, I think it's 25 minutes. So, and the sun is coming out. Look at that. It's looking nice out there. So yeah, I haven't seen anyone out on the deck. The deck is open. Please use the deck. Woo! to have them speaking here. Thank you.
Thank you. Thanks. Everyone is refreshed. It was nice to be out there for a minute. So I was researching this talk last week and exploring block explorers in the general ecosystem. And as one does, I ended up on Etherscan pretty quickly, on the mainnet anyway. And came to their privacy policy, which is actually fairly disturbing. I was ending up kind of clutching my treasure there, curled up in a ball. Some of the types of data that they collect, potentially, personal information like your name, your date of birth, other personal identification numbers, contact information, address, phone number, email, technical information like your IP address. And they use this data in ways that we're unsure of, sharing with data warehouses, marketing agencies, and other various organizations. Now, as a casual user of Etherscan, you're probably not going to run into this. If you're signing up for an API key, you probably will. If you want to add your own messages or content, they store that, and we're not sure what they do with that data. So that was part of the impetus behind building BlockScout. It is an open source explorer that also supports Ethereum Classic. I forgot to mention, that's another reason why you might not use Etherscan with Classic. It's not supported. So last year at the summit, our tech lead, Igor Baranov, gave a great demonstration on kind of an earlier version of BlockScout. And I'll talk a little bit about a few of the things that he spoke of. First of all, it's built on Elixir, the Erlang VM, which was originally built for telecommunications processes, so it's really good at concurrency. You've got, with BlockScout, we're fetching the first blocks in the chain, and we're also going backwards to get some of the archived data. So we need those kind of concurrent processes working. He talked about how there's support for different kinds of tokens, ERC20, ERC721, smart contract reading and verification. So when you're verifying a contract right through the UI, you're able to go through that process really easily. And basically that just verifies that the bytecode matches the contract. It's not verifying that the code is actually correct. Also, full transaction history. So in the past year, we've been fairly busy, and I want to speak with you about the ways in which we've been improving BlockScout. Basically, we've taken 3 approaches. We're working on some different tools and views for developers, performance optimizations, and we've actually really been focusing on the user experience. I've heard several people talk today about how important it is to kind of build that bridge between users and developers. So we're working on that to create a full-featured Explorer. So one thing we've been working on is creating a decoded view for the contract method calls. So basically just including this information in the Explorer itself. You can see here we have the method ID, the type of call, this is a transfer call with the arguments that it takes, and then the data that was presented. You can also copy any of that data as you need to. And this actually works for non-verified contracts as well. We're creating a library of these different method signatures so that you can go in and in an unverified contract, you'll still be able to see what these method calls are. Similarly, we've added views for the logs. So in this instance, it might be a little hard to see there, but the first topic, again, is the message signature, and we're able to extrapolate those out so that you can see different types of data right in the interface. We've also added a search functionality to the logs, so you can parse through the logs rather easily. We've added this raw trace functionality, and we store this to the database, so the same type of JSON object you would expect to get from geth or parity, you can access here. And you can see there's the internal transactions view and then the raw trace view. So offering just different views, different ways of looking at the data and being able to use the data as you need. We've really been focusing on some API improvements as well in Block Scout. And there are no limits to how many times you can hit the APIs. There's no keys that are needed. You can make requests directly from the UI. And we offer GraphQL support. We're also starting to support some of the JSON RPC endpoints. We found that these were the 3 most common ones: the ETH block number, get balance, and get logs. In addition, we've extended the RPC endpoints for contracts. So the list contracts endpoint, you can go in and find verified contracts or unverified contracts easily with that call. There's also a verify endpoint, and this is useful for third-party services, for example, Truffle, or we're talking with Etherlime right now so that you can actually write a contract there, compile it, deploy it, and verify it right through that interface. So as far as optimization goes, we're using something from Elixir called ETS, Erlang Term Storage, to really try and make the page load quicker. So you can see here average block time, the total transactions, total blocks, and wallet addresses. Those are all being served from ETS, as are the top 5 blocks in the chain and the top 5 transactions. So that way we can get things to the page really quickly, and we don't have to call the database every time. Once we get past those 5, we just prune it and continue with that process. On the front-end side, we've been caching as well with local storage. So if you go back here and see the chart, that's actually cached in the local storage. And we've been working on isolating a lot of our code. So before we had just this really, really long CSS file. And as we've been adding more chains, it really got out of hand. So now we just have files that are just related to the page you're on. We've also added pagination so that only the top 50 results come up and you can go through. And these might seem like little things, but when you add them all up together, it's really improved performance, which is such a big thing for block explorers. If you're waiting around for the data, it's not good. Along those same lines, we've really focused on the user experience. It's related to this idea of competence. When you see a good design, you automatically feel assured that it's a working product. That builds trust, and that builds adoption. And that's really what we're looking to accomplish here. One of the ways we do this is through eliminating some of these kind of black hole pages. So before, if someone would come on and look for a transaction and it wasn't there, they ended up on this scary white page and didn't know what had happened to their transaction. This is for a lot of users, naive users perhaps, who don't know that you need to wait a little while. So we've added this messaging just to assure people, okay, come back in 30 seconds, refresh. In all likelihood, your information is going to be there. We also have clear labeling of the different types of transactions. This was part of our 2.0 redesign. So contract calls, transactions, token transfers, all those types of things are clearly labeled in the UI. We've added a CSV download. This is especially good for users who want to download different transactions from their account or see all the transactions that happened with a smart contract. And these are the different headings for that CSV download. And night mode, which I've gotten emails recently from Slack and Google Docs and many other big corporations that are adding night mode, so we're happy to be ahead of them. But it really is something that helps people who have vision problems, that helps people who are on their computers all the time, and it shows that you're committed to that UI experience. So we're really trying to make Block Scout a beautiful and fun experience for users. Some of the things we're looking at in the future, the ability to write contracts right into the interface. So you can read and verify right now. We'd like to have the ability to actually write them. We're adding additional metadata for non-fungible tokens. So things like CryptoKitties will have the image there. Any other kind of non-fungible tokens, different metadata would then appear in the search as well. We have a community member who's working on showing daily transactions. That's actually an open PR. And to go off of that, we do have a community-driven roadmap. Block Scout's one of the most active projects in the Ethereum ecosystem. It's consistently in the top 20 as far as GitHub commits. So we're always looking for people to contribute, to add issues, to work on issues, and that really helps to drive the project forward. Briefly, I want to talk about a few of our other POA products that support Ethereum Classic in particular. This is Nifty Wallet. It may look somewhat familiar. It is basically a fork of MetaMask with some nice reskinning and the additional RPCs of Ethereum Classic, various test networks, Gurley, and some of our other chains. So we wanted to have a wallet that natively supported other EVM chains. And MetaMask was not so open to the idea. So in the spirit of open source, we made that idea our own. And hope that others continue to do that with this product as well. Another cool thing you can do with Nifty Wallet is make contract calls directly from that interface. So it's really good for testing different calls to make sure they work on a test net. Our token bridge is another technology that we're really proud of and that we're really working hard on right now. This is a live bridge right now from Ethereum Classic to the Ethereum mainnet. The way that it works is basically ETC is put into a smart contract. It is locked there. It goes through an oracle. And there's a smart contract on the mainnet that then mints something called WETC, which is wrapped ETC. It has all the same properties of ETC, but it's on the mainnet. And from there, you can use it on the mainnet freely as you would any other ERC20 token. There are at least one exchange that I know of, IDEX, that supports it. I believe Saturn also supports it on the mainnet. When you're done, you can bridge it back over to Classic. So it's a similar process in reverse where the WETC is burned and then it's unlocked on the ETC side. This is a new bridge mode that we're working on. It's called the A and B bridge, arbitrary message bridging. And this is going to allow us to bridge any asset from two EVM chains. So ERC 721s, 677s, basically any kind of message invocation will have the opportunity to be bridged from one EVM chain to another. We currently have a working model on the Sokol and Kovan testnet. And we really encourage you to check out how that works. And we're hoping to have an ETC implementation at some point. If there's anyone here who's interested in helping with that, we're definitely open. So a little bit about the POA network. We are an EVM sidechain, and we heavily believe in interoperability. So the desire to have different chains that have different characteristics, potentially, for example, POA network is heavily focused on games. We have the XDAI chain, which is a stable chain. and other networks that potentially can bridge to one another and have the opportunity to share assets as well as sharing assets with the mainnet. So this is our contact information here related to Block Scout as well as the POA website. We're active on Gitter and many other channels. And that's all I have today. Thank you. Any questions? Thanks.
Thank you.
Thanks. Appreciate it.
There you are.
All right.
The goods.
Thank you.
Right. So next up, we have a talk by Cody Burns. So Cody is an Ethereum Classic OG. He is also a director of the Ethereum Classic Cooperative, so he can sack me if I'm rubbish. So big warm hand for Cody.
Good afternoon, everyone. As Bob mentioned, I do a lot of stuff with Ethereum Classic, but my day job is I'm an enterprise architect at Accenture. So what that means is I work with the largest companies in the world and helping them develop blockchain solutions that solve their real-world problems. So over the last year, one of the things that we wanted to look at, and we've had our labs working on, is what's the relationship between AI and blockchain, and where can we leverage the two together? And that opened a huge can of worms, because there's nothing more hyped right now than AI or blockchain. And whenever you combine the two of them, you will find thousands of useless projects and scams. And everyone has an idea of what they should be. So what we set out to do was develop a framework of how we could evaluate what AI for blockchain was and how we can better look at it and how we can think about it in a different way, maybe something more methodical. So what we're going to go over today is the introduction, the basics of what we found, the combination of blockchain and AI, and what that looks like, and then specifically the difference between AI for blockchain, blockchain for AI, and then the combination of both blockchain and AI together, and how they can work and build a better solution for each other. So introduction, first of all, what is AI? How does it fit into all of this? And the real simple answer is, whenever you're trying to sell a project, that's whenever you're developing an AI solution. Whenever you're trying to hire somebody, you're looking for machine learning. And it basically boils down to statistics and data science and math. So it breaks up into many different categories. You can see 9 of them listed here, but the realm of artificial intelligence basically boils down to using a function to boil down a set of data and match with the answer that you're looking for, whether you can give a probabilistic answer of, does this data match the pattern that I'm looking for? Blockchains and DLTs, hopefully everyone's at least familiar with this technology if we're here. So the big differences that I'll touch on real quick is Accenture's work, we work with private and permissioned blockchains, whereas Ethereum Classic is a public permissionless. So there are valid use cases for both of them. And for machine learning and AI, there's also use cases where it makes more sense to do a private permissioned chain between a consortium. And there's also use cases where it makes sense to do stuff on the public and permissionless. And we'll get a little into that here in a moment. So as I said, our teams in the lab put a lot of work in the last year. And we put out a white paper on powering or powered by blockchain, realizing AI's full potential. And I'll share the link after this. But we went through and found use cases where there's actual value in combining AI and blockchain and how they can work together. So the real reasons for using it are the same reasons that people like to use blockchain for money. You have the audit trail, you have the trustlessness, it's tamper evident, and there's security built into the protocol. So you don't have to worry if the data that you're getting is valid or if it's up to date, because everyone has the same data at the same time. And this is a huge benefit for modern AI systems. If you haven't been paying attention to the AI space, in the last 5 to 10 years, as blockchain's been going crazy, so has AI. There's been huge advances in open source for AI. TensorFlow and Python's tooling around it have made it AI incredibly accessible to everybody. But the problem is that the data that gets trained on it goes through a black box and then gets put out as a solution. So you either take the data and assume that everything's correct and do your work on it, or you have to retrain the model yourself entirely every time. And that gets tedious, and it can lead to mistakes. So our methodology, I won't drill down on this slide too much. We broke it down into 3 broad categories: AI for blockchain, smarter blockchains, and distributed ledgers. So what this is how we can use AI to make blockchains more efficient, how we can get more value out of them. Blockchain for AI is how we use blockchains to make AI better. So whether that be public transportation systems or medical solutions or federated learning, all that falls under the category of blockchain for AI. Blockchain plus AI is the missing middle. It's where the two meet. This is, some of you may have seen Bridget on Telegram. So it's making the user interfaces where conversational AI can help people understand the blockchain better. They don't have to worry about numbers or hashes or wonky, long hexadecimal codes. They can talk to AI and have answers in human terms. This is our tree. As I said, we broke it down into 3 categories, and we have split out which elements fall under each tree. And these are the ones that we're going to be going over today. So starting out, AI for blockchain, how we can make blockchain better with AI. One of the big things if you've been following the Ethereum main chain, is for the proof of stake system that you need verifiable delay functions. And one of the things that can help with this is we can make smarter consensus mechanisms by utilizing AI and its training models. So you don't have to worry about doing squaring numbers repeatedly. You can use trained models, and it can help in the process and reduce energy costs. The other big innovation that we've seen is useful mining work. One of the biggest complaints against proof of work systems is that we have big warehouses of ASICs that are just hashing numbers all day, and they don't do any valuable work. There was a project called GridCoin a few years ago, and they had developed proof of research. So all of the mining equipment was working on folding proteins. So this is work that's part of a MIT initiative where they send out large sets of data. So it can be radio signals that were received from SETI or protein folding that's needed for building new medicines. And that gets sent out to users at home. And whenever their computer has idle spare time, instead of going to a screensaver, it starts processing these scientific formulas and folding proteins. And the proof of research or proof of useful work, instead of mining and doing hashing algorithms, it actually folds proteins and generates a proof that it had done the work and returns it to the user who sent it. So the proof of work isn't just burning energy and making numbers, it's actually providing valuable scientific feedback as well. Smart contract auto coding. GitHub has been an amazing tool for social coding. It's given users access to code that we never would have had before. I think 32 million users is what was on the slide earlier. And all of this data and code is just sitting there idly, not helping anyone. So what we've seen projects start doing now is they're using generalized adversarial networks, which basically means you feed all of the light code into the AI, and then it can generate code that looks like it's supposed to look. It can write the correct function that you're looking for. So if you have the same function as 45 other contracts. When you start typing it, it can complete the sentence for you. It can correct your syntax errors. And so the coders are able to move faster because they're pairing with the AI system. You don't have to reinvent the wheel every time. It can go through any language or any smart contract, and it can find the mistakes for you as you're going along and help you avoid making costly mistakes like reentrancy errors or just spelling or things like that. So it's a really helpful thing for people that don't program all the time and you need to get something done. So lawyers, doctors, and people in other industries who are looking to do smart contracts can fill out a form, and then the AI can generate all the contract code in the background without having to go through individually and write out all the functions themselves. Blockchain analytics. So one of the biggest problems with blockchains is that they are permanent, and everything you put into it is also permanent. If you make a mistake whenever you're doing data entry, that becomes a very, very costly endeavor. If you're doing manufacturing or track and trace, and your data entry is off or your API is wrong, then you have huge problems because you can never go back and correct it. So one of the things that the analytics can do is it can help with sanitizing data as it goes in. It can map the transactions that you already have going and detect anomalies. So fraud detection and recommended actions on those frauds can happen all in real time. As the transactions are coming through, you can flag transactions as bad or possible fraudulent or possible criminal activities, or if a temperature sensor's noticeably out of alignment. You can know this ahead of time before you have to wait 40 blocks down whenever you finally get around to looking at your data. This can happen in real time using AI. So blockchains for AI. This is the more exciting stuff, I guess. So federated learning. The easiest way to think about this one is there's no real value in being the best car company that develops an AI that doesn't kill people. There's no value in being the best hospital that knows how to cure cancer. That data is universal. It's for everybody. So federated learning allows multiple companies to train the same AI on the same models in real time, and you can follow the train back. So after a car wreck, you can see why the decisions were made by that AI that was driving the car. It's no longer a black box that has just data put into it and then you get something out the other side. This federated learning allows us to build a forensic, for lack of a better term, AI psychology. You can go back through the chain of transactions every time it's got a training data or every time a decision was made, how it led up to where it is now. And this is an amazing breakthrough for things like cancer research or malaria or diseases where you don't want to share all of the patient information, but the data does need to get out there. It does need to be shared. And right now, there's not a good way of doing that. As I said, we've had a huge advance in AI, but we have not had a huge advance in data sharing or model sharing. Right now, it's one company will build the data, they have their own model, and it doesn't do anyone any good because they don't know what data it was trained on. With this, you can see the training data. You can see what differences the training data made along the time. And as I said, as the auto wreck happens, you can go back and see why the decision was made and how to correct it in the future. Decentralized AI service markets. So one of the things that 2017 brought us was that everybody wanted to be a miner in Bitcoin or Ethereum. So everyone went out and they bought video cards and overpowered computers, and now they're sitting there idly doing nothing. The one thing that also happened at the same time is that AI started using GPUs. So the exact same hardware that used to be used for mining can also be used for crunching numbers for AI in a distributed system. So since blockchain is open and everyone open and transparent, you can have possibilities of doing stuff like cloud computing, selling off your spare hard drive, your spare processes, running AI algorithms on your old mining equipment, making a profitable market out of that. Rather than mining Bitcoin, you're now crunching training data for a TensorFlow. Health data. It's 2019. Everyone walks around with collecting data all day, every day. Heart rates, steps, endless amounts of data is collected by your phone. You have the ability now to be able to sell that data back to other companies. And blockchain is a tool that enables that. It allows you to safely do it in a distributed way without giving all your personal data that you don't want to. So we can use that data also and develop a better training set. One of the ways that Tesla was able to advance their self-driving cars was that they turned on all of the AIs in all of their cars, and they just followed drivers. The AI was training along with the driver, so it would make the same moves. If it was coming up to a turn, the AI would see whether it would turn left or right. And the AI never took control of the system, but they just used that data to train it and reinforce it. Now imagine if you did that for every car in America at once. You have years jumped ahead. And so all of this is possible with the blockchain. We're able to put all the data into a system and then be able to process that in real time. You don't have to worry if you have the latest model because your model's always synced. You're able to pull from the data store wherever it is, even if it's just a marker on chain, and you're using IPFS to store the actual model data. You know that you have the most up-to-date model at all times. Does anyone know the last time they changed the software version in their radio in their car? I don't think so. But with blockchains, we can make sure that our AI is always up to date, and you don't have to worry whether you did the latest flash or whether your car company is using the best algorithm at not running over pedestrians. All of the data can be mutualized and used to help save lives. Prediction platforms. Augur was one of the first ones to launch on the Ethereum mainnet, but prediction as a service, allowing businesses to see what people are thinking in real time. And so building these prediction markets out and using them for logging and rewarding of other users is the big market that's going to be opening up in the future. So I'm trying to speed along. AI and blockchain. So AI and crypto trading, which is also very interesting to a lot of people. So if you've used any of the crypto markets, you may have noticed that there's always transactions going through. And a lot of this is the AI in the crypto trading. You set it up on the patterns that you're looking for, and then the transactions happen automatically. And this is also a huge market, providing analytics on this, providing real-time updates. And so it's not necessarily AI on a blockchain or blockchain and AI, but it's working in concert with it. So it's allowing traders to perform actions and that they wouldn't be able to do in real time. And I believe with that, that's our last slide. And we have a glossary at the end of this also. All right. Are there any questions? Yes, Donald.
You mentioned marketplace.
Mm-hmm.
So the AI agents or machines that are doing the data, etc., is off blockchain, and the blockchain serves like a complementary system to make it trust minimized and to distribute the work, I guess. And there's a component of a marketplace I read. Is that marketplace going to be on blockchain or off blockchain?
The ones that we've seen have been on blockchain. That's what they're looking for. It allows for the escrow of the funds. That's something that's not really, you can't do through PayPal or through, you could do it through a third party, but then that just complicates and adds cost on top of it. But if you give your training data set to a random stranger on the internet, you don't have any real assurance that they're actually doing any work on it. They could just give you back the trained model and it have nothing to do with your data. So by using the blockchain and an escrow contract and some verifiable proofs from the data, you're able to prove that the data that you gave them, the training set, was actually used in the model for training. And so that's a big benefit. And it allows anyone to do it. You don't have to register and give all your information. You could pick up jobs piecemeal.
So there was a talk about maybe 6 months or a year ago by Peter Thiel, and he said that, oh, I'm right
There
here.
you go.
Yeah.
Yeah.
And he said there's two factors which are kind of driving 21st century technology, which is AI, which is an inherently centralizing force, because the more data that you have, the more powerful your models can be, and it's just better than the models with less data. And then there's blockchain, which is an inherently decentralizing force, in which, you know, you're trying to distribute amongst as many different parties as possible. So I'm curious, do you sort of see that as being like two opposing forces there, or what do you think about that idea?
I think that's the wrong mindset that he has. So right now, if you would have asked Google or Microsoft or any other big tech company, that's what they would tell you, is that having the most data is what gives you the most value. But that's also because they use their models to train for whether you want to buy this brand of soap or another brand, or how long you looked at something on a web page. But for humanity, the best solution is going to be something that is distributed. We can provide all the data that we can, and then all share the same solution on it. Like I said, there's no real value in being the best at curing cancer if everybody else is still dying every time they go to a different hospital. So I do think that the two, as their model is right now, are competitive. So AI is mostly centralized. So there's a big race to get as much data as a company can so that they can say that their AI can beat the world's best Go player. And it's not a very open or sharing market. All the tools are open source, but the data, the value is in collecting as much data as you can and having the best model. And that's not what works best for the general population, at least in my opinion.
Yeah, so with regards to sample sets, like obviously it's a competitive advantage, you know, if you've got this larger data set and you're able to, depending on who your customer is, but in the interest of like the public good, like to your point about, you know, cancer, is there some entity, or is there discussions with regards to some sort of entities that could articulate the value of this larger data set that isn't owned or manipulated by any one entity, like, you know, some sort of certification or something, where it's like when a consumer goes to buy a car, they're like, oh, well, this car is governed by this AI from this decentralized entity. You know, has it gone that far, as opposed to saying, well, it's company A that is solely in charge of what this particular, how this car is particularly governed with regards to the AI?
There's not yet that I know of. There's no government agency that's looking into this and saying this data should be public, this is for the public good, versus this is what a company A or B should be trained on. So that was one of the reasons that we were looking at blockchain and AI, is because it is such an open space, and there's such big buzzwords right now that it's hard to pin down what exactly someone means when they say they have an AI project, or when they say that they're doing something with a blockchain. So there is no clear-cut, these are the use cases that we want to be public, and there's no driving force behind it right now. This is still the very early infancy of the combination of the two.
And should these larger entities not in some way be, if not incentivized, mandated to contributing their data sets towards the greater good of humanity with regards to you know, these particular endeavors? They can still utilize it for, you know, market advantages, but some sort of philanthropic giving, you know, where they're actually giving their data set.
And that's where eventually it would be some type of government entity could make a mandate that if you're operating driverless cars, you will use this system. And that's most likely where you would see the innovation coming down, would be from the top down. Of if you want to drive on freeways, then you're going to have to use this system. Or if you want to be a company that cures cancer, you have to give some data back. So it's going to take some initiative from something to force companies to want to use for the public good. It's not in there's no business value in necessarily sharing the data other than you're saving lives, and it's everyone's data.
Yeah, it's almost like you think of it like organ donation. You know, you check that box on the card and you're like, yeah, well, if and when I don't need them anymore, you know, this will be contributed to the greater good.
That's right. Anyone else? Thank you.
Thanks, boss. Right, so Afri is going to return to the stage now with his second presentation to talk about Ethereum Classic testnets. You know, both Ethereum and Ethereum Classic have had a number of different testnets over the years, starting with purely proof-of-work chains, and then proof-of-authority chains started coming in. Interestingly enough, for the first time on CPP Ethereum, the team that I was working on, really because Gavin Wood was building that code base, and the things that happened at the very end of that period there on CPP Ethereum really were taken over into parity. So one of the first POA chains was actually CPP Ethereum, though not, funnily enough, the same executable. It was a different executable with largely the same code base. So parity really started that, and then was Clique, and you will pick up the history from there, I'm sure.
Thank you, Bob. Thank you for giving me the opportunity to have two talks here. But I really wanted to do this, and I will elaborate why in a second. I hope everyone's doing well. It's been a long day. I want to talk about testnets and specifically about the massive number of Ethereum Classic testnets. And eventually I want to reduce them today significantly. So what do we have? We have Morden, we have Kotti. Both testnets were mentioned in previous talks. We also have Astra, the SHA-3 testnet, which we'll hear more about tomorrow. We have Kensington, Nutskool, and we have yet another testnet that has to be revealed. Morden was launched in 2015 along with Ethereum. It's an Ethash proof-of-work testnet, and to prevent testnet transactions from being replayed on the Ethereum mainnet, it comes with a kind of unique feature of a custom starting nonce, which caused several issues of protocol testing, and eventually the Ethereum Foundation at some point decided to abandon the Morden testnet and to replace it by Robston. However, the Ethereum Classic community in need of a testnet continued maintaining it, and it's still around as Morden Classic today. And it's still around and still has this weird feature of a custom starting nonce. But because proof of work is hard to secure in a testnet environment that has no incentive for security, for keeping it alive and keeping it secure, we, as the Girly Testnet Initiative and supported by the Ethereum Classic Cooperative, launched the Kotti testnet, which is a click proof of authority testnet for Ethereum Classic. And what's unique about Kotti actually, and only a few knew it, it was actually the first cross-client proof of authority chain ever launched with EVM compatibility. The Astra testnet, I will just mention it because we have an entire talk, separate talk on SHA-3 by Alex tomorrow. It's about testing a new mining algorithm. Go to Alex talk tomorrow. While I'm talking about testnets today, we had kind of a situation when developing the Atlantis protocol upgrades. So I drew this client support matrix on the slide so you can get an impression what actually supports what. And you see that Parity Ethereum supports modern and the old classic gas supports modern. However, due to the custom starting nonce in modern, it eventually was removed from the foundation gas because it was deprecated years ago, and multi-gas, which is kept very close, compatible with the upstream foundation gas, also does no longer support this chain. And adding modern back is kind of non-trivial. COTI, however, it's a click proof of authority network, and this click engine required to run a COTI node is only present in Parity Ethereum and multi-gas. So here we have the problem that Gas Classic is not, and also Mantis is not supporting COTI due to the lack of this engine. So what are we going to do if we want to test a protocol upgrade such as Atlantis or Agatha? Because we want to test this software upgrade, this protocol upgrade on all clients to eventually reveal potential consensus issues. And so we had to come up with a solution and launched something we accidentally called Kensington. Together with the chain safety team, it was just an ad hoc testnet for testing Atlantis across all clients that were out there. And that was a full success. We revealed at least 4 different types of consensus issues, and it helped us a lot to make sure the Gas Classic client. And what is Kensington? It's basically just modern without starting nonce. This testnet, however, was just set up ad hoc, and it's no longer present, and also creating the genesis was not a very elaborate process, so it's good it's dead now. I've written an entire blog post on Atlantis testing in case you're interested how we got to this point. It's on my Medium account, A4FRI, you can just look it up. I will go in detail with all the issues revealed. But that's not enough. Oh yeah, in case you download the slides, you have like a demo running this testnet on different clients, but not enough. Months ago, we met with the white block team and we decided, 2 months ago, we decided it's not enough. We want to have additional stress testing of the Atlantis features in all the clients, and so we came up with the NUTS Gold testnet. It's also a proof of work testnet. We met at East Berlin this year, and specifically with the white block team, but also Jas from the ETC cooperative and we from the Gurley initiative, and we did stress testing of all the clients under Atlantis conditions. It worked very well, but and we couldn't find any issues, and today we know that Atlantis is very solid implemented in all clients. However, this is also only a temporary testnet, and I assume it's already dead by now. So, oh yeah, that's us in the cage at East Berlin. That's also coincidentally the same place where the COTI testnet was born. Yeah, so going back to our client support matrix, we still, as of today, have this problem that modern will most likely never get into multi-gas, and I believe it shouldn't. And we also have the problem that COTI is not supported by classic gas, and yes, I also believe this shouldn't happen, because it's probably a waste of time to implement click in Gas Classic. So coming back to this client support matrix, what if we launch a new testnet? And someone from the Ethereum Classic community once posted this picture on Discord and said, what about calling it modern? I think it was Jas.
I think it was Shane, but I approved it.
You approved it. Okay, thanks, Shane. And yeah, what do you think about launching one testnet today to replace 3 other testnets? Yeah. So I brought my laptop on stage, so we can do it right now if we want to. We will do it fair. We will do no ICO, no pre-mine, no pre-sale, and all I need is a volunteer on stage with a microphone. We have 10 minutes, so it's totally doable. So who wants to volunteer? Ideally, yes, Sunny. You're my favorite volunteer. Okay, actually, so we get a mic. Can I get another volunteer? I need higher entropy. No, I need your brain. Okay. Just pick yours up and this microphone. You can take a seat. Can I get another volunteer? We are playing some kind of. Oh, okay. Oh, it's all 3 of you. The more the better, because we need this entropy. Okay. Yeah, just come here, take a seat, or just sit on the floor. So all we need now. So we are playing an association game. Sunny, you will come up with a short pregnant word that goes into the genesis. And then we quickly pass around the microphone, and everyone, like clockwise or counterclockwise, you decide, come up with a word that makes sense in addition to that. Do you know what I mean? So you just come up with a random word, or your favorite word, or like your girlfriend's favorite word, or and then you play this association game. And I will type these words into my command line interface to create a hex string from your random words, so we have enough entropy and enough randomness for the genesis. Want to start?
Sure. Phoenix.
Phoenix.
Chicken.
Absurd.
Absurd? Okay, shall we stop at 3? What do you think? Or Sunny, you want to?
Someone in the audience just call out a word.
Okay, it's a banana. So this will be our genesis extra data. I'll just copy this into the extra data field. I hope it's not too long. You never know how clients react. That's guess classic, multi-guess. Okay, so all we need now is a timestamp. Do you know the timestamp of right now Unix time in hex? My command line does know that. So let me update the genesis file for multi-guess, guess classic, and parity. Okay, I do this everything live on Git, so I can add this directly to GitHub. If you want to join launching this chain, you just go to GitHub East Classic modder, and I will just commit this genesis file, so you can start mining right now. Now that all the secrets are revealed, commit live launch at ETC Summit. Okay, now I enter a super secret passphrase, and I push it. And I prepared a boot node where I will pull this code and initialize. Yeah. So the genesis hash starts with A68EBD, and I will run this boot node. Yeah, blah blah. Okay, mind a potential block. So if you want to join this testnet, just pull the code from this repository, connect your guess parity or multi-guess node to it, and I will just test this here. What's it called? Guess So let me test this quickly. Chain mortar. Okay. Yeah, that's the same Genesis hash. So we did not mess up. I let this run. We have 3 blocks already. So thank you for the entropy. Let's hope we can replace modern Nut School and Kensington once and for all. And yes.
Thank you.
That was a pleasure. Thank you. Thank you. And thank you for the banana. Okay. That's it. Any questions? I have 5 minutes. We can just continue. There's a question in the back. Okay, cool.
Hey, sweet talk. Thanks for the new testnet. Just wondering, is it proof of work? Well, I assume it's proof of work,
Yes.
as well as similar to how Morden was.
Exactly. The reason here is that it's always been a blocker to implement the proof of authority engine across different clients. And even though, from experience, everyone wants to replace proof of work testnets with proof of authority. So in Ethereum, we have the girly testnet doing a very good job at this, but in the end, everyone still, at least the core development team, always wants to have like this one proof of work testnet for testing protocol upgrades.
Mm-hmm.
And I believe it's time to retire Morden and have something better for Ethereum Classic.
So one of the big problems with Morden is lots and lots of chain splitting. So it's pretty, like, very difficult to say boot Morden twice in a row and arrive on the same block when it says it's fully synced.
Yeah.
And so I'm just, a lot of that has to do with boot node list. And I see that in the repo you have 2 E nodes included as like static nodes.
Yeah, so...
so do you want to maybe speak to what those are a little bit?
Yeah, that's you see one of them on the screen. It's my personal boot node. I will commit to maintain it, but I also encourage, I don't know, ETC Labs, ETC Cooperative, IOHK, Consensus, Pegasus, whoever wants to Hyperledger, whoever feels entitled to run a boot node, please contribute to it. And it's now the process, what we did now is starting this testnet, but the process, the subsequent steps would be to go out there, update the clients, set up proper boot nodes, and yeah, make sure we can finally get rid of the old testnets.
Great, thank you.
Yeah, no, thank you. Okay. Thank you.
Thanks, Afri. So yes, we're just going to have a very quick break. We'll start back here in 5 minutes or so. So if you want to have a drink, go do it quick. If you don't want to come back, you don't have to either, just to say that. But we will be starting whether you do or not. block, who is going to talk to us about Metronome, which is really quite a unique project to my knowledge, with a single currency which can move around between blockchains. So we've kind of arrived at the point where the rails and the assets running on those rails are starting to be decoupled, which is really very interesting. Welcome.
Good afternoon, everyone. Myself, Manoj Patidar, Principal Engineer at Block. So in this session, we will discuss about Metronome. So Metronome is a build-to-large cryptocurrency which is actually cross-platform. The cross-blockchain cryptocurrency can be moved from one blockchain to other blockchain. So some problems in today's blockchain world is that the cryptocurrency or the crypto coins are tied with the one specific blockchain. So any crypto coins which is launched on the one specific chain is actually permanently tied with the one chain. And it also has, some crypto coins has the discretions of the founders and community members, and they have the limited opportunity for the sale, or maybe some vaporware or some the crypto coins which was launched in 2017, they were even not listed on the good exchange. So it is not the fair opportunities for the cryptocurrency holders. So Metronome is actually designed from the motivation taken from the past experience from the previous the cryptocurrencies, which is something like, you know, the cryptocurrency should be self-governed. The one motivation, it should be predictable and reliable. And it should have the self-governance, and it should be actually be the portable. So technology we have used for the Metronome is initially it was launched on the EVM Ethereum as a ERC20, and now the later in the June 2019 we launched for the Ethereum Classic as well. So so Metronome is cross-chain cryptocurrency which is the working perfectly fine on these two mainnet of the Ethereum and Ethereum Classic. Initially, when it was launched in 2018, the June 2018, so 10 millions of the Metronomes were the minted, 8 millions were actually sold in the initial supply auction, and 2 millions were the retained for the authors. And so there was no pre-ICO, no whitelisting, no fundraising. Whatever sold in the pre-auctions were actually into the smart contract ecosystem. So it actually in the proceed contract. So no one is having the access to this one. Even the founders or the owner has no access to this the $1 million of the worth Ethereum which is into the smart contract. So why this is designed like this? Because this is the self-governance which can be worked forever. So a foundational cryptocurrency is like which should have the store of value, like gold is gold. So cryptocurrency should be like having the store of value, no place where it should be. So Metronome is also having the store of value across the different blockchain. So irrespective of which chain you have, you can move it from one chain to other chain. Like it has the payment system with some payment features like the mass payment and subscriptions. And because it is based on the smart contract, so it is programmable cryptocurrency. The key design principles behind Metronome is the self-governance. So it is self-governance because it is not influenced by the founding members or the community. So this setup is smart contract which is developed. It has the 4 set of smart contract which has the proceeds, auctions, and autonomous converters. We'll talk about it in the next slide. And it is reliable because it is the reliable and the predictable because the minting can be predicted for the 100 years for now because it has the 2% inflation rate annually, 2,880 Metronome hours being minted daily in the daily auction. And this auction is actually starting in every midnight UTC. And this auction contract auto run, and this actually has the descending price auction. and it auto-discovers the fair price of the metronome. So metronome purchaser who feels that what is the fair value of metronome at particular moment of time, they go ahead and buy it from the auctions, or they can use autonomous converter contract to exchange with the native currency. It is portable, it is cross-chain the currency which has been launched on the Ethereum and Ethereum Classic, which is truly actually has the features where the independent, the network of distributors, the network of validators can validate the chain ops. Fairness, so it is fair because it gives the fair opportunity for all the metronome token holders to actually use it or exchange it in the autonomous converter contract. So whenever if someone want to buy it, so there is no dependency on any third-party exchange. So the metronome ecosystem has a autonomous converter smart contract which has the liquidity of Ethereum and Ethereum Classic on a specific chain and the metronome. So as of now, proceed contracts is used to fund autonomous converter, and every night 0.25% from the proceed contracts goes to autonomous converters to maintain the liquidity of the native currency. So auction contract is running the descending price auctions. Every midnight UTC starts with the 2,880 metronomes are sold into this one. And whenever the auction contract, every day new auction start, it starts with the 2x price of the last day's sold out price, and every minute it decreases by the 1%. And whenever the auction start, it also transfer the fund from the proceed contracts to the autonomous converter contracts. So it transfer 0.25% from the proceed contract. So whatever the amount has been collected in the auction, today's auction goes to the proceed contracts, and as of now, proceed contracts has approximate somewhere between $2 to $3 million the worth of Ethereum into proceed contracts, and these proceed contracts actually send 0.25 basis % to the autonomous converter, and autonomous converter is having the liquidity of these two, the native currency and the metronome. So it is kind of decentralized financial instrument, product where it has the liquidity of the both currencies into the contract, and this is self-governed. No one is holding, no one is owner of this one. So metronome is portable. It has been launched on the Ethereum and Ethereum Classic. So chain op has been successfully done. So since last 3 or 4 months, it has been tested on the mainnet. So as of now, we did it for the mainnet on the Ethereum Classic, and we are testing it for the Quantum and the RSK, and we are also doing the technical feasibility for the other chain. So how does it work? So it has the network of validators, which is off-chain distributed networks of validators. They do the validations of the chain off. So whenever the wallet, if the user initiate any export from the one chain, from the source chain, and submit the import on the destination chain. So this group of the network of validators do the consensus and the validations of these transactions on the source chain. So once they have the consensus among themselves, then they do the attestations on the destination chain, and then the users is going to burn this metronome on the source chain and do the minting on the destination chain. And this minting is done only when these validators has the consensus among themselves. So this is the phase 1 validators networks. As the technology will evolve, we will have the completely distributed and independent the system where we can say that the each set of metronomes on the one blockchain can be considered as a one lily pad or the one node or something. And then on the other chain, it would be the second node. So whenever every hour we can generate the block on the metronome, which is something like blockchain on the blockchain. So this node can be carry the information. So whenever someone will be exporting the metronome from the one chain to other chain will be carrying some information. So that is for the phase 2 and phase 3, which is still in the technical study and in the design phase. So metronome has the desktop and mobile wallet. So in this, the mobile wallet, whenever the user initiate export, it does generate the unique hash of the export receive, which is the unique hash for each burn. And this export receipt is submitted to destination chain. Now, the destination chain, on the destination chain in the smart contract, so there cannot be the duplicate, the receipt can be submitted by the users. And then this validators is watching all the chains where the metronome lily pad has been deployed. As of now, it is deployed on the 2 chain. So these validators will go and read this export receive, validate the transaction hash on the source chain, and then we'll do the attestation. So there are the different interoperability solutions in the blockchain. So metronome is slightly different from the others. So it is not the REBD token, it is not the atomic swap. It has the chain of complete solutions, where the users do the movement of store of value asset from the one chain to other chain. So the brains behind this, the great innovations, this one, and then so this is our team and advisors. If anyone has any questions, welcome. Thank you. Yeah.
So I've been paying attention to this project for a little bit because I think it's interesting to have sort of a cross-chain currency, because like the currency can live, between multiple infrastructures, and that makes sense to me. My question is, how do you actually ensure that the economic value is able to be transferred to another chain? So for example, if I, let's say, move $1 worth of metronome tokens from Ethereum to, let's say, a chain that, let's say ETC, where there's a lot less users and there's a lot less liquidity, would it still be worth $1 on sort of the new chain, even though I moved it over, because there's less sort of buyers there? That was my question.
Yep. So actually, when you move the one metronome from the chain 1 to chain 2, so on the, say, suppose you move it from the Ethereum, and Ethereum's autonomous converter contract has some different liquidity. And Ethereum Classic's autonomous converters of the metronome has the different liquidity of the Ethereum Classic and metronome. So it will depend on the current available liquidity in a specific chain. So you are moving one asset, that means the 1 unit of the metronome from the one chain to other chain, but the value will depend on the available liquidity on that specific chain. So actually it will balance automatically, because the traders, what they will do, if they feel that the metronome on the chain 2 is being sold at a lower price than the metronome on the chain 1, so they will do the exchange between this one. So as of now, we have seen some of the users who is doing the chain off on the regular basis, because the autonomous converter on the other chain may be having the different liquidity, so they want to leverage the difference of these two, the liquidity, and they keep hopping from the one chain to other chain. So it is, you have the metronome, you have the unique asset, store of the value, but if you want to actually compare with the price of the metronome on the different chain, it depends on the other exchanges or the autonomous converters liquidity. But it will auto adjust this one if you, so we have the very nice dashboard on the metronome.io, where it does display the price of the difference. So market price of the metronome in the exchange, and the metronome's price in the autonomous converter and in the auction. So more or less, we have seen that autonomous converters price, market price, and auctions price, they are more or less same, because the traders who are watching this regularly, they do the exchange between these three sources of the metronome. So they buy from the auctions, they sell in the autonomous converter, they buy from the autonomous converter, sell in the exchange. So it will auto-adjust the values of the metronome. Thank you.
Thank you. Thanks for coming. Okay. So we have something a little bit different now, which is a fireside chat. So I was saying to Anthony and Michael here a little earlier that I was half tempted to go off to a garden centre and see if I could find some ferns to put on either side, but I didn't have time for that, so we'll just have to imagine that and imagine a roaring fire behind. So for anyone who doesn't know, Michael here at Grayscale was really one of the individuals who initiated the Ethereum Classic Cooperative in the first place. And then Anthony joined as the first director several months later. So we owe them both a great deal of thanks.
Thank you. Thanks, Bob. All right, Michael. Sorry. So why don't you just tell me a little bit about yourself and Grayscale?
Sure.
What you're doing here.
So we'll try and make this fireside chat a little interesting, right? I know there's us and a couple more talks that stand between all of you and cocktails, so try and keep everyone informed here. So, you know, I started working at Grayscale, January will be about 6 years, and I think for us, it's long been our view that digital currencies as an asset class have arrived and investors want access to them. Now, the unfortunate part, or maybe the fortunate part that's actually created a lot of opportunity for folks like yourselves, is that digital currencies exist outside of the existing financial infrastructure. So to buy Bitcoin, Ethereum Classic, really can't go and do that in a brokerage account or something like that.
It's hard.
It is. Not to mention if you wanted to do it maybe in a tax-advantaged way, an IRA, a 401k, something like that. And so what Grayscale has gone and done is created a whole family of investment products for people to access digital currency. So this has benefited everyone from retail investors who can now actually buy and sell exposure to Ethereum Classic, Ethereum, and Bitcoin in their brokerage accounts, because we have 3 public securities that people can buy and sell. All the way on the other end of the spectrum, dealing with institutions like hedge funds and endowments and pensions and things like that.
Yeah, that's great. So you're saying you just get more access to these cryptocurrencies, to the underlying, because it may be hard in some situations for people to obtain them otherwise.
For sure. So I think in particular, being that we're at an Ethereum Classic event, let's kind of hone in on that.
Yeah.
So our team, I think, had long been believers in the idea of Ethereum and kind of all the applications that could be built on top of it. And it wasn't until the DAO and the subsequent, kind of conceiving of Ethereum Classic and some of the principles and governance that it, quickly was able to adopt, that we really felt that there was a strong level of investability there. The truth is that I think when we started doing this, which was, call it late 2016, early 2017, a lot of folks had kind of left Ethereum Classic for dead. Either that, or as soon as they had access to Ethereum Classic after the fork, either kind of sold it and were like, all right, I got my free dividend or whatever they were kind of thinking about it. And so we authored a paper, which still exists today. It's on the Grayscale website, that really looked at what it was that the Ethereum Classic community, the initial set of developers, some of whom are still involved with the protocol today, kind of rallied around it and kind of what were the governance principles that they had implemented. And so I think our initial interest probably came around when Ethereum Classic was maybe 50 cents, I want to say. And so we published this paper, I think in the spring of 2017, and subsequently launched an Ethereum Classic investment vehicle. And so if you can all remember back then, if you were involved with the protocol, there weren't really that many places that you could buy and sell Ethereum Classic at the time. And so by providing this investment vehicle for folks, it really gave them an on-ramp, right? An access point to get exposure to it. And I think, as Bob mentioned, one of the things that we did, which we think has historically and continues to really benefit this ecosystem is we said, yes, we're a financial, an asset management firm. Of course, we have to charge a fee on these products to support auditors and accountants and lawyers and things like that. But if we could section off a part of our management fee and donate that money into an organization that would support the development of the network, well, that would benefit certainly the network as a whole, as well as the underlying shareholders who were participating in this investment vehicle.
Yeah.
And so when we launched the product, we made this initial commitment to donate a third of our management fee into the Ethereum Classic Cooperative, which is still something we're doing to this day, and is a lot of the reason we're able to see the cooperative go on to give grants and bring together events like this.
Yeah, and I think that's great. Actually, somebody touched on it earlier about Gitcoin, was the fact that when it comes to actually funding these things, it's very, very difficult to find money for it. So I think it's great that Grayscale was able to provide this money to the ETC Cooperative, no strings attached, and we went and did what we thought would be best for the community with it.
Sure.
So yeah, thank you very much. And you mentioned earlier there was a paper you published in 2017. How do you feel ETC has changed since then in your eyes, as somebody not from the dev side, but more from the financial side?
Why, I don't look like I'm from the dev side? So I think it's changed a lot. I think there's ongoing talks within a lot of the different developer communities about what the right governance models may look like, how many competing teams of developers or different schools of thought should there be around issues like scaling and upgrades to the network, mining, things of that nature. And I think what's been really great around ETC is to kind of see that development community continue to flourish. And certainly in the wake of other communities like Ethereum, which, let's be honest, have had a lot more money thrown at them and a lot more time and energy thrown at them. And from our perspective, it's been fantastic to see, the Ethereum Classic community kind of rally around the somewhat limited resources it's had over the last couple of years.
Yeah.
And I think
I'd agree with that. And I would also say, too, that having limited resources is certainly a struggle, but sometimes having limited resources is actually better than having too many resources. We see in a lot of projects today where they end up with too much money and then they don't know what to do with it, and a lot of it gets wasted. So I think ETC's hit a good middle ground there.
For sure. And then I think, certainly an event like this, for those of you, if this is your first time coming to an ETC summit, this is actually the third time this event has taken place. And so the idea of bringing together the community like this has been really fantastic over the last couple of years.
Yeah, absolutely. So then for ETCG, can you just give kind of like an overview of the product? Like, how does it work? What does somebody do to get ETCG?
Yeah, so basically anybody who has access to US securities can buy and sell shares of ETCG in their brokerage account. But what I would actually kind of impart on this audience, and certainly something if folks want to do, is they can actually take Ethereum Classic they already own and contribute it into the fund in exchange for shares. And the nice thing about that is you're continuing to maintain your exposure to Ethereum Classic, but you're actually doing so and simultaneously supporting the Ethereum Classic Cooperative, because a third of the management fee goes back to the organization that throws this event. So folks can feel free to get in touch with us on the Grayscale website. I'll be around today. My colleague Ray is here as well. Happy to chat with folks about doing that.
And so that kind of brings us into the next topic, which is when it comes to accessing cryptocurrencies, there's a lot of things to overcome. There's custody, there's wallets, there's a lot of other management tools and techniques you have to do. It sounds like ETCG might do part of that. Can you just go into like what the challenges are from a more financial perspective when it comes to this?
Yeah, I mean, I think today we're kind of breaking down the lack of, I guess, call it infrastructure at a high level across a couple of different, call them verticals. So the first is certainly custody. Custody of any digital currency, Ethereum Classic or otherwise, by and large is outside of the traditional financial players and legacy players. It's great to see folks like Fidelity, launching Bitcoin custody, but it's going to take some time for other legacy players to offer custodial solutions, and that either will mean they're either acquiring companies who have launched custodial services in the space or partnering with them. And until that happens, happens, I think there's a really ripe opportunity for the digital currency investment community to continue to gain exposure through places like Ethereum Classic, Trust, and other access points as well. I think besides custody, we also look at things like order management systems and trading systems. There's been no shortage of entrepreneurs that have launched different types of exchanges that have certainly been susceptible to hacking or theft or things like that. But as the ecosystem is continuing to mature, we're starting to see better and better tools available to investors so that they have much better oversight of how they're gaining exposure to digital assets. But again, entirely outside of that existing infrastructure when it comes to stocks and bonds and other areas where investors are getting exposure. And then something that I'm sure everybody in this room would love to see a better job of having access to is things like tax reporting and tax lots and being able to manage positions and things like that. So there's certainly some firms that are coming up in the world that are starting to develop the right tools that can help investors deal with that. But again, it kind of just speaks to how early we are in the evolution of the asset class and again, why there's tons of opportunity.
Yeah, absolutely. There's still quite a lot left to build
For
every
sure.
dimension of this. So then generally, I guess you were kind of touching on the fact that Wall Street or some of the larger investment groups might be starting to move into the space. Why do you think they will, and why do you think we should care if they do or not?
How much time do you have? So legacy players are moving into the space because the asset class isn't going away. There is ever-growing demand from the investor community for access to digital currencies. Even just being here in Vancouver the last couple days, we're turning down meetings with some investors because we don't have enough time to run around and kind of see everyone. Everyone kind of wants to understand what the benefits of adding digital currency exposure to their portfolios may be. And so I think legacy players don't want to miss out on how this asset class is going to evolve. They don't want all those assets hemorrhaging out of their existing platforms and moving over to Coinbase and kind of other startups that have done really, really well and created these really unique user interfaces for folks. But it's important. It's important that we're all supporting the build out and the infrastructure around the asset class. I think if we don't continue to see greater liquidity in these assets, then all of the business models and all the services that are being developed around them, we're just not going to be able to kind of see a lot of them come to fruition. And so I think one of our big missions, and certainly something I think we should all be tasking ourselves with, is really evangelizing the benefits of this and kind of what this really represents as we're kind of moving into this much more digital age and moving away from kind of this physical world where maybe different notions around money and things like that may have existed.
Yeah, that's interesting. So you mentioned that we need to grow liquidity in this space because otherwise, what's the negative outcome of that if liquidity for Bitcoin and ETC stay the same?
Well, so I think the liquidity and just more capital in the space in general kind of creates this, call it almost like a snowball or a flywheel effect, right? If the monetary base inside these assets is larger, the velocity is greater, it starts to lend itself to a lot better, applications. People tend to make money. They're then able to kind of spend it. And then that's really when you kind of start seeing the ability for more applications, things that may not really exist well within the existing financial infrastructure, really start to take place. And whether that's different things that Ethereum Classic lends itself to, like smart applications or whatever else, IoT applications or things that Bitcoin may be working on, which may be more like a store of value or payment mechanism.
Yeah, that makes sense. So then what do you think is keeping other investors back from actually testing out the waters in this space?
Let me start by telling you what's not preventing them, which once was. There used to be a hesitation around the headline risk or the kind of reputational risk that may be associated with investing in digital assets, that's totally been shrugged off. That's never part of these conversations anymore. The idea of maybe using digital currency for the dark web or something like that, that's not the kind of stuff that investors are skittish on anymore. I think what investors are probably most impatient for, and it doesn't necessarily always lead them not to invest, is the idea of regulation. So I would say generally that we're proponents of seeing greater regulation in the space. It will lend itself to credibility and validity of the space, give us greater oversight of kind of what constitutes a security and what does not, and other areas that could use a refresh, things like taxation, things like that. I don't think that we're going to see any regulation anytime soon that is going to cause us as an industry, hopefully, to slow down at all. I think the issue that we're experiencing now is that the industry is moving so fast that regulation and regulators probably just can't keep up with the pace at which we're all moving. And so I think a lot of investors are hoping to see greater clarity around regulation. And if anything, that's probably the most frequent thing that we hear from folks that may be preventing them from maybe allocating to the space.
When do you think we might see more clarity? I mean, I know the SEC just released some judgments, and from what I read from the various lawyers that I follow, it seems like it's still very unclear.
Yeah, I mean, I think when the kinds of judgments that we're seeing, I candidly am not as familiar with the approaches that regulators have taken in Canada, but certainly in the U.S., I'd say regulators have been pretty active and taken a pretty proactive stance on coming out either with judgments or enforcement actions and trying to kind of establish where those lines are going to be drawn. Over time, they've also done a good job of kind of developing these regulatory task forces that are really staying on top of developments in the space. So hard to say. If I had a crystal ball, I don't even know if I could predict how long it'll take for more regulatory clarity, but I think certainly they're definitely signaling certain things through some of the judgments that you're seeing, recent events.
Yeah, I think that makes a lot of sense. I personally hope to see more clarity and actually see this, this whole ecosystem grow, because it is so small, and we focus a lot on development, but there are other aspects to this that need to fall into place, because otherwise I don't think anything will come of it.
Sure. Yeah, and listen, I think that we as a firm, some folks may kind of balk at the idea of our taking assets which kind of otherwise may want to, or in their ethos want to exist outside the existing financial infrastructure. But I do think we're playing a really important role in helping to ensure that these types of networks continue to have funding and are secured and can kind of continue to have the runway they need to flourish. With just kind of circling back to the beginning of our conversation, with Ethereum Classic and the product that we've developed for it, that product now actually owns, for its underlying shareholders, more than 7% of the ETC outstanding today, and growing. So, we certainly think we're doing our part to kind of, move that money back into the community so that we can continue to see things go.
Yeah. Absolutely, and it just occurred to me, obviously ETCG and the rest of them, they're a custodial solution. So you don't have your own keys, but do you think there are any investors out there who maybe they put a portion of theirs towards ETCG and then they hold some themselves so that they can still believe in this, in our ethos, without having to deal with all the tax implications and all the...
Sure.
Yeah.
We definitely encounter investors that I think want that tangibility, so to speak, of owning some Ethereum Classic outright or some Bitcoin outright, and in those senses may want to send it to a friend or give it as a gift to somebody so that they actually have that real world experience of broadcasting a transaction, seeing it hit a blockchain, seeing it get confirmed. And so it's nice when we kind of have those encounters with investors where they're kind of doing both, both making a kind of a core investment as well as wanting to have an experience with the underlying tokens directly.
Yeah, great. So I guess that mostly wraps up our fireside chat. Do you have any closing statements?
Closing statements. Well, one, I'm happy to take any questions from anyone. I know this is a fireside chat, but if anyone has questions, happy to answer them. Sure.
I'm not presently at the ETC co-op, but I do know that Yaz is their one developer relations who's currently working on a lot of projects.
Join the fireside chat, Bob.
May wanna...
I would love to hire more people if I had more budget. Give us money and I'll hire people.
Yeah, I mean, I think at its core, the idea for the cooperative was to support development around the ecosystem. So certainly.
So I've been tracking the ETCG fund, and I've actually been mapping it on top of the price of ETC. It's really interesting because it's always gone between like 2 times the value to almost 4 times the value. And I'm kind of curious, how does ETCG decide, okay, we're going to acquire more Ethereum Classic to kind of like equalize the price so that, you know, the ratio is sort of kept intact? And is that sort of a public process?
Yeah, so that's a great question. So the way that the Grayscale Ethereum Classic Trust acquires additional Ethereum Classic and the share count of the fund grows is when investors are deploying capital, be it cash or ETC contributed into the fund at its daily net asset value. So if someone wanted to, drop $100 into the fund on a given day, they actually must qualify to be an accredited investor, which we can follow up on, and then that way the fund will actually grow by that $100 worth of ETC on that day. On the public side, a year later, once an investor has owned their shares for a year, they're actually then able to sell their shares out into the public market as ETCG. And so ETCG represents the secondary market for shares that are created through that private placement. As you mentioned, yes, ETCG has historically and still does today trade at a premium to where Ethereum Classic is actually trading. We don't trade ETCG, meaning that we are not involved in where the market is creating buys and sells of ETCG. It's always going to be dictated by market forces. So if ETCG is trading at a substantial premium to the actual underlying Ethereum Classic it holds, that is representative of where the market is willing to buy or sell the stock and is more likely than not a function of supply and demand. There not being enough shares available to meet the demand of investors wanting to transact in the security. Yeah.
Any thoughts on what the OSC is doing in terms of approving Bitcoin tracking stocks, like what happened with First Capital?
So I'm not as familiar with that particular filing, but what I will say is, again, kind of what we know in our interactions with regulators in the US, being a New York-based firm, is their stance has been really proactive. We engage with them quite a bit. I would say in the 3 to 4 years that we've been spending time in DC, the level of education on the other side of the table through these meetings has just gone parabolic, and it's a matter of when, not a matter of if, but hard to say how long that when will take.
Basically, First Capital thinks that the OSC is going to approve the fund and that the SEC is going to follow suit.
We've also, to that point, spent time in other jurisdictions around the world. For better or for worse, probably for better, a lot of other jurisdictions are actually, in many cases, sounds like they're waiting to see what the SEC and what American regulation ends up looking like around the asset class. But again, we're in the early days, early innings, so we'll wait patiently.
Hey, Michael. I have a question from YouTube. At what stage does Grayscale consider investing in tokens? And what is the criteria before they consider it?
Yeah, sure. So today we manage 10 different products that span everything from Bitcoin and Bitcoin Cash, Ethereum Classic, et cetera. I think the willingness of Grayscale to launch a new product around either an individual token or, in the case of our diversified fund, which holds a basket of digital currencies, it's really, for us, a kind of a delicate balancing act. On the one hand, we're constantly looking for tokens that are what we think are investable and present good opportunities for investors. On the other hand, our eyes and ears are always open from our investors and always want to hear what folks want to be able to have exposure to through the form of a security. So I know that doesn't give exact criteria because there is no exact criteria for it. But certainly there are always going to be some overlays, things like, are there sound custodial solutions that we can leverage if we do in fact support a product? Is there an addressable market that we can access? Is there fair and transparent pricing for a given token, which again would lead to being able to support a product? If folks have ideas or other areas of the digital currency realm that we're not currently offering exposure to, certainly encourage you to reach out to us on our website, on Twitter, kind of whatever works for you.
Hi, Michael. Are there any catalysts or narratives unfolding at the moment in the mainstream that you see as compelling reasons for investors to own this asset class?
Yeah, I mean, at the moment, I think one of the most compelling things is certainly something that we're part of driving that narrative is around this generational wealth shift. And so what we're watching is over the next 25 years or so, you're going to see probably about 60 some odd, maybe even close to $70 trillion worth of wealth move from older generations down to younger generations, millennials, Gen X, Gen Y, from baby boomers. And so what we believe is that most of the investment community is not really looking closely enough at the way those assets are currently postured, and are they sitting in things like gold and other assets that perhaps aren't going to resonate as well when they get passed down to a younger generation. And so from our standpoint, we certainly believe that digital currencies are going to be one of the beneficiaries of that generational wealth transfer. How fast that happens, we don't know, but certainly something that is causing people to look kind of out into the future and see how portfolios may rebalance over time is certainly a narrative that we're in a conversation we're having with a lot of investors.
ETCG must be holding between 7 and 8 million ETC, according to what you said. Where is the custody? And also, what is the mix, more or less, between individual and institutional investors?
Sure. So the Grayscale Ethereum Classic Trust custodies its Ethereum Classic in the Coinbase Custody Trust Company solution. So all of the assets are held in trust. This is a New York State chartered trust company. All the assets are held in cold storage. They're also all insured. And again, they've developed a really robust system for institutions like us to be able to hold assets on behalf of clients. I'm sorry, what was the other part of your question?
What is the mix of ownership of ETCG, individual and institution? If you know.
Off the top of my head, I could probably follow up with you and give you a more precise answer. What I can tell you is over the last 18 months, I would say that the mix of assets that we've been raising have skewed towards institutions, probably to the tune of 80+% of our asset raising is coming from institutions. So it's hard to say.
Great. Well, thanks very much, Michael.
Thanks. Thank you.
Thank you.
Thanks.
Thank you. Thank you. Okay, so next up we have another friend from ChainSafe, also from the wrong side of the country, from the center of the universe, which all Canadians will know is what people who do not live in Toronto say about Toronto. So from the center of the universe, we have Aidan.
Thank you. Well, thank you for having me. I thought Canadians were nice, but I guess I was wrong. I'm just kidding. Thank you so much for having me here. It's such a pleasure to not only be looking at this beautiful view while you're all turned the wrong way, but also to be a part of my first ETC event of any kind. Yeah, so this is awesome and this is exciting, meeting a lot of people that I've only ever communicated with on the internet, so it's kind of cool to see those people IRL. But yeah, so I'm going to talk a bit about ChainSafe, who we are, what we do, how we started, and then also I'm going to talk a bit about what we're doing and the things that we're working on that are a little bit more relevant to ETC and just EVM-based blockchains in general. And I'll also mention a bit about kind of how we even got to ETC, let alone ETC Summit. So yeah, hello. I was supposed to have that slide on. So yeah, a little background on us. We started at an Ethereum developers meetup in Toronto. It looked like this. It's the only picture I could find of it on the internet because I just didn't care to take a picture at the time. And so yeah, this is where I met my partners, or at least most of them. It was a regular meetup that happened. I mean, this is a big one with a lot of people. It was usually, like 10 of us. Scott was there and a few others from Toronto. And yeah, it was just a place for us to have fun, think about things, and see, can we experiment together? And that's really where ChainSafe came from. It came from a local community meetup. And so this was the first space where we actually rented our own little office. And by rented, I mean we would, book space in the public library and then go and meet there and say, yeah, this is our office. So that was really cool. And it was awesome because it was, we're building open source stuff, we're building things for the commons while taking advantage of our, amazing public institutions in Canada. And so this is one of my partner's apartments. This was our real first office. In his living room is where the real magic happened. And then this was our first real office that we paid rent for. It's right next to our office now. And so this is a picture of our Ethereum developers meetup that we now co-organize. The same thing that we found each other at, we now kind of, with the help of people like Scott, are now bringing that to others. So it's a real privilege to be able to not only kind of be a part of that grassroots community, but to then give back to it and actually create the space that gave us everything that we have today. So what are we doing now? These are kind of major projects that I'm just going to highlight, and then afterwards we'll talk a little bit more about ETC specific. But yeah, for now, so yeah, just going backwards, just one note. These are in the order in which we started them. No one here is a favorite. We love what we do in general. So Lodestar is a TypeScript implementation of the beacon chain. So yeah, it has incredible tools that we've built out to make this work. The beacon chain, for whoever doesn't know, is phase 0 of ETH 2.0. Very recently, we had an incredible milestone achievement where we were able to interoperate with a bunch of other clients. And so that means that all the code we've been working on for almost a year now is not garbage and actually really good. Oh, thank you. And so this is a really exciting milestone because, you run spec tests and you run all these different things and they work, but you don't get to see it, right? You don't get that validation, no pun intended, of actually seeing these things talking to each other. And so, yeah, this just happened and it was really, it was really an incredible moment. Gossamer. So Gossamer is a Golang implementation of the Polkadot runtime environment. The Polkadot runtime environment is basically, if you're familiar with Substrate, Substrate is also a Polkadot runtime environment. And what that really means is it's kind of like the base that you would need to then build a parachain. And so a parachain is a blockchain compliant with the Polkadot ecosystem. You don't, however, need to use this framework per se to build a Polkadot blockchain or a parachain. You could build whatever kind of blockchain you want with it. So it's all the little pieces that you would need to build that. So, it has the networking all there, everything basically there that you would need. And so go Ethereum. So we implemented the Atlantis and Agartha hard forks into Go Ethereum, Geth Classic, which was not necessarily the easiest thing in the world. It was a code base that had been left for a long time. As Afri talked about earlier, there weren't really test nets that existed for us to test this. And something that he didn't mention that happened in the Morden testnet was that there was an issue because of the nonce, the starting nonce. And so, we thought, holy shit, critical consensus issue, what's going on? Oh, turns out Morden nonces are different than everyone else. And so, these are real kind of problems that arise because you aren't the person who wrote this code and built this client from the ground up, right? And so, one of the things that I want to highlight here is that open source is only, and interoperability is only as useful as it is usable, right? If we can't work on these things and collaborate with each other because there's a gatekeeper that wrote this, wrote all of this, it's never going to scale and it's never going to work for most people. So we really need to check our egos and work together to make these things happen. Ethermint. Ethermint is Ethereum on Tendermint using the Cosmos SDK. And so what that basically means is that we're taking the EVM, turning it into a Cosmos SDK module, and then eventually it'll be created into its own zone that hard spoons Ethereum. But what I think is even kind of more usable to developers is the fact that the EVM will be a module. So you as a developer can take your dApp and scale it into a Cosmos zone that has optimizations perfectly built for you. And this will complement your dApp on Ethereum Classic, or whatever. These things can work together, not necessarily just against each other, as we all kind of usually expect. We're really proud to be recipients of grants from all of these incredible organizations. Again, this is in order. The Ethereum Community Fund, the ETC Cooperative, the Web3 Foundation, the Ethereum Foundation, and the Interchain Foundation. Without these organizations, we would have no work to do. And these are some of our clients that we've worked with. So how did we kind of get to this place? How do you start building blockchains? It's kind of like an abstract, weird thing to do for a living. So around 2 years ago, we started looking at implementing sidechains. And so what's a sidechain in the Ethereum context? Because in the Bitcoin context, this means something different. This usually means merge mining and all these things. But in the Ethereum world, it usually just means that you have a fork of Ethereum that's optimized for a specific use case, and then you bridge that chain over to ETC or the Ethereum mainnet. And the reason for doing this is to allow for your application-specific optimizations to be realized while also kind of allowing you to then utilize this token or whatever across a multitude of chains. This is a bridge. You can think of deposit and withdraw as just contracts, and they could kind of go the other way as well. And the bridge instance is sitting somewhere, could be in the cloud, whatever, and it's just monitoring these contracts. So it's a pretty simple design that has been around for 3 years. It's been implemented, 3.5 years. People have been using it. 3 years. It's a bit different than a relay. These are things that have been around for a long time. And so what do we have to do to build these Ethereum sidechains? And how did this kind of, how did we start building blockchains starting with this, right? So we would fork Geth in a lot of these projects, potentially parity, but mostly Geth. And then we would utilize the parity bridge, which was the first kind of piece of software ever built to bridge EVM blockchains. And eventually we realized that people don't like Rust, regardless of what we thought. And our kind of perspective on the future of programming, I guess it just didn't matter. Again, we had to check our egos and realize that we were building things for people and not subject matter experts. And so Chainbridge was born, which I'll talk about a little bit at the end. But basically, it's just a Golang implementation of the parity bridge. And our clients were really happy with that. It wasn't that much work. And just like that, we made something like a bridge really usable for people. And then they would always want some weird consensus mechanism, so we would try and do that. And so what did we learn from building these Ethereum sidechains? Well, firstly, we need more modular blockchain components. We need clients like Pantheon, which are built for not only just public blockchains, but also for, unfortunately, enterprise applications. And the reason I say that is because, well, not the unfortunately part, you know why I said that. But the reason that matters is because in enterprise use cases, they'll have their own consensus, they'll have their own requirements. And so, you know, these clients made for those purposes are actually built in a more modular way because they assume that people are going to take this code and do stuff with it, right? When Geth was built, it wasn't assumed that someone would fork it and go make an application-specific blockchain, right? It was made to be a public, decentralized, or generalized smart contract platform. And so, you know, finally the technology is starting to actually be at a point where I guess it makes more sense to do certain exciting things. Plus, you have all these incredible frameworks like the Cosmos SDK, Gossamer, and what have you. And for one of the projects, we worked on a sidechain for over a year, added opcodes to the EVM, had to then go justify that all the way up the stack. And from this over a year of work, dealing with, like Geth, SolC, Solidity, Remix, the only upstream PR that we ever had was adding Control S to recompile in Remix as opposed to saving your browser. I don't know if everyone remembers Control S used to save your browser. Well, thankfully, after a year of work, we were able to fix that. The reason I bring this up is because it's really important to note that the point of open source is not to feel really good and to market this as something that's free for people to use so you can go and do whatever you want to do from a business perspective. The point of it is for people to decide together on standards that we can, as a collective, contribute towards because these are common goods that provide us value that's beyond zero sum, right? Linux doesn't exist because a couple of hippies wanted to build an operating system. It exists because large enterprise has decided that it makes sense economically for them to support this thing. And that's something we really need to appreciate. And it, again, requires us to check our ego at the door to be able to actually take the next steps that are required to take this technology to the world. And on that note, interoperability is only as useful as it is usable. And what I mean by that is that technically I can do whatever I want. But if I can't make this in a way that's usable by other developers, if only subject matter experts can build with this technology, well, then who are we really building for? And will anyone ever use it, right? And you know, we're all I guess one of the biggest questions I get asked is when decentralized Uber? When decentralized Airbnb? And my answer to that usually is, well, I can't even explain to my friend in 5 minutes how he can get started or they can get started building a dApp because, you know, they would need to basically come work at our company for a couple months before they could do anything. And that's kind of a problem that we don't really address. We don't really address kind of the barrier to entry that it takes to build something on the blockchain today. Now, it's one thing to go build a smart contract, a single smart contract, and then a shitty React UI and call it a dApp. But it's a whole nother thing to go interact with state channels, plasma chains, and a whole magnitude of incredible technology that's available today. I mean, most people think that Ethereum right now cannot scale, but that's just not true. Like, we're working on ETH 2.0, and let me be the first to tell you that Ethereum has scaled already and has been scaled for the past 6 months to a year because state channels and plasma chains have been available this entire time, yet nobody has gone ahead and used these things, right? And to me, I think that just indicates how much the barrier of entry is to using these technologies. And if that was kind of diminished, anyone would be able to build anything, right? Isn't that the point of decentralization? And so how did we begin contributing to and collaborating with the ETC community? Because it kind of started one place, it went to another, and now they're both happening at the same time, which is awesome. So it all began with Gurley and Cody. So we kind of briefly talked about, or Offrey talked about it. This was a hackathon project of ours at ETH Berlin just over a year ago. And this awesome guy, I don't know if you've heard of him, named Anthony, he reached out and wanted to see if there was some kind of potential room for collaboration. He saw that this was something that not only, this is not an Ethereum Foundation mainnet specific thing. This is a problem that exists and persists in our ecosystem, as Afri mentioned in his talk, right? And so yeah, this was our first collaboration, and it was awesome, and it was just so easy to get kind of going together and get to work, which was really exciting for us, because I think within like a month or something we were already working together, which was awesome. And so then we began working on Go Ethereum with ETC Labs, partnering with them, and that's been an incredible journey and has been a lot of fun. Getting to know Terry and Eric and a lot of the developers there, it's been awesome, and I'm excited to see kind of how that journey continues. We have a few hard forks coming up, so we're excited for that. And it's just been great to get to know everyone and to get to know kind of the motivations for why we're all here. I mean, people honestly want the best for this technology, and that's just always fun from a developer's perspective to kind of build towards, right? Build towards like good intention. And so Besu, this is, I think I'm pronouncing it right, I don't know. It's hard. So this was really recent. So this is with collaboration with the ETC Cooperative. So for those of you who don't know, the Consensus Pantheon client got accepted to Hyperledger and got renamed to Hyperledger Besu. And so Bob and Yaz are pushing for ETC support in Hyperledger, which is really cool. And I'll be totally honest with you, from our perspective, something we never expected. I never expected to be contributing to Hyperledger. So it's quite an achievement to actually have that be something that we want to do as Ethereum developers, so that's pretty cool. But we're contributing to Hyperledger, and soon we'll have ETC support in a Hyperledger project client, which is really cool, really exciting. And so that's kind of, I guess, if the major kind of things that we're working on with ETC. And these are just tools that we're currently working on or have already that are either open sourced, or I'll mention that they will be open sourced, that are relevant to any EVM blockchain. So Anemone is a testing tool that broadcasts batches of transactions and tests opcodes. This for us is really important to feel comfortable with not just Atlantis, but other things that we've done. Like, this doesn't exist. There's no integration testing tool available for Ethereum. That's ridiculous. So this is an answer to that need. And you can use it today. Node map. So this is coming out of the Gurley initiative. So this is both voluntary and, I didn't write non-voluntary, but it's dev P2P monitoring. So if you know how dev P2P works, you know it's non-voluntary. And the point of this is that we have a lot of different things going on in the networks. It's hard to understand what's going on from a layer 0 perspective. Layer 0 is kind of the networking side of things. And so this will take ETH stats and take dev P2P monitoring and kind of smash them together into one tool. So you'll be able to not only see what people are telling you, but you'll also be able to see what they're telling you. So that'll be a lot of fun to have out there, and for people to be able to use and to start caring a little bit more about networking, because it's definitely, cryptography is really sexy, but networking never really got sexy. And so Ultralight Beam. Ultralight Beam is a project that 3 of my colleagues, Eric, Cayman, and Greg, are collaborating with Dean Eigenman from Status. So this is something they worked on at ETH New York. And really, for me, is one of the most exciting things, I think, in blockchain at the moment, because it's relevant beyond blockchain. And so Ultralight Beam describes a protocol for sending offline messages that will later be broadcasted through relay nodes. It is a transport-agnostic mobile ad hoc network for sending arbitrary data. And so what this allows you to do, and what their ETH New York, and soon they'll have a presentation at DevCon that goes a bit more into detail with examples. But what it did at ETH New York was allow for someone over here who wasn't connected to the network to basically sign a transaction, broadcast that transaction, and then through Bluetooth, propagate it over there. So this is huge in terms of, for sure, offline transactions. But even more important, you look at what's happening in Hong Kong right now. Well, previously with the Umbrella Revolution, Fire Chat was the tool that was used for people to communicate. So this made mesh nets that allowed people to communicate with one another, completely proprietary. They now use that. They license out that software all over the world. This, on the other hand, is just a protocol. Anyone can use it. Anyone can build on top of it. Any blockchain can utilize this. And it's just for arbitrary messages. So imagine taking something like Fire Chat, generalizing it to a protocol, and then allowing for anyone to build on top of it. So now we can have offline messages from any blockchain being relayed by anyone who wants to be a participant in this relay network. And the best part is, there will never be a token. Chainbridge. So Chainbridge is a modular multi-directional EVM-based blockchain. Bridge, wow, that's long. And basically what this allows you to do is set up EVM to EVM bridge. So basically what I talked about earlier, but just, I guess elaborating on it now would be what I should say. But yeah, so this is a simple piece of software. It just allows you to basically deploy a contract on one blockchain or one EVM-based blockchain, and then on another, and maybe even another. Like you can do 3 or 4 blockchains, really as many as you want. And then there's this kind of piece of software that then monitors these different contracts. So yeah, you could have this be like a POA type system. We've worked on versions of it that have had some gossiping between the bridge nodes, or the bridge instances, I should say. They're not really nodes. So yeah, there's lots you can do with this, and lots that you can fork it on GitHub and do whatever you want with it. So that's basically it for my talk. I've been meaning to change the GitHub thing. It's only github.com/chainsafe. If you care about any of the things I said, please go there and look at the stuff we do. I mean, everything we do is either open source or will be open source when we're comfortable with the code quality. Most of our things do start as ideas that are completely public, so with really poorly written code sometimes. No, I'm kidding. We don't do that. And yeah, so just go there, fork whatever you want, do whatever you want with it. Tell us it's broken, because without you, it's useless, and we're just building for ourselves. So please, if there's anything that this talk gets you to do, is just critique our code, please. Because yeah, there's not very many people in the world who care to do that. So hopefully a few of you are sitting in this room right now. But yeah, that's basically it for me. Thank you so much for having me. Thank you, Bob, for inviting me. Any questions?
Thank you, sir. Okay. So we have our final session of the day. I hope everyone's got a little bit of stamina left, because bring to the stage my colleague, Yaz Khoury, who's the Director of Developer Relations and the other part of the co-op. We are the co-op. We're here. That's it. That is us. And Yaz is going to talk a little bit about that role.
Thank you, Bob. All right. I'm Yaz, or the last man standing between you and happy hour. My talk is Developer Relations in Ethereum Classic, or what I like to call what the hell I've been doing for the past year. I want to get more energy in the room. Is it okay if I take a selfie video with all of you and everyone yells out immutability? Yeah? Let's do it. All right. 1 sec. All right. Let's go. Immutability. Woo! All right, let's power through. So my talk is about DevRel, Developer Relation, as we call it in Ethereum Classic. Basically, what we're going to talk about here is what is DevRel and what are the challenges that we face in DevRel in crypto. And then we're going to talk about all the DevRel projects that we worked on at the ETC Cooperative. All right, so the main important question is, why are developers important? Rita Mayer He's a Google developer advocate. He said that if you have a platform that is benefits from a lot of user adoption, then you want to provide products and services in order to retain those users. Now, how do you do that? You can provide an ecosystem where third-party developers can build those products and services, right? In his example, they're talking about Google, their APIs, their bunch of products and services. But when it comes to crypto and ETC specifically, third-party developers refers to smart contract and dApp developers. So what is developer relations? Does anyone heard of DevRel before? Show of hands, anybody? All right, we have a handful. So back in the 90s, tech companies tried to advocate for developers to use their services or their open source software. They would send marketing peeps over in order to advocate for developers. Now, developers have a high filter for BS. They know when somebody's trying to sell them something, and they know when somebody's not really technical. So what happened in the 90s was marketers couldn't even advocate anything for developers, and developers never trusted marketers. Lo and behold, developer relations was born. The idea was you want to send developers to advocate for other developers. Why? Because developers can get as technical as they can with other developers. The developer advocate and developer relation was born from that. So what are the things that we do in developer relations here? We try to build an awareness of the platform and developer communities. In our case, ETC as a development platform. We also want to create necessary tools and infrastructure for third-party developers to build their apps. We also, I file feature requests, bug reports, tickets on GitHub. I answer questions on Discord, Gitter, and Stack Overflow. We also write documentation, how-to guide when build demo apps. So the TLDR is DevRel is the interface between the third-party developers and the product stakeholders, in this case, people who are stakeholders for ETC. Now, how do you quantify success in DevRel? The problem with DevRel is very hard to measure ROI, return on investment. Why? Because it's an open source software. And you don't measure about how many people clicked on your ad that takes them to your product page. We don't use that. It's a mixture of data signaled online and gut feeling. Like when you go to a community meetup and you try to figure out what kind of, the sentiment of the community, what are the trends? Are people more into mixers? Are they more into Zach's Fly client? Or, a lot of gut feelings involved. The most important online engagement metrics that we care about is how many people are mentioning your product on Twitter, Facebook, whatever. How many people are forking your GitHub repo, adding pull requests, writing issues, and how many people are posting, sharing it on Medium, commenting on it. And the other thing that we like to do is in-person connection. And that's very hard to quantify, but it's equally important. Because, as we said, we try to figure out what are trends in developer conferences and stuff. We also care about what kind of developers are in attendance, are a lot of smart contract devs, a lot of front-end devs working on dApps. Are they interacting with the sponsors for maybe swags or whatever? And we look at the theme. What is the theme of the developer conference going on? And what do developers care about here? What are the challenges in crypto DevRel? DevRel only existed in traditional tech environments, not in crypto until recently. I'm one of the prime examples here. But developers found out that there's when you come to the crypto environment, there's a lot of politics. Developers care about writing code. They don't give a shit about, what kind of politics are going on and stuff. But then, one prime example is Prague POW, highly controversial. And a certain somebody was uninvited from this conference. DevRel as well, you have to deal with market prices and tribalism when you're advocating. If I go to people, let's say in Ethereum or maybe in Tron and trying to advocate, hey, we have this really cool open source developer tool. They'll be like, oh, how heavy are your bags? Which is not everyone, but it is a challenge because people might think you're trying to tie it to a price when you're just trying to do open source development work. And there's a lot of conflicts in the ecosystem that developers are facing and have to deal with. One of them was like, especially when it comes to product stakeholders. Like for a lot of developers, you had to it was a shock, like the DAO fork. Because it was something that was like, it's technical, but it's like split the networks and stuff, and here we are. So now that we talked about what DevRel is, we're talking now about how do we improve the developer ecosystem in Ethereum Classic and what we've been doing for the past year. The areas of focus for the ETC cooperative this year has been 4 categories: data science, developer operations or DevOps, dApps or decentralized application, IoT, Internet of Things. I'm going to go over each 4 of them and what we did. All right, one of my favorite projects is the Google BigQuery one for data science. What I love about this project, it cost the cooperative $0 and a lot of marketing benefit from it and a lot of technical implementation. It came about when me and Anthony decided that we want to quantify decentralization in ETC from a wealth distribution point of view, which is the Gini coefficient. Now, what I realized when I implement that project was there's no easy way to parse ETC data in order to analyze it and get that metric. So the data engineering problem was much higher than the data analysis problem. We found the Google BigQuery implementation of Ethereum, and we got in touch with Google, and we collaborated with them to get ETC as an open source data set that updated every 24 hours in order for data scientists to quantify and run all their queries and analysis on Google BigQuery for ETC. In continuation, just to give you a few ideas of what happened after, ETC dataset is the second most referenced dataset in crypto right after Bitcoin on Kaggle. What that means is we're the second most popular crypto dataset. We provided a lot of example charts and analysis and queries that are being referenced by a lot of data scientists on Kaggle, and for us, that's a win. Now, why did that happen? Simple. We provided a lot of documentation, a lot of code, a lot of open source stuff, a lot of analytics to show you how to use Google BigQuery for ETC. And that for us is great marketing for Ethereum Classic as a serious development and data analysis platform. The second data analysis project we worked on was quantifying immutability. When we had Atlantis hard fork, a lot of developers had issues trying to explain what immutability and how does it get affected when you implement Atlantis. And developers really wanted to just focus on the code. So I set out to quantify immutability, did a lot of research on how do you visualize it to stakeholders. We have an article on it on Medium for Ethereum Classic. So, Google quantifying immutability if you want to check it out, just deeper analytics. I'm in the process right now trying to submit it to journals, try to get it peer reviewed. So it's another example of the cooperative trying to submit original research into blockchain that is, never existed before. Nobody ever tried to quantify immutability before. So what are the future plans for data analysis? We want to focus more on research, decentralization, and chain reorgs topics. We want to submit more original research there. We want to do machine learning models like what Cody was talking about, maybe implement something with ETC, with ML. We also want to do graphical mapping of the entire ETC network with analysis. For example, maybe look at the DAO fork during that time and do graphical analysis. 51% attack would be really interesting. Also, node analytics. We want to try to map out all the nodes by IP address and graphically, and try to see geographically, where all the ETC nodes are. Now, the most important project, in my opinion, which I've been working on, my little baby, Ether cluster. It's under the category of DevOps. So to understand why the Ether cluster is really important, you have to look at Impura. Impura is considered, according to consensus, the secret weapon of Ethereum. They're like the Goliath. Every Ethereum service connects to Impura. Well, consider me David. I threw a rock at Impura. And we provided Ether cluster as an alternative. Ether cluster works just like Impura, but it provides support for Ethereum and Ethereum Classic. And it's scalable, it's open source, and it's designed not to be centralized. Because by open sourcing it and not relying on one cloud provider, you can deploy on multiple different cloud providers, which is much better than what Impura is working on. Let's see. So to give you an idea of project using Ether Cluster, you have Jade Explorer by Zane and Shane Zach. MetaMask, I demoed it working with Ether Cluster endpoint. We got Second State, one of our sponsors. They have the BUIDL IDE, which uses Ether Cluster. Two Impura competitors came up to me after we released Ether Cluster to tell me that they're going to reference our open source design to compete better with Impura, which is, for me, that's the win. You know, like if you find it valuable, use it. We have a lot of DevOps and DApp developers that are, engineers that are interested in, adding more tools and like better support for Ether Cluster. The other one that we collaborated on with Afri and Project Gorley at the same time with White Block team was the Nazgul project testnet, which is like Afri was talking about, like a stress testing Atlantis compatible hard fork testnet at ETH Berlin for ETC. It's probably going to be used for future testing ground for multi-client hard fork and consensus testing. It's going to be useful when you have Agartha coming up later and other upcoming hard forks to make sure there's no consensus breaking changes. For dApps and smart contracts approach, we provided a lot of guides for deploying and writing your smart contract to ETC. We also demoed how to run Kali testnet and deploy to it. And now you can use the latest Solidity version with ETC, as we demoed in one of our guides. Future plan for dApps on ETC under the cooperative. We want to work with decentralized oracles, like maybe dApps that are using Chainlink. We want to focus on mixers and anonymity using dApps. Maybe a fun social dApp like the token coin registry, the CCR. And maybe want to add DAOs for fun experiments, like maybe a DAO for Donald McIntyre. So the idea here is like the more we try to collaborate on open source tools with other services, the more you have access to third-party developers and people can understand that ETC is a serious platform for development. IoT, this is supposed to be a GIF, but like, I guess not being played right here. We built a guide for Raspberry Pi running on ETC for IoT. The future plan that I want to work on is a robotic project that would write to the ETC network. Now, my background has been in robotics before I started software. I would love to build some sort of robot project that would just like, write whatever to the ETC network. Examples of cross projects. Project Gorley Kali, which we funded originally at the cooperative, now runs on Ether Cluster. We also, the Peace Bridge uses Ether Cluster and Kali testnet. Now, why do we care about all that? Because we try to find like different projects that we work on that can or fund that can actually, benefit from one another. And that's like a good, signal for us. Hyperledger Besu, when it's finalized for ETC, will be running on Ether Cluster. Like, what is the outlook in summary for the future cooperative project? We want to improve Ether Cluster, add more features. We want to build more dApps. Another idea I had is like maybe build a reference dApp for cybersecurity, like make it very exploitable in order to improve dApp security online. We want to do more data analysis and research and robotics and machine learning with ETC. For community and developer outreach, we're going to go over what we did from that end this year. So we attended 2 hackathons. When I mean attended, not just like show up, like I actually sat down and coded with people. 2 ETH Berlin and AtCon in Sydney. What I realized was that there's a better reception among developers to ETC once they realize that, from a technical point of view, ETC is like the same as ETH1X. The other conferences we attended, sponsored or spoken at, Anthony and I, we were at a panel at the Atlanta Blockchain Conference. ETH Berlin, I gave a talk about quantifying immutability, and I was a judge at the hackathon at ETH Berlin. ETH Denver, Bob was there to give a talk. At Con Sydney, I gave a talk. The ETC meetup in Xiamen, China, with ETC, in collaboration with ETC Labs, I gave a talk over there. And then I gave a little, what do you call it, like a tutorial on how to deploy your smart contract to ETC in San Fran with ETC Labs. So the future of that is we want to give more conference talks, obviously, about ETC development all over. We want to sponsor more hackathons. We want to hack with other devs at hackathons on ETC projects, and we want to do more meetups. So in summary, we at the cooperative, we had a good year, successful DevRel project and outreach. There's more development, new dApps, cutting edge projects. We want to do more infra, improve Ether cluster, and more community outreach with sponsorships and talks. Thank you. If you ever want to reach out to me, here's how you can find me. I'm available. More than happy to get any of your questions later or anything. Thank you.
You can wear that. Put that around your shoulders. There you go.
Oh, Canada. All right. Anyone got any questions? What up, Anthony?
What's your ideal DevRel project? Like, if you had no limits, what would be your favorite projects to do?
Like something like I want to actually I can build any robot project you think of. My problem is budget. Like, how much can I get away with? Like, I can get you a walking clone of Anthony robot, who's connected to the ETC network. But seriously, I think robotic would be really interesting with ETC. But like the problem is robotic project, hardware is really expensive. You need to pay a lot of money for hardware for prototyping and all that. But yeah. Anybody else? Yeah. Zach. It's not working.
Just for the Ether cluster thing, like how is that intended to be used? Would that be like if I'm a dApp developer and I want my users to point to that instead of Infura? Or is that something like as a user, I would go into maybe my like Nifty wallet or some sort of wallet software and point my wallet at my own cluster that I make myself?
Right. So Ether cluster right now as an endpoint, it is centralized. And the reason we have an endpoint to begin with is because we want to demo it. But Ether cluster, the main innovation is the design specs of open source DevOps scalable blockchain infrastructure that, Impure never open sourced their backend, right? So the idea is we're providing an endpoint for you, but if you find that it's not enough, like you have a lot of users, you need more of your own thing, we have the entire design spec for you to use on your own, for your own, dApp and stuff. And for wallets and stuff, running your own Ether cluster might be really, overkill because by default you're running minimum 3 nodes, So
Right,
I think it's better
just
to
use my local. I just
you just run it locally, right?
Rather than deploying a bunch of nodes. Okay.
Yeah, but locally you just run one node locally. But Ether cluster is more designed if you have a lot of traffic and stuff, and it's designed in a way that'll be cheaper than probably using Infura. At the same time, I know Infura uses AWS. We have Google Cloud, but we're opening it for AWS. So a decentralized component would be having multiple cloud providers running Ether clusters. So if one data center breaks down or something, at least you have Google Cloud and AWS running and stuff.
Gotcha. That makes sense.
I mean, something I'm thinking just popped into my head that could be a use case is if in the not too distant future we get Bezu running within Ether cluster, whether that's in ETC or in F mode, what you could actually do is if you're a business who wants to have a private or consortium chain within their own data centers, you could run that completely behind firewalls and so on. Really what you're providing there, I guess, it's a bit like sort of an OpenStack kind of scenario of saying, well, hey, you want to run a cluster of machines, here's the answer.
Even for like testing, like let's say I want to like the chain safe product, and I forgot the name, but like
Nazgul?
for
Nazgul?
No, what was the
Did like batch
transactions? Like the testing, an enemy, right? Like for example, an enemy, we can like easily deploy something like that on Ether cluster and maybe have it for multiple clients. So if you have an upcoming hard fork, we would have it on Ether cluster, 3 different clients communicating together and try to, jack up all the transactions to the point to see if you can break it and if there's any consensus breaking problem.
I mean, I think the problem that Infura have is how on earth do they get anyone to pay for Infura, ever? It's basically being provided as a free service and is just scaled up to astronomical levels because people are obviously going to use it because it's free. Like, who would not want that? Mm-hmm. But then how on earth do you turn that into a business that people will pay for? So, I mean, I think what we have here with Ether Cluster is, yes, we can run some convenience bits, but, we're never going to scale that to Infura's size, both because it would be a stupid waste of money for us and because it encourages that centralization. Mm-hmm. But what we can provide is saying, if you have a need for more, for more coverage, here you go, run the machines yourself. That really that needs to be a built-in part of a business model. If somebody is building things on top of a public chain, well, where are your nodes coming from? That has to be an intrinsic part of your calculations. And if you don't have an answer for that, other than free riding off Infura, you don't have a business.
That's true. And I think Infura's main weakness, they're only committed to one chain. So by that definition, it's tough for them to monetize anything, right? And Ether Cluster, now we have support for Ethereum. And so that's like one other reason we're better than Infura.
Can we do an expanse chain?
Sure. I mean, like
an Ethereum social chain, a music coin cluster.
We can do anything.
There we go.
All right.
We love all the Ethereums.
We love all of them. All right. Anybody who has any more questions? No. Okay. I don't know if you need
Thank
it.
you.
Thank you.
No, that's okay. I'm not going to hold you up. Let's go and have some drinks. Cheers.